Hello and welcome to a very special video where I'm going to be showing you how to create a competitive multiplayer game in Unity using Unity's Netcode for entities. In this video, I'm going to be going over the whole theory of Netcode for entities, as well as showing you the complete process of creating this game that you see playing behind me, which is a multiplayer MOBA game. So before we get into it, I'm just going to start with a quick overview about the structure of this video, because as you can see, it is quite long. Now, I don't expect everyone to watch this through in just one sitting. This might be something that is best to just kind of bookmark and come back to it over the course of a couple of days, because we're going to be going through a lot of different things in a relatively short amount of time for, how much things that we're going to be going over. And of course, there are timestamps down in the description of this video if you need to jump around to different sections as we go through things. Now, I'm going to be starting off with a general overview about network for entities and some of the basic networking concepts that Netcode for entities provides us. And then I'm going to be going into some of the specifics throughout the course of this video as they become more relevant to the things that we're going to be creating at any given time. And then as far as the actual game goes, the main things that we're going to be getting into is first is going to be showing you how to actually enter the game. How do we create these client and server worlds, and how do players actually join into our game? Once our players are joined into the game, I'm going to be showing you how to synchronize movement across the network so that every player basically controls their own champion, and all that input data as well as translational movement data is synchronized across the network. And just these first two sections are going to be actually about the first hour and a half or so of this tutorial. And if you just want a very basic introduction into Netcode for entities, I would highly recommend at least just going through this portion, because again, it's going to show you the basics of setting up the client and server worlds, as well as synchronizing some basic amounts of data. Now, the rest of the video is we're just going to be doing more repetitions of a lot of Netcode for entities concepts and getting into some kind of weird edge cases that you'll run into as you're creating an actual game project. So I think there's a lot of value in the latter portion of this video where we start getting into things that you would actually encounter if you were creating a full game project with this. Now, to get into some more of the specifics about what we're going to be doing, I'm going to be showing you how to create a full combat system where the champions have the ability to actually send multiple types of attacks into the game. And then we're also going to have some NPCs which can attack other players and things in the game. Now, some of these NPCs are going to have some basic logic that allows them to walk around and attack throughout the world. And I'll be showing you, of course, how to do all that. And then towards the end, I'm going to be showing you kind of like the actual game flow, which is where we get into a little bit more of the kind of, specific management of things that you might need to consider when you're creating a multiplayer game. So, ensuring that we have the correct number of players in the game to actually start the game, and how do we actually, just add kind of some of the, the plumbing of the game flow logic and all that. And then the very last section of this video, I'm going to be showing you how to actually spawn a thin clients into your game so you can have kind of some fake clients connect into your game, so you can do a little bit of testing to see how the game functions with, say, up to 10 players, even if you are just testing by yourself. Now, real quickly, I just want to go over some of the prerequisite concepts that I would highly recommend that you're familiar with before following along with this video. I mean, of course, you can follow along with this video with no experience of any of these things that I'll be mentioning. However, you might be a little bit lost as to why we're doing things in particular ways, because it is using Netcode for entities, which is based off of Unity's entity component system. And with that, I would just say that this is absolutely not a beginner's tutorial. So first off, you should have an understanding of some networking basics. If you understand kind of some of the general concepts about clients and servers, IP addresses, and ports, that is going to be pretty much all you need to understand what I'm going to be showcasing in this video. Next up, you definitely need some experience using C# and Unity development. If you don't have any Unity experience at all, there's plenty of good Unity tutorials available online, but I expect everyone to have kind of some level of knowledge about, creating prefabs and managing assets and understanding value types and reference types, because I'm not going to be, explaining those things throughout the course of this video, because those are what I would consider pretty common knowledge for something like this. And then finally, you should also have some familiarity with Unity ECS. Unity ECS is their entity component system, which is a completely different way of creating games than the traditional game object and mono behavior workflow. I have a bunch of tutorial videos on my channel kind of going over a bunch of these concepts. One that I would point out is I did a full ECS 1.0 tutorial video where I show you how to create this little zombie simulation. That was kind of a fun thing to do. That is just kind of like a good overview about how how to create a project using Unity's ECS. Now, Unity itself does have some good sample projects and other things to learn if you don't have any familiarity with Unity ECS at all. I would also recommend checking out CodeMonkey's video that he recently did. I think it's about an hour or so long, just kind of going over the basic concepts of ECS. Again, I'm going to be showing you exactly everything that you need to do. I'm not going to be like skipping over portions of code or anything like that. However, again, I'm not going to be, constantly explaining what I would consider more basic concepts of Unity ECS, but I will provide some additional context to things as I go along. Also, if you are just interested in data-oriented design and ECS in general, I would also recommend checking out our weekly live show that we recently started called the Hot Path Show, which airs every Friday at 1 p.m. Pacific time. It's a really fun live show where we talk about solving problems in game development using data-oriented design. Now, for software requirements, there are a couple things that I do need to point out. So the starter project and final project can be downloaded from the links in the description below. If you are following along with this video, I would recommend starting with the starter project because that has, all the assets and a couple of the kind of UI-based scripts that we're going to be using that don't necessarily relate directly to Netcode for Entities things. And of course, the final project files are there for you to reference what the final project is like if you need to copy any code from that or anything. As far as Unity version goes, Unity does recommend using the 2022.3 version. For this specifically, I'm using the 2022.3.17 version, but any version of the 2022.3 should work for you just fine. It's also highly recommended that you have an IDE that supports source generation, so pretty much any newer version of Visual Studio or JetBrains Writer will give you this ability. Otherwise, you may see some errors in your IDE because the IDE is not properly accounting for source generation. Also recommended to have an IDE that automatically references your namespaces so that, as we're adding classes, it'll add the proper using statements to the top of the C# script. Then also, I do just want to give a quick little change warning saying that Netcode for Entities and just even Unity ECS more generally is still in active development. So that means that any specific APIs mentioned in this video are subject to change. One example of that is actually film this tutorial using the 1.2.0 pre-release 6 version. And just a couple days before I'm recording this section specifically, the 1.2.0 pre-release 12 version just released. So the small little update from that. I did actually on my own upgrade the project to the pre-release 12 version just to see if anything would break. And luckily nothing did break. So everything in this video is still completely valid. I didn't need to make any changes from that, which I'm very thankful of. However, just note that this is still considered a pre-release version, and there may be some changes when the full release version of the 1.2 comes out. What I did last time in the zombies tutorial is I had just kind of a blog post linked down in the pinned comment of this video where I noted any breaking changes. So I'm going to be doing the same thing for this video. So there's going to be a blog post linked down in the probably description as well as the pinned comment of this video. And, just as every time that a new Unity ECS version comes out, I'm going to go ahead and just try and upgrade this project to that and see if there are any major breaking changes that you need to account for. So if you're following along with this video in the future and there is a newer version of ECS out there, hopefully that would fill in some of the gaps for you. So with all that out of the way, let's go ahead and actually get into some of the theory behind Netcode for Entities. So Netcode for Entities is a server authoritative model. So this basically means that the server is the only true point of authority in the game. This means that all new objects must be spawned on the server, and then those are replicated down to the clients. Now, of course, the clients, we want them to be able to interact with the game. So the clients can use RPCs as well as command data. Both these concepts we'll be getting into later to request changes on the server. But ultimately it's the server that has the final say whether those changes are accepted or not. And one of the main advantages of having a server authoritative model like this is that it really reduces the possibility of players cheating because basically all the code is going to be ran and validated on the server, which means that a player can't say just, continually set their health to 1,000,000%. However, one of the downsides of having a server authoritative model like this is this means that because everything is happening on the server, well, there's always going to be some delay, some latency between the client and the server. So to account for that, we need to factor in some type of client prediction. So instead of waiting for that data from the server, the clients can actually predict what it thinks the server is going to do, so the user can have a kind of responsive experience. So one example that you'll see of this is when we go to actually move our player. When the player clicks to select a position to move to, we want our player to basically start moving immediately. We don't want to have to wait for that input to go up to the server validate that input, and then send back what direction that player should be moving in. We basically want the character on the client side to immediately move so the player has an extremely responsive experience. And the way we do this is through client prediction, where basically both the server and the client run the same code, so the result ends up being deterministic. And because the client and the server are both running the same code, the client can easily predict what the server is going to do. Now, one related concept that I do want to mention is the concept of network ticks. So in Netcode for Entities, the server runs at essentially a fixed time step. By default, this is running at 60 ticks per second. However, you can change that in the editor if you want to, but that is typically a good update rate to start with. Now, our clients, on the other hand, we want to allow them to update at a much faster rate. And especially as we're talking about competitive gaming, where some of these esports games are running at 360 frames per second, we don't want the player to have a laggy experience where only the players are updating at that 60 frames per second. So this is kind of where we bring up the concept of these full versus partial ticks. So a full tick would be considered when the client and the server are basically simulating the same full tick, which is that one every 60th of a second by default. Now basically in between those full ticks, the client is going to have a number of fractional ticks, which would basically be called partial ticks, which can kind of simulate what's going to happen in between full tick 1 and full tick 2. So essentially, once a client receives a network tick from the server, they have all that data as well as kind of some of the historical data from that particular entity. And then from that data, because again it's running that same code, it can predict ahead of time where that client was going to be at any of those partial ticks up until the next full tick. Now sometimes there will be some discrepancies between what the client thinks is going to happen versus what the server says actually did happen. And to combat that, Netcode for Entities provides some form of simulated rollback, where basically if a network packet comes in from the server that doesn't match what the client predicted, then the client is actually going to go back to the last known valid update from the server, and it's going to re-simulate the game using that new incoming data. Now, this is all well and good, but it can be quite costly, especially when we're dealing with large numbers of dynamic physics objects, because it's going to have to run that full physics simulation, every single one of those simulated ticks, which can add up quite quickly if we're doing a lot of it. And I should point out that with this client prediction and simulated rollback, there is a little bit of setup that we need to do. However, Netcode for Entities basically takes care of a lot of the heavy lifting of this for us, so we don't actually have to worry about implementing the client prediction as well as simulated rollback logic. We basically just need to structure our code in a couple simple ways for it to allow for this proper behavior. Now, I have been talking a little bit about clients and servers, and I think it would be good to just take a quick sec to just explain what I mean by that. So clients and servers actually can both run from the same executable. However, depending on your game, maybe you want to have server only versus client only executables. But in this particular tutorial, I'm going to be showing you, how we can actually use clients and servers running both from that same executable. So all the server really is just a simulation of the game that's running in a server world that's listening for client connections. Again, it's running off of the same executable. However, the server has some, special things about it. It doesn't run any like input systems or rendering systems. So it really is just simulating the game again at that constant 60 frames per second. And then clients are going to connect to a server through an IP address and port, just kind of basic networking stuff there. And clients can actually send up input data and RPCs, and they'll be able to receive RPCs as well as snapshot data from ghost entities. So let's go ahead and talk a little bit about snapshot data here, because this is a pretty important fundamental concept of Netcode for Entities. But again, like I've mentioned, the server runs at that fixed time step, and data for ghost entities are going to be synchronized on each time step. Now, I'll be getting into what ghost entities are again later in this video, but you can think of a ghost entity as a way to just view data from the server. And we can actually set different priority values to kind of optimize the amount of data sent each frame, so that way we're not sending all data for all entities every single frame. We can kind of prioritize entities that maybe are closer to the client entity, or maybe more important or more relevant for particular reasons. And then these snapshot data can basically contain anything, just basic data like transform data, input data, or other custom defined data that we have in our game. So anyways, that's kind of a high level overview about the theory behind Netcode for Entities. Again, we're going to be getting into lots more of the specifics throughout the course of this video. But before we get into it, real quick, I do just want to say that this video did take me a very long time to make. And if you found it valuable, I would really appreciate any form of support that you can give me. So if you want to support through liking, subscribing, and commenting, all that stuff is extremely beneficial to the performance of this video. If you do even want to take that a step further and share this with some friends or some colleagues or some online communities that you're on, that would be fantastic. And if you do want to provide any amount of financial support, probably the easiest way to do that would be through the super thanks button down below this video, because even donating a single dollar gives me more money than not only watching ads on just this big course video here, but it actually gives me more money than if you were to watch ads on every single video I've ever published. Yeah, seriously. So every dollar really does count. And by the way, if you do want to be so generous as to donate on a more recurring basis, I do have a Patreon available at patreon.com/turbomakesgames, which ties in a lot with the live show that I'm doing every week, where we're providing you a bunch of extra bonuses on a weekly basis. So if you are interested in data-oriented design, I would definitely recommend checking that out for some extra content as well. And with that, I just want to thank you all for being such a fantastic community, and I'm happy to present to you my full Netcode for Entities complete course. Enjoy. Okay, so I'm going to start off in Unity with just a little project overview. So this is basically what you're going to get if you download the starter projects using the files that I've linked down in the description below. So everything here should be set up in the starter project already, but it would be good to go ahead and just double check everything to make sure that nothing got missed. Also, it's good to just kind of have a little bit of an understanding about what these things do. So when you do go ahead to make your own multiplayer project, you'll make sure all these settings are set as they should be. So I went ahead and created a new project using Unity version 2022.3.17. We do need to be on version 2022.3 per the ECS requirements. Also, I did create a URP project because if we are creating a project using entities graphics, if we want to render the entities in our scenes, we need to be using either URP or HDRP. Other than that, I'm going to go ahead and open the package manager and show you the packages that I installed. So I did go ahead and install Cinemachine so we can do some cool stuff with the camera. Went ahead and installed entities as well as entities graphics. You see this is version 1.2.0-PRE6. Again, the full 1.2 version may be available by the time you're watching this video, but I am going to be using the 1.2 versions because there are a couple of interesting features that we can use that are helpful. However, the majority of concepts should still apply if you are using an older version such as 1.0. We also are going to be using the new input system. I created a whole video about using the input system with Unity ECS, but I'm going to be showing you kind of how I have that all set up in this project here. Of course, we need the Netcode for Entities package, and just make sure it is the same version as whichever entities package we are using. I installed Pro Builder so I could just kind of create some easy geometry within the scene here. Of course, we do want Text Mesh Pro in there for some UI stuff as well. And then Unity Physics, we are going to be using the ECS Unity Physics package. Again, we're using 1.2.0 Pre-6. Make sure that's the same version as your entities version as well. As far as project settings go, a couple things that we are going to need to set. If we go over to graphics, we can see which scriptable render pipeline we are using here. So I can go ahead and click on this, and then we'll go ahead and click on the actual renderer asset right below it. In the inspector, we're going to go ahead and make sure the rendering path is set to forward plus. If it's not, we'll just get some warnings in the console to remind us to go ahead and set it to forward plus rendering. Back over in the project settings, if we go over to editor and scroll down towards the bottom, you'll see there are the enter play mode settings. So this is kind of the fast enter play mode options. So we do just want to check mark that first box and then leave the next two unchecked. And this is going to enable fast play mode settings. There are some kind of gotchas with this if you are using some static variables. So it's just important to read the documentation and you understand kind of some of the limitations when it comes to the fast enter play mode settings. However, I would recommend having this enabled because it is a lot faster to enter the game when you're testing it. Okay, so next up is a very important one. We want to go to player, and then under the resolution and presentation settings, we definitely want to make sure that run in background is enabled. This is a very important feature to have for Netcode for Entities, because if we don't have this enabled and we try to say test it when say we have the server running in the editor here, and then we have maybe a client running in a build, well, when we're switching back and forth between the editor and the build, we don't want the game to be, continually pausing, because when that happens, it effectively stops the server. So if you have a client build who's like trying to connect to that server when it stopped, it's just not going to go through, and you're going to start pulling your hair out because you can't figure out why things are not connecting. Ask me how I know. However, in the 1.2 version, if you do not have this feature enabled, it will give you some warnings in the console and give you a little bit more information about why you want this feature enabled. So also going to other settings, we can scroll down here. We'll have our scripting backend set to IL2 CPP because we get better performance. There's no reason really not to have that enabled. Also went ahead and enabled the incremental garbage collector, just so we don't see these, crazy garbage collection spikes every once in a while. Although that wasn't something that I was necessarily seeing with that feature disabled, but I usually just have it enabled by default. And then finally in the project settings, here's a feature that's new to 1.2, and this is a netcode configuration asset. So you see that I've gone ahead and created this netcode configuration asset. It's under the settings directory. If you don't have one yet, you can go ahead and just create one here. And then when we set it here, you'll see that this sets it as essentially the global netcode config object. Now this is really handy to have because there are different places in our project where we may want to reference the netcode configuration. So we can go ahead and click on this and I can give you a little bit of an insight about what's going on here. So you see that there are a bunch of different options that we can change. Really the main thing that I use this for referencing is the simulation tick rate. So you see by default it's set to 60, which means it updates 60 times per second. That is essentially on a fixed time step. So you see that there are going to be a couple places in our code where we are going to reference the netcode configuration asset so we can see what that simulation tick rate is. So we can kind of calculate, how many ticks something is going to take over a certain given input in seconds. So I just have all these values set to default, but feel free to go ahead and modify these, play around with them a little bit to figure out, how they work and if changing them might work better for the type of game that you're going to be making. And one other thing that I do want to point out is I am using the new Unity input system. So I've created this MOBA input actions script here. So we just have a regular gameplay map on here. And then we have a couple different things configured for the different things that we can do. So first is select move position. This is basically the player can right click anywhere and the player is going to move towards that position that they right clicked at. The AoE ability is going to be the Q ability. So when they press the Q, a little AoE ability is going to spawn. The skill shot ability is going to be the W key. So when they press the W key, a little arrow is going to show up, and then whichever way that they're kind of pointing their mouse, the arrow is going to point towards. And then finally, they can confirm the skill shot by pressing the left mouse button, and then the skill shot is going to move in whichever direction that they have selected. So it's just a pretty basic input map setup here. You see that I do have the generate C# class. I checkmarked that, so we do have the ability to access this class through code. And one other thing that I do want to point out, if you go to edit and preferences and we go to the entities tab here, we'll just go ahead and make sure that the scene view mode is set to runtime data. That basically means that we're going to see kind of live entities updating inside the scene view as well as the game view. If we have this set to authoring data, then we won't necessarily see that happening in real time, and I know that can kind of lead to a little bit of confusion. Okay, so to give you a little bit of overview on the different scenes that we have, you'll see in the scenes folder we have two main scenes. We have the connection scene and the MOBA scene. So the connection scene is going to be kind of this, basic connection scene that the user is going to see when they first launch the application, and this is going to allow them to enter into the game. So you see that I have a very simple UI interface here where we have the connection mode where we can set if this instance of the game is going to be a host where it spins up a server as well as a client, or this is going to be a server only or client only instance of the game. The connection address is essentially the address that it's trying to connect to. So if it's set to server mode, then this doesn't matter. It's just going to create a server on the IP of this machine. However, if we are trying to connect to it through a client, we can go ahead and input the IP address of the server that we're trying to connect to. Of course, for testing, we can use the loopback IP address of 127.0.0.1, which basically means that we're trying to connect to this machine. Next up is the connection port. This basically means that if we are creating a server, what is the port that the server is going to be running on that clients will be communicating through? And similarly, when we're creating a client, we need to know that port that the server is going to be running on. So again, we can communicate through that port. Finally, I do have a team selection drop down. Of course, we're just going to create a simple little game where there's a blue team and a red team. So I do also have options to auto assign a team. So it's just like whichever team has less people, it's going to assign the player to that team. And then we also do have a spectator option. So basically someone could join in the game as a spectator and they can essentially just watch the game playing, but they don't have control over an actual player or anything like that. Turns out this is a super easy feature to add. So I just went ahead and added it, and I can go ahead and show you how this all works later in the tutorial. And then finally, we just have the little connection button at the bottom, and you'll see that I have this update when we go ahead and just change whichever UI that we're doing here. And then just going over the MOBA scene here, you'll see that we have these simple little map set up, something similar to what you might see in like a League of Legends or a Dota. Basically, we have the blue section over here where the blue team is going to spawn, and the red section where the red team is going to spawn. You see that we kind of have these different towers scattered throughout the map. Basically, the towers are going to attack players of the opposing team. And then once a team's base gets destroyed, the game is over and a winner will be determined and displayed at the end. And then just looking in the game view, you'll see that I do have a couple little UI things set up here for the Q and W ability cooldowns. And then I do also have some other UI things set up that will, pop up to display different text for when we're entering the game and all that, but I'll go ahead and hook into that when we get to it. And so of course, because we are using ECS, you'll see that in the hierarchy, we do have this MOBA entities scene here. So this is a sub scene. If the box is unchecked, we can check it, and then you'll see what is actually in the scene here. So you see that we do have these different prefabs for the blue base, red base, and all the different towers. And these are basically just kind of regular prefabs right now. However, we are going to be adding some things to these later, which is why they're set up as prefabs. Okay, right now we do just have an empty entity right here for the camera entity. We are going to be adding something to this later, but it is really just an empty game object. Physics debug, this is another basically just empty game object, which we've added the Netcode physics config script on here, which allows us to have a little bit of control over some of the physics configurations. So I do just have this dropped in here with the lag compensation box checkmarked here, which is a recommended feature per the documentation. The ground plane is basically just a plane that spans across the ground. And it's basically just a big physics plane which we can raycast against, so we can basically click to have our player move to a specific position on the map. So you see that I went ahead and changed the collision filter to belongs to ground plane, and it collides with everything. Now I did set up some custom physics category names. So if we go ahead and click on this, go down to edit physics category names, it's going to bring us to the physics category names assets. And you see that I have different categories for the ground plane, champions, minions, abilities, structures, raycast, and target casts. These are all different physics categories that we will be utilizing, and it is important to have different categories set up for different things so we can determine which types of objects we are going to be interacting with for different physics operations that we might want to do. Moving along, we have a prefab container. This is again another just empty game object right now, which we're going to be adding things to. Game start properties is empty, and minion properties are empty as well. And then the only other thing that I set up in this scene is just a basic camera controller. So whenever you move your mouse kind of towards the edge of one of these, towards the edge of the screen here, it is just going to go ahead and move in that direction. So it's not like, following the player or anything like that, but it's just a pretty basic kind of free look camera here. Okay, so we'll go back to the connection scene, and then we're going to go ahead and start with the most important part, which is actually creating these netcode worlds and then having our players be able to enter into them. So by default, when we're using netcode for entities, you'll see that if we go ahead and hit the play button, and then we come down here, you'll see that I do have the systems window open. By the way, you can get to all these fun different entities windows just by going up to window and entities. And then you'll see that we do have hierarchy, components, systems, archetypes, and journaling. So in the systems window, this will show us the active worlds. So you see that right now we have a client world and a server world. Now, if we didn't have the netcode package installed, we would just see one single world, which would be the default world. So by default, when we have the netcode for entities package installed, it's actually going to go ahead and create a client world and a server world. Now, we don't exactly want this to happen because we want to have a little bit of control over, when the worlds are created and which specific worlds that we want to create. Because again, we don't necessarily always want builds of our application to be creating a server world as well as a client world. Sometimes we just want a server world and sometimes we just want a client world, but sometimes we do want to have both as well. So we do want to have a little bit of control over that. So first thing that we're going to go ahead and do is just go ahead and create a empty game object here, and we'll go ahead and call this the bootstrapper. And then we're going to go ahead and add a component, which is going to be the override automatic netcode bootstrap. So basically this is going to give us a little bit of control over the automatic creation of server and client worlds. So where it says force automatic bootstrap in scene, we're going to go ahead and change that to disable automatic bootstrap. So now when we hit the play mode, you'll see that in the systems window, we just have the default world. Now we'll point out this is a new feature in 1.2, and there is a way that you can actually disable the automatic bootstrapping, but you do have to do it a little bit more manually, and you actually have to do that through code. So I'm going to go ahead and put that script up on the scene right now if you are using an older version of Netcode for entities. The next thing that we need to do is actually go ahead and create the specific worlds that we want. So I've already created the script for the client connection manager. This does a little bit of that UI stuff that I was showing off in the beginning. However, you'll see that when we go to the on button connect, we have a couple functions that don't actually do anything. So the first one is going to be the destroy local simulation world. So the first thing that we actually want to go ahead and do is destroy that default world, because there's no point in us having that, because we just want the netcode worlds that we're creating here. And so we can do that with just this simple little snippet of code here. So basically all that we do is we iterate through all the different worlds in worlds.all, and then we see if the world.flags is equal to worldflags.game. If it is, we just go ahead and dispose it and then go ahead and break out of that for each loop there. Okay, so going back to the on button connect, this is basically what happens when we click that connect button. So we've gone ahead and destroyed the local simulation world. Then we're going to start going ahead and loading the next scene, which is the MOBA scene here. And then we're going to just go ahead and do a little switch case here to see what the connection mode dropdown is set to. So if the case is 0, this basically means that we're going to start the host, which all we do is just call a start server and the start client function. If case is 1, we're just going to start the server. If case is 2, we're just going to go ahead and start the client. So down here, I do just have a couple empty functions for start server and start client. So we'll create the server world first. So we can say var server world is equal to client server bootstrap dot create server world. And then in here, we can type in a name for the server world. Of course, we can name this anything that we want. Let's just call it Turbo Server World. So now we need to actually tell the server world to start listening for connections. The way that we do that is we're first going to go ahead and create a server endpoint, and we can do that by using the network endpoint dot any IPv4 dot with port. And then here we can go ahead and pass in port. So you see that I've gone ahead and created a private property here called port, which just does a ushort for unsigned short integer, which does a ushort.parse on the port field.text. So whatever we have typed in the text field here is going to go ahead and parse that to a ushort. And so this is basically how we say the server is listening on, whichever specific port that we've typed in that connection field. Next up, we'll just do the open and close curly braces, and we can do a using var network driver query. And so we'll go ahead and create a new entity query. Now to create an entity query, of course, we need to create it based off of an entity manager. Now this script that we're in right now is just a mono behavior, so we can't actually access a mono behavior through this script directly. Luckily, we can access the entity manager of the server world, which is exactly what we want because we're going to be creating a query from the server world. So we can do server world.entityManager.create entity query, and we'll do a component type.read write with the type of the network stream driver. And then here we can go to the network driver query .get singleton RW, again using the type of network stream driver, so we're actually accessing that singleton component on there. From here we can go to value.rw.listen, and then here is where we basically pass in the server endpoint that we've just created. So again, this is telling the server to listen on that port. And that is all that is needed to actually go ahead and start the server up. Now for the client world, we're going to do something very similar. So we'll go ahead and do a var client world equals client server bootstrap dot create client world this time. Of course, we can call this the turbo client world. And then here we can do a connection endpoint, and we'll do a network endpoint dot parse, and this way we can pass in a string for the IP address and a ushort for the port. So as you may have guessed, I do have a property for the address, and then we can use that same port one as well. You see that the address, again, we're just getting the raw text from the address field in the UI. We're going to do something very similar to before, where we have the network driver query. This time we're going to do this on the client world's entity manager, but instead of this time at the end of doing a .listen, we're going to go ahead and do a .connect. And so here we first need to pass in the entity manager. So we'll do client world.entity manager. And then the network endpoint is going to be our connection endpoint. Now, one last thing that we do want to do is we can set the world.default game object injection world, and we'll set this equal to our client world. So that basically means that anytime within our code, if we are ever referencing the default game object injection world, it's going to be referencing the client world. Now we do want to make sure that we set this because again, we are destroying the regular default world here. However, just be aware that we could run into some weird situations if we are trying to say access the default game object injection world from the server because it's not set to anything. Okay, so now we'll come back to the connection scene here, hit play, and then you'll see over in the systems window, we just have the default world. Again, we're not actually destroying the default world until we actually start the game here. So we'll go ahead and say start a host. When we do that, it's going to go ahead and actually load into the main entities scene here. And you'll see that right here, we no longer have a default world, but we do have the turbo client world as well as the turbo server world. So that is exactly what we were looking for. And then if you want, you can also verify that, say, if we just go to the client world and say start client, we now only have a turbo client world created. And same thing would be true for the server world. So basically at this point, we have the ability to spin up a server world and start listening for client connections. And we also have the ability to create a client world and then connect that to the server. However, at this point, we actually can't send and receive snapshots between the server and the client because the client isn't actually considered as in the game yet. The client still can process RPCs. However, we actually aren't transmitting any like live player data or anything at this point. So I've decided to organize the scripts between client scripts, server scripts, as well as scripts that are shared between the client and server worlds. Now, the bulk of the scripts that we're going to be creating are going to be in that shared one. However, there are some specific ones that we need for clients as well as servers. So now to get our client actually in the game, what we're going to do is create a system on the client side, which is going to request the server to say, hey, I want to get in the game. The server is going to process that request to determine if the client can enter the game. And then if they can enter the game, then it is going to actually enter them into the game. So I'm going to go ahead and start in common, and I'm going to go ahead and add a new enum, which I'll call team type. This enum is going to be just a single byte because we don't really need to convey that much information, and just having a single byte that's going to be passed back and forth between the client and server is not all that bad. So here is the actual different team types that we can define. So we'll go ahead and have a none, which is equal to 0. This would basically be for if a player is going to be entering the game as a spectator, they're going to be assigned a team type of none. Go ahead and set blue equal to 1, red equal to 2. And then finally, we'll go ahead and create an auto assign one, and we'll just set this equal to the byte.max value. So the idea here is that our client is basically going to pick which team they want to be on, and the server is going to determine if the player can actually be added to that team or not. So next up inside client, I'm gonna go ahead and create a new script here. I can just call this client components. So I'm actually just gonna go ahead and delete all this default code here. And this is basically where we're just going to create a couple of components that we're gonna be using on the client side throughout this tutorial. So in that client components, we're gonna go ahead and create a client team request. And then you see that this is just a regular I component data. And then inside here, we're going to have one field for team type. And just because we have a single field, we can just call it value. Now, the idea here is that we're going to actually create an entity and assign the requested team type to that team type value. And then we can use that to send a request up to the server to say, hey, I want to be a part of this team. So first thing that we're going to do is use a switch expression to figure out the value of the team that we're going to be requesting. Now we're going to be using the team dropdown.value. Again, the dropdown in the main menu, the first option is auto assign. So you see that if basically the dropdown is at index 0, then the team that we're going to be requesting is just the auto assign. The next option is blue, the next option is red, and then if we use anything else, such as the spectator mode, then we're going to set team type equal to none. After that, we'll go ahead and create a team request entity, again using the client world's entity manager, and we can just create an empty entity here. Next up, we'll go ahead and again use the client world's entity manager. This time we'll do an add component data, and then we'll be adding this again to that team request entity which we just created. And then we'll say a new client team request. And then the value here is just going to be equal to that team value from our dropdown here. So this is just going to create an entity on the client side. And then we're going to have a system that runs on the client side that runs against this entity. And then that is actually what sends the request up to the server. So I'm going to go ahead and just create a new struct here and call this the client request game entry system. The reason that I'm doing this as a struct is because we want this to be an iSystem. So we do need to make this a public partial struct and implement the iSystem interface here. Now we do want to specify that we only want to run this system on the client world. So the way that we can do that is we can use the attribute for the world system filter. And then here we'll use the world system filter flags, and we can run this against the client simulation. We also want to go ahead and run this against the thin client simulation, because later on we are going to be adding thin clients to this simulation. So this will basically be running on both clients as well as the thin clients created in the editor. So although it's not typical in systems, we are going to have a private member variable here for an entity query, which is called the pending network ID query. And you'll see why I'm doing this here in just a moment. We'll go ahead and do just a regular on create here. So public void on create, ref system state. State is just kind of the general way that we define these here. So we're going to create an entity query builder to create our query. So we'll just do a var builder equals new entity query builder, and we'll just do a allocator dot temp. And so we want to see everything that has a network ID component, but does not yet have the network stream in game component. So the network ID and network stream in game, these are both part of the Unity Netcode's namespace. The network ID is basically just a component that is assigned to each of the clients. They're going to get a unique ID assigned to them when they do that initial connection to the server, which we've already done. And this network stream in game component is an additional component to basically specify that that client is actually in the game and they should receive snapshots from the server. So here we'll go ahead and assign our pending network ID query. And we can do that just by doing a state.getEntityQuery and just go ahead and pass in the builder there. Now, one of the reasons that we want to do this is we can just do a state.requireForUpdate and pass in the network query here. And then we also are going to be using this in the onUpdate as well. But we do want to do one other requireForUpdate, and that is going to be the client team request. Again, we only want this to run if one of these client team request entities actually exist. So now here we can go ahead and create our onUpdate function here. So first thing that we need to do here is actually figure out the team that we're requesting to be a part of. So we can do that by using our system API.getSingleton and the client team request. We can do this because we know that there's only going to be one of them, and then just go ahead and do the .value to get the underlying team type of that client team request. Next up, we're just going to go ahead and create a local entity command buffer. So we can just call this ECB equals new entity command buffer. And this as well as going to be a temp allocator because we're just going to be running it right here. So next up, we'll actually get a list of all these entities that are essentially these pending network IDs. So say var pending network IDs equal to, we can do pending network ID query dot to entity array, and we are going to use a temp allocator as well. This will be disposed at the end of the frame. And then here we can just use a for each to basically iterate through all of these pending network IDs. Now just kind of sticking with the ECS design pattern, even though there's only really ever going to be one of these particular entities, it's still best practice to treat it as if we are iterating over a group of these. So here we'll use our entity command buffer to first add a network stream in-game component to the pending network ID entity. So now on the client side, this network ID entity has that network stream in-game component, so it will start receiving snapshots from the server. Okay, so just going to take a quick sec here to talk a little bit about RPCs. So an RPC stands for Remote Procedure Call, and it's essentially a message going from machine A to machine B. Now, clients can send RPCs up to the server. In the first case that we're going to be doing, the client is going to send an RPC up to the server saying, hey, can I enter the game? And the server can also send RPCs to one or all clients. So if a server needs to send a message, back to that one single client and say, hey, you can't enter the game actually because, this reason, or this reason, an RPC would be a good way to do that. One reason that a server might send an RPC out to all clients is if, say, the scene that the game is in needs to change. So maybe, everybody is in level 1 and then we need to move over to level 2. Well, the server can send an update to all the clients for that kind of one-time event to happen. So now let me show you how we actually implement these RPCs in practice. So we're going to be using the automatic code generation approach to send these RPCs. There is a way that you can do it a little bit more manually, and the online documentation does a really good job about, showing you everything that you need to do. But for the most part, the auto code generation approach works really great, and you don't have to write a ton of extra code for it. So this would be an example of an RPC that, say, our server is sending out to all our clients to notify them of a new scene change. So the way that we create this is we create a public struct called load level RPC, and you see that it implements this IRPC command, which is a special netcode data structure, basically signifying this as a component as well as a special RPC command component. And you can see that we can actually pass along data with this RPC. So in this case, we have a public integer for the level index. Now what we're going to do here, and this is happening on the server side, is we say have a method here called load a new level, which takes in an integer for the level index. Now what we do is we create a new RPC entity. In this case, I'm just using the entity manager, and then we're going to be adding this load level RPC as well as the send command request components to this entity here. So this load level RPC, of course, this is the custom component that we just created. Now this send RPC command request is a special component saying that, hey, this is an RPC that needs to get sent out. If we don't pass in any entity parameters to this send RPC command request type, then if we're sending from the server, then this sends to all the clients. However, if we're on just the client, this will send it automatically just to the server. Now we can also pass in an entity for the connection entity if we did want to target a specific client. And then you see here with these last couple lines that I'm just setting the component data again on that RPC entity that we just created, and we're setting the load level RPC, and you'll see that's where I'm actually setting this level index here. So basically all we need to do is just create this entity, and then the automatic code generation will handle the rest of actually sending this RPC entity. Now, how do we actually receive this? So again, we can use the automatic code generation approach, and we basically just read data and handle it as needed. One important thing that we need to do is we do need to immediately destroy the RPC entity. And then so this time, instead of actually having a send RPC command request, we have the receive RPC command request, and the entity field on that references basically the connection entity of who it came from. So you can see here that I'm doing an idiomatic for each, and I'm just looking for anything with this load level RPC. And notice that this entity will have the receive RPC command request. So again, basically on the side that it's sending from, this component will be the send RPC command request. And then on any clients that are receiving these RPCs, the component is going to be called the receive RPC command request. So then this is just pretty standard stuff. Maybe I've created a little method here called load level, and we can just pass in the level to load that level index here. And then again, you'll see that I have maybe say an entity command buffer created before this, and we're just doing an entity command buffer.destroy entity. Again, we need to make sure that we destroy this RPC entity right away. If we don't, we do end up getting some errors, so it's kind of pretty obvious when we forget to destroy an RPC entity. So let's get back to the tutorial, and I'll show you how this is actually implemented in our game. And then the last thing that we need to do is actually request to the server to say, hey, can I be a part of a particular team? So here we'll create a request team entity. We just do an ECB.create entity. So now we need to add a specific component type to this entity, which is going to be a special RPC component. Now the RPC component is basically a way that we can say send a message to the server, and again in this case we're going to be sending the request for which team the client wants to be a part of. So we can go into our common folder here. I'm going to go ahead and create a new file here. We'll just call this RPC components, because we are going to have a couple of these over the course of this tutorial here. So the first one we're going to do is a public struct, and we can just call this, say, MOBA team request. So the type of this is going to be an IRPC command, which again is a special netcode type for these specific RPCs. And the one field that we're going to have on here is the team type, which we can just call value. So this is basically the team type that we are going to be requesting. So back on here, we're actually going to go ahead and add this component to this request team entity. So we'll do a new MOBA team request. And again, the value on here is going to be equal to our requested team that we got from earlier, just right up here. However, just adding this component isn't enough. We need to go ahead and add one more component to this request team entity. And this is again, another special netcode type. And this is the send RPC command request. And then here we set the target connection equal to the pending network ID, basically the current entity that we're iterating across. So the whole idea here is that basically when we're sending this RPC, it needs to know the target connection that is actually, the one sending that RPC. So we set the target connection equal to this particular entity, and this is a special entity because this has the network ID component, which uniquely identifies it on the server. And so that is basically all that we need to do. The last thing that we'll just do here is do an ECB.playback, passing in the state.entityManager. So at this point, we're just basically broadcasting this RPC off to the server. Now the next portion is to actually have the server process this RPC request. So we'll go here and we'll go ahead and create a new struct. We'll call this the server process game entry request system. So again, this is going to be another iSystem. So of course we'll need to make this a public partial struct and implement the iSystem interface here. Now we want this system to only run on the server world. So again, we can use our world system filter using the world system filter flags against the server simulation here. And then in the onCreate, we're going to do something similar where we create a new entity query, looking for anything that has this MOBA team request RPC as well as the receive command request. So basically when we send it, we have the send RPC command request, and then on the server side, that component is translated to a receive RPC command request. So it only will run one time when a new client is trying to enter the game. So here in the on update, we can actually go ahead and process this request. So we'll go ahead and do a for each loop here. And then we're going to be using the idiomatic for each, so we can do a system API.query. And then we're basically going to do this same thing here where we have the MOBA team request as well as the receive RPC command request. So then here we can just go ahead and call this, say, the team request. We'll call the next one the request source. And then I actually do need to do a dot with entity access, and then we'll have the request entity here. And if we want, we can clean it up and have these on multiple lines here so it looks a little bit cleaner. Now we do need an entity command buffer to do a couple things. So again, we'll just do a local entity command buffer. So the first thing that we actually do want to do is destroy the request entity. The reason that we do that is because we only want this RPC to essentially run one time. We don't need this to continue to run. So first we just go ahead and get rid of that RPC entity. Next thing that we need to do is add that network stream in-game component to the request source.source connection. So this is actually going to line up with this, say, target connection that we're setting in the send RPC command request. So this basically, again, is that kind of unique component that is associated with that client. We're adding that network stream in-game component so the server knows to actually send that client data. So at this point, the client is kind of considered actually in the game and will start receiving data. So now we actually need to kind of process this team request to, see if we can actually add them to the team. Now we're gonna do something simple for now. We'll get a little bit more complicated as we go on, but here we can just go ahead and get the team request type. So we'll do a team request dot value here. So we'll go ahead and say if the requested team type is equal to the auto assign, then for now we'll just go ahead and set the requested team type equal to the blue team. Later on we'll get a little bit more complicated with this, where we can kind of actually count up how many people are on each team and so on. So what we're just going to go ahead and do right now is just go ahead and print a little debug log statement just to make sure that everything is working up to this point, because I know we've kind of been stuck in the code editor for a little while here. So first we're going to figure out what the client ID is, and we can get that just by doing a system API.get component. We're looking for the network ID, and then we're going to be running this against the request source.source connection. And then here we can actually get the underlying value for that network ID. So here we'll do a little debug.log statement. So here we can say server is assigning client ID, pass in the client ID to the requested team type dot toString team. And then finally, we just need to make sure that we do an ECB.playback, and then we'll go ahead and pass in state.entityManager. So now when we enter play mode and we say join this game as a host on the auto assign team, you'll see that in the console we have just a single message here saying server is assigning client ID 1 to the blue team. You may notice that we have a couple error messages. We will be addressing those later. That's just because I have some things set up in the demo scene where I've intentionally omitted some things that we're going to be adding later. So you don't need to worry about that for now. And also we can just verify if we say go to the red team, we can say start host. And then we do now have the server is assigning client ID 1 to the red team. Okay, great. Now the next thing that we need to do is actually spawn an entity for our player. But before we do that, I'm going to take a little bit of a detour because we are going to go back over into our main MOBA scene and just to fix a couple of things here. Because you see that first thing first, when we enter play mode, you'll see that we actually do create the generic server and client world, which we don't want. So we can actually just go ahead and come over here. We'll create an empty object. We'll call this the bootstrapper. And then again, go ahead and add the override automatic bootstrap in scene. Go ahead and set that to disable. We can just go ahead and save that. You'll see that it'll just go ahead and create a default world for us right now. Now, this is kind of going to be the main scene that we're going to be in. We're going to be editing this and stuff like that. However, it doesn't have those, specific connection details that we've created inside that kind of main menu scene. So what we're going to go ahead and do is create just a little bit of a workaround where we actually create a system where if we are in this scene, it's going to bring us back to the main connection scene. So here I'm going to go to the scripts folder here and create a new directory. We'll just call this the helpers. Inside here, we're going to go ahead and create a new class here. We can call this the load connection scene system. So this is going to be a system base. So this is going to be a public partial class, and it implements system base here. And we can just do that to go ahead and implement the on update. We don't actually need anything in on update because we're going to do everything inside on create here. So first thing that we're going to do is set enabled equal to false because we only really want this system to run once. So what we can do is just use the scene manager. So we can say if scene manager dot get active scene is equal to scene manager dot get scene by build index 0. We'll just go ahead and return. So this basically means if we already are in the connection scene, just don't do anything. Otherwise, we'll do a scene manager dot load scene 0. So this basically means that, you know, any scene that we're in, if it's not the connection scene, we'll just go ahead and load it into the connection scene. Now, running this system doesn't actually apply in builds, so I'm just going to go ahead and use the preprocessor directive here. So we can say if Unity editor, and I will go ahead and move this end if down to the bottom here. So again, basically this system only runs in the editor because, you know, essentially anytime that we create a build of this application, it's always going to be starting off in the connection scene. So we don't want to necessarily run this in a build or anything like that. So coming back to Unity, you can basically see the regular workflow of this. So if we are in the MOBA scene here, if we hit play, it's just going to load us back into this connection scene. You see that we just have the default world right now. And if we're to say start host, now it loads us back into the main MOBA scene, and we have these server and client worlds available to us. So that is perfect. That's exactly what we want. And one very important thing to point out about doing this little hack, you'll see that anytime we make any modifications to things inside the entities scene, there's going to be a little star next to it. It is very critical that we always make sure that we save the scene before testing. Otherwise, next time we come to load the scene using this hack, it's actually not going to load with the latest changes that we've made. So we always need to make sure that we save it before we test. Okay, so now let's go ahead and actually spawn these champions into our game. So the way that we're going to do that is by using our prefab container, which is in the MOBA entities scene here. And then we're going to store a reference to our champion prefab, so we can actually spawn them in a game when a new client joins. So under common, we'll go ahead and create a new struct for MOBA prefabs, and this is going to be an iComponent data. Now we're going to end up having a couple of these, so we'll say public entity, and then we'll just call this champion. So we're going to have a couple other things in here, so that's why I want to actually go ahead and name this variable. So if you're watching this video, I'm going to assume you're already familiar with authoring components, but basically the way that we can store a prefab reference is we can basically just have a public game object, and we store a reference to the game object prefab, and then inside the baker, what we have to do is we actually have to get a reference to the entity, which is a reference to the entity that is being converted. So in this case, this is actually the prefab container entity that this prefab authoring script is going to be on. So first we have to get that entity, which is this entity right here. For clarity, I can just call this the prefab container entity. And then here we're just going to add a component to this prefab container entity, which is a new MOBA prefabs, which is the component that we just created. And we're going to go ahead and set the value of that by doing another get entity, but this time we actually are going to pass in authoring.champion, which is a reference to the game object here. And then we're also going to use the transform usage flags.dynamic. Now the transform usage flags.dynamic, this means that this is an entity that is going to basically exist somewhere in our world. And actually, you know what? Our prefab container, now that I think of it, it doesn't need this transform usage flags dynamic. So we can actually set this to none. And this basically just means that none of the transform components are going to be added to that prefab container entity, because this is basically just a data only entity. So back over in Unity on the prefab container, we'll just go ahead and add the MOBA prefabs authoring. Now for our champion, we can go into prefabs and drag in our champion prefab just like that. Now, of course, this just gives us a way to reference this entity prefab from the ECS side. Now we actually need to go ahead and spawn it. Okay, so we'll come back to our server process game entry request system, and this is where we'll actually spawn our champion prefab from. So first we'll need to get a reference to our champion prefab. And we can just do a system API dot get singleton on the MOBA prefabs, and then we want to grab the champion off of that. You'll see that writer gives me a little squiggly line under here, and what we can do is do an add missing require for update, and that basically means that it's going to go ahead and add this require for update MOBA prefabs in our onCreate, just so we don't get any errors when we try to say access this singleton if that singleton doesn't actually exist. So now back inside the for each loop, we'll go just under this debug.log statement here. In our entity command buffer, we can go ahead and do an ecb.instantiate, passing in the champion prefab here. Let's go ahead and get a reference to this. So we'll say var new champ, and we'll just go ahead and set a spawn position for this for now. So we can say var spawn position equals new float 3, passing in, we'll say 0, 1, 0. And then of course we need to actually assign the spawn position to the transform component. So we can say var new transform equals local transform dot from position, and we pass in the spawn position here. And then we can do an ECB dot set component, passing in the new champ as well as the new transform. And then also, to make this a little easier for debugging, I'm just going to go ahead and add in an ECB.setName, and then we'll just go ahead and set the name to champion. So let's come over to Unity and test it. We'll see that we enter play mode and enter the actual game, and we see that nothing spawns. So what is going on with that? Let's look over in our MOBA entities, and we do see that champion, and we see that it is at our spawn position of 0, 1, 0. So why is that happening? Well, let's take a look about what world that we're looking in on this entities hierarchy. Well, we're just looking at the Turbo server world. What happens if we move over to the Turbo client world? And so we do not see anything named champion anymore. So what the heck is going on with that? Well, you'll remember that that instantiation code is only running on the server side. It's not running on the client side. So we need some way to essentially replicate what's happening on the server over on the client. Luckily, there is a pretty easy way to do this, and this is a very core concept of Netcode for entities, and that is by turning this champion into a ghost. All right, so just gonna cut in here real quick to talk a little bit about ghosts. So the theory behind ghosts is, well, ghosts are client-side entities that just display data from the server. So even player-controlled entities are considered ghosts, and the clients can actually not directly set any ghost data, as it just ends up getting overridden by the server on the next network snapshot. So this is one of the things that led to a lot of confusion for me when I started learning this Netcode for entities, because again, it is a server authoritative approach. So when I was just doing kind of normal things that I was used to about, setting data on some of my client side entities, I noticed that that data just kept getting overridden, and it was, a little bit confusing for me to kind of wrap my head around why that was happening. Well, really, you can think of these ghosts as, again, they're just essentially reading data from the server. And, Netcode for entities doesn't necessarily give you any errors when you try to write to data on the clients, but it just kind of, silently gets overridden. So also to point out on these ghosts, they must be prefabs, and they're typically spawned at runtime, but they can also belong to a subscene. So we have a couple of those different things happening there. So ghosts in practice, they're pretty easy to set up. All that we need to do is actually add this ghost authoring component on here. And you see that there are a number of parameters that we can set on here. So for example, here's the importance. Now a higher importance value basically means that it is going to be more likely to be included in a snapshot. So this is how we can kind of configure some of the prioritization of certain entities over others. For supported ghost modes as all, so we can have either predicted or interpolated as the supported ghost modes. And you see that I have the default ghost mode set to predicted for this particular one here. Predicted means that the clients are going to run the prediction logic on these particular ghosts. However, if they're set to interpolated, then it's not actually going to predict them. It's just going to interpolate the data of where it thinks it should be based on the previous couple network ticks. Again, for things like our player, we want to have these as predicted, but for maybe the things that are far off that we don't care about so much, we can have those set to as interpolated, so we don't have to worry about, running that expensive prediction logic on those particular entities. Optimization mode can either be dynamic or static, and that just kind of optimizes about, what data is synchronized and when. And then these first two checkboxes are things that we would say want enabled as our player, so that, our player client can actually own a given entity. And the support auto command target is something that's really important for input, because we want our entities to basically take in proper input and be able to process that all correctly. And to be honest, I haven't yet needed to use any of the other checkboxes listed here. Now, as far as code goes, I want to go over the concept of ghost components. Now, a ghost component is just kind of a regular iComponent data, as you can see here, but we've included some extra attributes to denote this as a ghost component. Now, a ghost component is essentially, a regular component, but it receives snapshot data from the servers. So one easy way that we can actually define a ghost component is just by adding this ghost field attribute to any field in an iComponent data. Now this basically means that this field is going to be replicated across the network. And then this ghost component attribute up here, this is not always necessary, but it is just kind of probably best practice to include it for the most part, when we do want to, be extremely obvious about that something is a ghost component. Now with this ghost component, there are some optional parameters that we can set here. So in this example, we're setting a prefab type equal to ghost prefab.all. So this means that all ghosts, whether they be predicted or interpolated or owners or non-owners, they all will have this data replicated. Now, if we set the prefab type to predicted, which I actually do for a couple components later on in the video, then that means that only predicted clients have this component here. So again, that's kind of another optimization. If say, interpolated clients don't need to worry about any specific data, that's kind of more maybe intermediary data could be considered, then that interpolated entity is actually not going to have that component. And so we don't need to worry about synchronizing that extra data. So again, it's just kind of a little bit more ways to optimize how much data we're synchronizing per frame. So let's go ahead. I'm just going to minimize a couple of these things here to get those out of the way. So go ahead and add a component, and we'll just type in ghost, and you'll see there is a ghost authoring component. Now this ghost authoring component has kind of some different parameters that we can tweak on here. For example, you see this importance field. So basically the higher the importance value, the more important that we can consider it. Of course, because this is the thing that the player is directly interacting with, let's go ahead and set it to an importance of 1000 to make it very high. So the supported ghost modes, this basically determines whether this is going to be an interpolated or predicted ghost, or it can support both modes. And so we're just going to go ahead and have it support all, so that say local clients can have it as predicted. However, maybe we can configure it so further away clients can have this as an interpolated client, and it doesn't need to do that prediction logic. However, the default ghost mode, we're going to want to set that as predicted for now, just so by default these champions are all going to be predicted. Now a couple other things that we do need to do is we do need to mark the box for has owner, because we do want our player to kind of have some ownership over this, as well as support the auto command target, which is going to help us when we go to actually add input to our game. So it essentially knows what entity to associate any input with. And we can go ahead and just leave the rest unchecked for now. And so having this has owner box checked, it will also do some important things, like such as, if a client disconnects, it'll automatically go ahead and clean up this champion entity to basically despawn it from the world. So now that we've made those adjustments to the prefab, now we'll go ahead and enter play mode. We'll do a start host, and you see that we now do have this entity spawning in the middle of the world here, which is fantastic, exactly what we want. Okay, so now we do need to do a couple things to actually make this essentially ready to accept player input, and we do want to configure some things so that if it spawns on the blue team, it's going to go ahead and spawn over in the blue area, and we're going to change the actual material color from this gray to a blue. So under common, we're going to go ahead and add a new script here, and this will just be called the champion components. And so here we're going to create a couple different things. So here we're going to have a public struct for the champ tag, which is an iComponent data. Next up, we'll also do a public struct for a new champ tag. So this basically is going to be associated with this entity when we first spawn it, so we can do some kind of initialization logic against it. And we'll also do a public struct called MOBA team, which is an iComponent data. This one does have a public team type value. So this is basically going to be associated with the champion entity, as well as some other entities like the minions and bases and things like that, to associate it with a specific team. Okay, so here I've just created a champ authoring component, and inside the baker, we're just going to go ahead and add the champ tag, new champ tag, as well as the MOBA team to the entity. So again, we'll just come to our champion prefab, and we can go ahead and add the champ authoring, and we don't need to set any values on there for now. Okay, so after we go ahead and set the transform, we do need to do a couple other things. So next we'll go ahead and do an ECB.setComponent. And so this is again on the new champ, and this is going to be a ghost owner component. So this is a component that's added when we add that ghost authoring component on there. And then basically we just need to go ahead and set the network ID equal to this client ID that we actually pulled from earlier. So let's just say client ID, and that's just an integer right there. So again, we're basically setting this on the server so we know that this champ is associated with a particular client. So next we'll go ahead and do an ECB.setComponent. And then we're going to go ahead and do a new MOBA team, so we can actually set the team that the champion is associated with. So we'll set the value equal to the requested team type, which again is just this one that we created from right back here. And then one final thing that we need to do with the entity command buffer is we are going to be doing an append to buffer. And this entity that we're going to do this on is on the request source.source connection. So on basically the source connection that we're trying to enter the game with. We're going to add to the linked entity group buffer, and here we'll set the value equal to the new champ. And so by adding the new champion to the linked entity group for the source connection, this means that when, say, the source connection is destroyed, if the player were to ever disconnect, then it's automatically going to go ahead and destroy this new champ here. So we can come back to Unity and test this out a little bit. If we actually go ahead and hit the play mode, we can go ahead and we see that the player enters the game again. So now we see in the entities hierarchy, if we select the champion here, we can go over here. We see that it has the champ tag, new champ tag, and all that. And then we can scroll down and we see that the MOBA team is set to a value of blue team. Now, here's something a little bit interesting. If we go over to the client world, and then we find the champion, which actually is this guy right here, we can see that there is the champ tag as well as new champ tag and all that. And then if we scroll down, we see that MOBA team is set to none. So the reason for that is even though that this is set up as a ghost entity and it is essentially replicating some data, well, by default, really the only data that gets replicated is the transform component data. So we actually do have to do a couple extra steps for some things like, say, where we want to have custom components that get replicated. So that's one thing. And then one other thing that I do want to point out just while we're here real quick is there are these play mode tools that you can get to just by going to Window and Window Play Mode tools right here. And this opens up this window here. We can see the different connected clients and all that. And so what we can do is we can say do a client disconnect. We can click that right there. And if we have everything set up properly, then you should see that our champion entity should disappear. So that's what we want to happen is, again, if a player gets disconnected, we'll just go ahead and automatically clean up their entity. So anyways, we'll go ahead and fix that issue with the MOBA team here. All we need to do is just come back to this. In front of the team type value here, we're just going to put a little attribute, which is the ghost field attribute. Now there are some options that we can set on this ghost field attribute, and we'll be setting some of those a little bit later, but for something like an enum where we're just basically replicating this value, we don't need to do any additional configuration or anything. So now we will come back over to Unity, enter the game, the guy spawns, we can go to the champion, scroll down, we'll see that it is on the blue team, and then we can go over to the client world and then make sure we can click off the entity, click back on, so it is we know it is the actual entity from the client world. And then we do see that the value is now set to the blue team. So that's now being replicated across the server. So if we change this actually on the client end to say red and then click off, you'll see that it automatically flips back to blue. Now the reason for this is because the server still has complete authority over what this value is. The client, it really only has authority over any input data. So if we change a value on the client, it's basically just going to get reset back to whatever the value on the server is. So that is definitely something that can lead to a little bit of confusion with a server authoritative model like this. But you can see that if we do go back over to the server world and we select the champion, we come over here, we can say change this over to the red team. We can click off, you see that it stays on the red team again because the server has the authority over it. We'll come back over to our client world. Select the player and you'll see that it is now on the red team. So it is very important to understand that if we ever want to change any values for any ghost fields that are going to be replicated across the network, we need to make sure that we're changing those on the server side and not the client side. Okay, so let's get this to spawn in the correct position based off of whichever team that it is on. So what I'm going to do, I'm just going to go ahead and move this spawn position up here a little bit. And I'll go ahead and create a switch statement based off of the requested team type. So basically what this is going to do is we're going to look at the requested team type, and if it's on the blue team, we're going to spawn it at this position. If it's on the red team, we're going to spawn it at this position. If it's not the blue or the red team, meaning that basically the player is a spectator, Then we'll just go ahead and say continue. If you'll remember that we are still in a for each loop right here, so it's going to move to the next entity that's requesting to enter the game. Now we are going to add a couple more things to this switch statement later, but this is all we really need for now, is just kind of the spawn position to determine to spawn it in the correct spot. So now we'll go ahead and initialize a couple things on our champion. So under the common, we're going to create a system that runs on both the client as well as the server. This is going to be an I system, so we can just go ahead and create a struct. We'll call this the initialize character system. Now later down the line, we are going to be using this for our minions as well. So again, we'll just do a public partial struct, and this is going to be an I system. Now I'm going to go ahead and update this in the simulation system group, and I'll go ahead and set order first equal to true. So this kind of runs at the beginning of the simulation system group. So inside on update, we're going to need a local entity command buffer, and then we'll do an idiomatic for each loop. And we're going to be needing read and write access to the physics mass component, because we're going to be doing a little modification on here to make it kinematic. We need to read from the MOBA team so we can kind of color it based off of what team that it is associated with. And we only want to run this on any of our new entities, so we can just pass in the new champ tag to with any. I'm using with any because later on we're going to be using the new minion tag as well in here. So it can basically be either a new champ or a new minion. And finally, we need to do a dot with entity access here. Now for the tuple, we'll need we'll call this, say, physics mass, MOBA team, as well as the new character entity. And we'll go ahead and clean that up a little bit there. So first I'm just going to go ahead and set the inverse inertia on the physics mass to 0 for the indexes at 0, 1, and 2. Basically, this is just going to set this as kinematic, so it's not going to be affected by any outside physics forces, because that's not the type of game that we're going to be making. However, we do still need this to have a physics mass component, so other things can, say, collide with it. So to determine what color should actually be assigned to the entity, we're just going to go ahead and create these new float fours for blue if it's on the blue team, red if it's on the red team. We'll just use a switch expression to store that in a variable there. We can do an ECB.set component. Of course, we're going to be setting this on the new character entity, and then we'll do a new URP material property base color, and then we'll just go ahead and set the value equal to the team color. Again, I did a video on these material property overrides is what they're called a while back, where we can kind of essentially use different overrides to, say, apply different things like different colors to materials. And finally, we'll just go ahead and do an ECB.remove component, and we'll just go ahead and remove that new champ tag from the new character entity. And then don't forget, outside the for each loop, just go ahead and do an ECB.playback for state.entityManager. Now, in order for that to work, we do need to add this URP material property base color to the champion entity, so we can just do that through our existing champ authoring. So now we'll go ahead and enter play mode, start the host here. You'll see that nothing spawns in the center. That's because we are spawning in the blue base here. So you'll see that we now have the blue champion inside the blue base. Similarly, we can go ahead and re-enter play mode. We'll change this to the red team, start the host, and you can see we move up over to the red base, and we do have the red champion spawning in the red base. And then at this point, it might be a good idea for us to test a build. So we can just come over to our build settings, make sure we have both our connection scene as well as our MOBA scene. And then we'll just go ahead and hit build on these default settings here. And just go ahead and select a folder and let it build. It might take a few minutes to do so, especially for the first time it's building. So now that our build is completed, we'll just go ahead and enter the game here, and we'll start the host inside the editor. And then you'll see that over on this side, we have the blue entity spawning here. Go ahead and start up the build, and then we'll set this to client only, and we'll go ahead and assign them to the red team. We'll hit start client. If we move over here, we should now see a red entity here. And then if we move over towards the other corner of the screen, we should see our opponent, which is the blue entity, a little bit far away, but that's okay. We do see the blue entity here, and then same thing, we can go ahead and check to confirm that over in the editor side, if we go over to the red base, boom, we see the red champion entity. Perfect. That is exactly what we wanted to see. And then real quickly, let me just show you how spectator mode works. So basically we have the game set up with a blue client and a red client already connected. So we can go ahead and change this to a client connection mode, and we'll set the team selection equal to spectator. And when we say start client, you'll see that we spawn into the world just kind of at the center here, and we can move our camera over towards the blue base here. You see that we do have this blue client that we can see. Of course, we can move all the way up over to the red base, and you'll see that the red client is connected here as well. So the spectator client is essentially just, it works just like any other client does because it receives ghost snapshots from the server. However, the only difference is it doesn't have a player that we can actually control. And again, to support this feature, we don't have to do anything extra. We basically just don't spawn a player for that new client. Fantastic. So the next thing that we should probably do at this point is allow the player to actually move this champion around just by right clicking around the map. Okay, so I'm just going to talk a little bit about the input theory here. So input is pretty much the only thing that clients should have any authority over. Now the server will still make the final determination if a given input can occur and what effect it has. Again, we want to minimize the possibility of our players cheating. So it's always important that, on the server side, we're still running some validation to, ensure that that input, actually makes sense for the given context. So the way the input data works is actually a constant stream of data between clients and the server. Now we're going to be using this IInput component data, which is an easy to use wrapper for ICommand data. Now, let me get into a little bit about what ICommand data is, because again, this is kind of the building blocks of the IInput component data. And we do also use ICommand data specifically for a couple of things. So this ICommand data is actually a kind of a wrapper for a dynamic buffer where it has data for the last 64 network ticks. And we basically set data on a per tick basis, and we can look up what that data is at any given tick. Now this is necessary to have for our simulated rollback so that when we're, needed to roll back a number of network ticks, we can reference what that data was at any given tick. So here's basically how we create one. So I have this public struct called a damage this tick. You'll see that it is an ICommand data. And so the only thing that I have particularly defined is this public integer value. However, with this ICommand data, we are forced to include this network tick property called tick, which we can get and set publicly. And so basically using this network tick, we can say, hey, at, this current tick, whatever, current tick index it is, the value is this. However, the next tick, the value is something different. And again, it's basically a dynamic buffer, which is going to keep data for the last 64 network ticks. So we can always kind of key in and say, oh, hey, what was the damage this tick 4 ticks ago? And that way we can kind of look up what that data was. So now I'll talk a little bit about this IInput component data. So it's still basically a buffer of input from the last 64 network ticks. However, we don't actually need to worry about getting and setting the network tick. That's kind of all done for us automatically. So you can see that the way we do this is, we'll be creating this champ move target position. You see that it implements this IInput component data, and we just have our public float through value on here. Again, we don't need to worry about getting and setting the network tick. As we use this input component data, all that stuff is happening for us behind the scenes. And there is one other thing that I do want to point out, and that is related to input events. And so the reason that we have these input events is our input is gathered on the main update loop, which often runs much faster than the server tick rate. So essentially what that means is that multiple update ticks will all map to the same network tick. Because again, if the network is updating at 60 frames per second and our game is updating at 120 frames per second, well, on one frame, that basically means that 2 client frames are going to map to one single network tick. Now, this ends up being a little bit of a problem because if, say, a player presses a key on one frame, we'll set the IInput data for that network tick saying, oh, hey, the player pressed this key on this network tick. However, if the next frame, which is still maybe associated with that same tick as the previous frame, and then now the player is no longer pressing that key, well, we're still going to be running that system to continually update that IInput component data, and it's actually going to end up clearing out that previous value that we set. So what Unity has created is this thing called input events, where basically we can say define these different input events. You can see a couple of the ones that we have here. And then what we can do is we can go to one of these input events and do a .set, and then that basically will set it for the current frame. And then we want to go ahead and check it. We can can do a .isSet. Now you can actually look into the source code of how it works, and it's kind of interesting where basically, anytime that you call set, it just kind of like increments a counter, and then at each network tick that gets reset. So anyways, that's a quick little overview about how input works. Now let me go ahead and show you how to implement it in our game. Okay, so to do that, we're gonna go ahead and add a few more component types. So we can go to our champion components little script here. So we'll just go ahead and create a regular iComponent data for character move speed. We'll call this character move speed, so both the champions as well as minions can use this. Now we don't need to make this any type of ghost component or anything like that. Reason being is because we're just going to set this value inside the inspector, and the value isn't going to change. Now if we ever did want the character's move speed to change, maybe if there were any type of like power-ups or slowdown effects or something like that, then we would want to make this a ghost component. Now the next thing that we're going to need to do is a component to essentially store our player's input, and that's going to be synchronized from the client up to the server, and then the server can kind of process that input and determine where the player should move. So go ahead and create a public struct for the champ move target position. And so instead of making this an iComponent data, this is going to be a special type, which is an input component data. Now this input component data, it's kind of interesting because it's actually a dynamic buffer under the hood, but it kind of acts like a component. So it is kind of interesting, and you'll see some of the quirks with it as we go on. So just go ahead and create this public float3 called value here. Now we do want this to be a ghost component, so we can go ahead and add the ghost field attribute on here. Now one thing that we do want to make sure that we do when we're using floating point numbers is we want to set our quantization number. So the quantization number, this basically is kind of a little bit of an optimization so we can save on the amount of bits being transferred between the client and the server. If we set the quantization to 0, that means there's no quantization and the just full float value is going to be transferred. That's totally fine for this use case, but you could say, put like a value of like 10 or 100, and it does a little bit of multiplication to, again, kind of save on bits, but we can just go ahead and set the quantization to 0 for this use case. Next thing that we're going to want to do is we can actually put a ghost component attribute above the actual component itself, and then we can set the prefab type. There are a couple different options that we can send here, but the one that we want to set in this case is the prefab type. And then we're going to be doing this on, say, all predicted clients. Basically what this means is this component is only going to get synchronized across any entities that are considered predicted entities. So now that we have all that set, let's go ahead and get the input for our player. Okay, so before we actually get input for our player, there is one other bit of initialization logic that I'm going to do on our player. This is only going to be on the client side. So we'll go ahead and say add a new struct here. So we'll call this the initialize local champ system. So this is going to run on the client side only, and it's only going to run against the champion that client has ownership over. So we'll make this a public partial struct. And this is going to be an iSystem, and this is only going to run in the client simulation as well as these thin client simulation worlds. Now in onCreate, we want to make sure that this is only running when there is a network ID component. So that means that we are actually connected to the server. We'll go ahead and create an entity command buffer, and then we'll just go ahead and do an idiomatic for each here. So we're going to query for anything with a local transform, and then we can do a with all ghost owner is local, and a with none of a new type that we'll need to create, which is the owner champ tag. So we'll come back to our champion components, and I'll just go ahead and add this up towards the top here. Basically, this is just a tag that's going to be applied to the champion, and that way we can query for just the specific champion that the player has ownership over. So it's kind of a handy thing to have. We also will need our with entity access. For the variables, we'll do transform as well as entity, and we're going to be adding a couple things to this later on, but this is fine for now. So we can do an ECB.add component. We'll go ahead and add the owner champ tag to this entity, and we'll also do an ECB.set component again on the entity, and this time we'll do a new champ move target position. And so we're basically just going to initialize the target position to the current transform dot position just so it doesn't move anywhere off the bat. Basically, the client should spawn and then it shouldn't move anywhere. So that reminds me that we do need to go over to the champ authoring, and then we'll go ahead and do an add component on here. And we'll just go ahead and add that champ move target position to the player entity as well. So at this point, our initialization is complete. Now we're actually ready to gather input and send that up to the server. So this is all happening client side. So we'll go ahead and create a new class. We'll call this the champ move input system. I'm going to be doing a system base on this one, and then we are going to be updating this in a special group, which is the ghost input system group. Now this group is only ever going to run on the client side, so we don't need to worry about specifying whether this runs on the client or the server. But basically just us saying that it's going to run inside this ghost input system group means that it's going to run on only the client. Okay, so I've gone ahead and created a little bit of this input system. If you do want a little bit more details on kind of how I have this set up, go ahead and check out the recent video that I did on using the new input system with Unity ECS. But basically I referenced a input actions asset at the beginning of this video. Basically that is where we define what buttons and key presses do different things within the game. And so basically in this case, I'm subscribing to events for the select move position. So when it's performed, we're just going to go ahead and call the on select move position. So this is basically what happens when we right click anywhere in the game world. So the idea is if we do a right click, what we're going to do now is do a ray cast out into the world, and it's going to hit somewhere on that ground plane, and then that is essentially going to be the target position that our player is going to move towards. So in order to do that, we're going to need to do a little bit of an interesting way to reference the main camera because, well, ECS is ECS. So we'll go over to our clients, we'll create a new class. We can call this main camera. This is going to be a public class called main camera, which implements iComponent data. And the value on here is going to be a public camera value, just like that. And then in order for us to easily reference this, we'll also go ahead and create a public struct called main camera tag, which is just an empty iComponent data here. So we'll go ahead and create the beggar here, and we're not going to initialize it with anything, but we do want to do make sure we're doing an add component object main camera, and then we're also doing a regular add component for the main camera tag. Of course, we're adding that on this entity, and then finally we'll go ahead and move this off into its own script here. So then this basically just kind of adds the components to this particular entity. Now we're going to need to go ahead and create a system which actually assigns the main camera to this main camera object. So again, this is going to be another client system. I'll go ahead and set this up as a system base. So initialize main camera system. So again, public partial class is going to be a system base. And we'll do a world system filter for the client simulation. We don't need this to run on thin clients because thin clients don't have cameras. On create, we'll do a require for update of the main camera tag. And then on update, we'll go ahead and set enabled equal to false because we only want this system to run one time. We'll go ahead and get a reference to the main camera entity. So we can do a get singleton entity using the main camera tag. So that means we're going to get the entity which has that tag. So we can use the entity manager to do a .set component data, again, on this main camera entity. And we'll do a new main camera, and we'll set the value of that equal to camera.main, and that's just the regular Unity camera.main. Okay, so now that the main camera is set, now we can come back to our champ move input system, and in the on select move position, we can actually go ahead and shoot out a raycast into the world. So actually another thing that I'm going to do up in this on create here is I'm going to add a require for update. And we're going to pass in the owner champ tag. That basically means that we only want to be running this system if the client who's connected actually owns a champion. So that means, if we're a spectator, we're not going to have this owner champ tag existing in the world. So we're just not going to go ahead and update this system because, it's not going to work because there's no, champ that we can apply this input to. So anyways, in the onSelectMove position, we'll just go ahead and do a little bit of setup. We do need to get a reference to the collision world. I did do a brief video on, doing kind of like a click to get input a little bit while back. The video is a little bit outdated, but most of the main concepts should still kind of be there. But we basically just do a get singleton against the physics world singleton and get the collision world that way. We can get the camera entity just by doing the get singleton entity against the main camera tag again. And then we do just need to do a get component object using the entity manager to get that main camera reference by passing in this camera entity, which we just got, and then getting the underlying value. So that's the actual, reference to the actual main camera in the scene there. So now we'll just do some pretty basic stuff. We'll get the mouse position using input.mousePosition. I'm going to set the mouse position.z to 100. So that basically means that this is going to essentially raycast out a distance of 100. And then we can use our main camera and do a screen to world point, passing in that mouse position, and then we just get a world position out of that. So now using that, we can create a raycast. The way that we do that is by first creating a raycast input where we basically define the start position, which is going to be the main camera's transform position because we want to start from the main camera. And the end position is going to be the world position. So it's basically kind of, wherever we clicked into the world, it's just going to be aligned directly, to the mouse. And then we're going to be using the selection filter, which we created a little bit earlier. I don't think I actually mentioned much on that, but we're creating a new collision filter, and then we can essentially use, manipulate the bits here to say that this belongs to group with ID number 5, which is the raycasts group, and then the collides with group, and then what we're colliding with is the ground plane. So we're only colliding against the ground plane. And this basically maps to what I was talking about earlier with these physics category names. So you can see category 0 is the ground plane and category 5 is the raycasts category. So once we have our raycast input, then we can actually go ahead and run the raycast by taking our collision world and doing a .cast ray, passing in our selection input, and then out of that, we can get a variable for the closest hit. Now the type of this is a public struct called raycast hit, and we can use this to kind of figure out where that collision actually hit and everything like that. So first, let's go ahead and get a reference to our champ entity. So we can just do a system API.get singleton entity again on our owner champ tag. So you see that why this is super easy to have this owner champ tag. We can get the singleton entity and just have an immediate reference to our champion just like that. And then all we really need to do is just use the entity manager to set the component data on the champ entity. And then we're going to create a new champ move target position. And the value is going to be the position of that closest hit that we got from our raycast. So if our raycast actually hits the ground plane, it's going to basically just take that position, and then we're going to set that value on the champ move target position. So this is basically just us setting it in the local client. Now, because this is the special input component type, this data is automatically going to be synchronized up to the server. Now, it should be noted that this kind of acts like a dynamic buffer, so that it keeps a reference to the past like 60 or 64 of the last move target positions, and this is going to be synchronized up with the server. Now, I keep saying that we're going to be synchronizing up with the server and everything like that, but it's a little bit misleading because the code that we're actually going to be using to move the champion is actually going to be running on both the client and the server. The reason for this is going to be known as a predicted system. Now, the advantage of this is we can kind of have the benefit of the server authoritative networking model, where the server is the end all be all determining what actually is happening in the game, and that's how we can ensure that our players are not cheating, because we can do some validation logic on the server side. However, we do also want the same system to run on the client side. The reason for that is because we want the input to be very reactive. Right when the player clicks in the game world, we want the player to immediately start moving in that direction. Because if we just ran this on the server, then there would be a little bit of a delay between, when we clicked and then when the player started moving, and that just wouldn't lead to the best player experience. So for this, we're going to go ahead into our common scripts here. We're going to go ahead and add a new struct. So we can just call this the champ move system. And this of course is going to be an iSystem. So it will be a public partial struct implementing iSystem. So inside our on update, we'll go ahead and get a reference to delta time, because of course, if we're going to be moving our player, we do need to normalize for frame rate and all that. So we can get this by doing a system API.time.delta time. We'll do an idiomatic for each loop here. We'll do a system API.query, and we're going to, of course, be writing to our local transform. So we'll do a ref RW local transform. We of course need our champ move target position. So, the destination of where we're going to be moving to. And finally, the character move speed, because again, the character is going to be moving at a certain speed. The last thing that we need to do is do a with all, use the type simulate. This is just kind of like a built-in type that all entities have. It's actually an enableable component, so it can either be enabled or disabled. Now, having this in the with all ensures that, only the proper entities that are supposed to be predicted are actually going to run in the system. Because the way that these prediction systems work is they can kind of, run under different circumstances. And by adding this with all simulate in there, it ensures that it is only running on the appropriate entities and it's not, doubling up and running when it shouldn't necessarily be, because it wouldn't really do anything. So pretty much any time that we're using a predicted system, we always want to have the with all simulate in here. Now inside the for each, we'll just go ahead and set our variables. So here will be transform. We can have our move position and then our move speed, and we'll go ahead and clean this up a little bit here. Whoa. Now, one thing that I definitely forgot to do is we need to actually make this a predicted system, and the way that we do that is actually super easy. We can just do an update in group, type of predicted simulation system group. So this is a simulation group that is where all of our predicted systems are going to be running, and this will run on both the client as well as the server. So back to where we're moving our player, I'm just going to go ahead and store our move target in a variable because we're using this a couple times here. So we can just do a move position dot value. So even though I said that this is kind of like a dynamic buffer where it stores the input for the past 60 or 64 ticks, whatever it is, still just by doing this move position dot value, that's going to get the value at the current network tick. So this happens with a lot of the code generation stuff. If you want to dive into the disassembly of that, you definitely can. So anyways, here's a little bit of a hack that I'm going to go ahead and do, or set the move target dot y equal to transform dot read only dot position dot y. This is basically just because the central position of our player is going to be in the center of them, and if we're selecting a move target on the ground, then we don't want the player to move into the ground. So I know everything in this game is just completely flat and level, so we can do this little hack where we're just setting the move position to whatever it is, just go ahead and just move that up a little bit. So we're basically only moving in the X and Z direction is what I'm trying to say. So first thing I'm going to do is just go ahead and do a quick distance calculation between the current position as well as the target position, just to basically see if we are already at the target position. So if that distance is smaller than a very small number, we can just go ahead and continue. So next up, we'll just go ahead and figure out the move direction just by normalizing the difference from the move target to the move position. And then once we have that move direction, we can calculate the actual move vector, where we're just multiplying that direction times our speed times delta time. So we know, how much in a vector 3 context we need to move this exact frame. So once we have that, we can just go ahead and do a transform.value.rw.position plus equals our move vector, just like that. We also do want to go ahead and set our rotation, and we can use a quaternion dot look rotation safe. The forward direction is the move direction, and the up direction is math dot up. So this basically just kind of, points the character in whichever direction that we want to face. Okay, so before this works, we do need to do one thing, which is go to our champ authoring and actually go ahead and add a public float field here for move speed. And then we just need to go ahead and do an add component on the entity, new character move speed, and then we pass in the value is equal to authoring.moveSpeed. So back over in Unity, first go to your camera entity, make sure you set that main camera authoring script on there so it can find our main camera. Then we'll go to our prefab and the champion prefab, and we'll set the move speed to say a value of 3.5. So go ahead and enter play mode here. We will start the host and scroll over to our champion entity. And then once we're here, we can right click, and then we now see that our player, wherever we right click, our player is going to move to exactly that position there. And we can, of course, click around as much as we want to make them, move in any direction. And it's just going to move to the location of the last pressed input. So if we, press there, it's going to go to that position. And so even if we, move our mouse, it's still just going to go to that last position that we clicked. Now, before we actually test this in a build, I do want to fix one thing. So we'll actually have our camera, actually spawn above the player so we don't have to scroll every time. Now, luckily, I've already done that for you. So if you just go ahead and open up the camera controller script here, just go ahead and uncomment out the start method. This is going to basically just move the camera when we first get into the scene. However, this isn't always going to work. This is only going to work if the player either requested the blue or the red team, because this, you can kind of dig into this code if you want a little bit, but it looks for that initial client team request entity that we created kind of all the way back at the beginning, that kind of client side only entity that kicked off the system to actually send the request. But one thing that we're also going to do inside our on update is set the camera for the auto assign team. And that's because if we do an auto assign, then we actually don't have a team set for that particular client yet. So in this case, we do just need to go to the owner champ singleton entity, get the MOBA team component off of that, and then we can set the camera's position to either the blue team or the red team position. So now just come back to Unity and go ahead and run a build of it. All right, so we'll go ahead and start up the host in the editor here. You'll see that we're on the blue team, and then we'll join as a client on the red team. So now we can kind of move towards each other. This may take a sec here. Okay, so now we can see that once our guys are close to each other, when I click around, you'll see that the position is now being synchronized across the network. So when I'm in the build and controlling the red character, you'll see that the red character is moving over in the editor over here. And then same thing, if we go over to the build, I'm just going to have this guy move over here so then I can come back to the build. And then we can see that the blue guy is moving over in the build as well. So just exactly as we would expect it to. Sweet. Okay, so at this point we have a pretty basic networking game set up. So basically we can have multiple players enter the same game environment and some data can be synchronized across the network between them. And so I know it was kind of already a lot to get to just this point right here, and there's still kind of a lot to go. So I think right now would probably be a good time to take a break if you've been at it this whole time, because the next thing that we're going to get into is the whole combat system. And so there's going to be a whole bunch of different things that we're going to be doing with that. So I'd probably recommend, stepping away from this video for a little bit and maybe just kind of playing around with some things in your project so you make sure that you really understand all the fundamental concepts of how the netcode is set up. So feel free to just kind of play around with things and see by, adding, removing, changing things, figure out what breaks, and, just try to play around with it a little bit more at this time right now, because the next section gets into a little bit more of the combat stuff. And that's going to take a little bit of a while to implement as well. But anyways, I really do hope that you're enjoying this tutorial so far. If you are, I'd really appreciate it if you hit that like button and also subscribe to the channel for lots more awesome content on data-oriented design in video games. Okay, so I just want to talk to you a little bit about the theory of our combat system. This is going to be just kind of like a high-level overview about how I have the combat system set up, but if you do want a little bit more detailed information about how I have set up this combat system, well, I have done a couple streams over on our show, The Hot Path Show, specifically episode 4 and episode 6, where I go over kind of a little bit more in depth about how I have this combat system set up. So the first one, I kind of go over a data-oriented damage setup where I show how we can kind of use ECS to deal and take damage. And then the combat system, this kind of shows a more flexible and full-featured combat system and a cool kind of ability system that's all related to that. So if you're doing a little bit more in-depth, I would go ahead and recommend checking out those videos. However, just kind of in general, the way that we have these combat systems set up is we have these attacks, and these attacks have colliders, which essentially are set as triggers, which are going to invoke trigger events. And once these trigger events are invoked, we're going to add damage to a damage buffer. The reason that we have a damage buffer is because, say, if a certain character got attacked or got hit with multiple things in one frame, we do want to kind of, buffer all those things up, and then later on in the frame we can kind of add everything up in that buffer to see how much damage a particular entity took on a given frame. So again, each frame, the damage and the damage buffer is then applied to that entity. And then kind of getting into kind of more of the stuff along the lines of the combat system, there are a bunch of different properties that we can add to our different entities. So for example, we can have events that are fired. So when the base is destroyed, we'll have a game over on destroy, which is going to trigger the game over state. Okay, so now is the time to implement the combat system. So we're going to start with the data side of things, and we're going to go ahead and create some combat components. So I'll just go ahead and create a new script here. We can call this combat components. And this is going to be part of the common directory because both the client and the server will use these. So basically the way that this is going to work is every entity that can basically be damageable should have some type of hit point counter, and we'll just use integers for keeping track of hit points. So let's just go ahead and define a public struct for max hit points. This of course is just going to be a regular iComponent data. And we'll have a public integer called value here. Next up, we'll create another public struct. This one is going to be for the current hit points. This is another iComponent data, and it will also be a public int called value. However, this time around, we are going to make this a ghost field because we do want this to actually be synchronized across all the clients. Again, we don't need to do this for the max hit points because the max hit points isn't going to be changing throughout the duration of the game. Next up, we're going to implement a damage buffer. The idea with the damage buffer here is that anytime an entity gets damaged, a basically damage value is added to that buffer. The reason that we want to do this is because if we say have multiple things that could damage an entity on one single frame, then all those things could be added up into that buffer. And then at the end of the frame, we're going to go ahead and add up all those values into the buffer to know what is the total damage per frame for that entity. So we'll go ahead and define a public struct called damage buffer element. And this is going to be an iBuffer element data. And we can have another public int called value. However, this time around, we do want this to be essentially a ghost buffer. So what we can do here is define a ghost component attribute, and then we'll also define the prefab type is equal to ghost prefab type dot all predicted. The reason that we're doing this is because we want basically any predicted entities to have this damage buffer, so we can kind of like in real time show the actual damage as soon as it happens when we're predicting clients. But if we're not predicting a client and we're just interpolating it, then we don't need to worry about kind of having that immediate accuracy of the damage being affected to an entity. So what's going to end up happening is once the damage is applied, the current hit points is going to end up having the current value from the server, and then whenever that just gets synchronized down to the client is plenty fine for our use cases for interpolated clients. And then we are going to need one last component. This is going to be a special netcode type. So we'll define a public struct, and we can call this damage this tick. And this is going to be an iCommand data. So an iCommand data is a special network component type. It is actually another one of these like buffer type components where it is kind of like actually a dynamic buffer under the hood. So it's kind of similar to how input data works. In fact, I'm pretty sure input data is basically iCommand data under the hood here. So you see that we do have a little bit of a red squiggly line under here, and we do need to implement some missing members. And so that is this public property for network tick, which is get and set. So the idea here is that, anytime we add something to this buffer, we not only apply a specific value, but we also apply a specific tick so that we know, which server tick that this data is associated with. So let me just kind of complete this and show you a little bit what I mean here. So we'll have a public int called value. So basically what we can do is we can pass in a value for the network tick, and then we can get what the current damage at that network tick is. So when we're adding any damage to this tick, we have to set the network tick value to say, hey, at this particular network tick, this is the damage at that. And then we want to read from it, we can pass in the current tick, and then we can see if there's any damage that should be applied to the entity at that particular tick. Now with these command data, it pretty much handles all the serialization and deserialization and synchronizing across the network for you. So we don't need to do any of that. So we also will go ahead and set this as a ghost component. We'll do another prefab type of the all predicted. We're also going to add another option, which is the owner send type, and we'll set this equal to send to non-owner. So the idea with this is this basically means that data is only going to be synchronized from the server to other predicted clients that are not the particular owner. The reason that we do this is because this ends up overwriting values on our local clients, and it can lead to some weird kind of desynchronization issues. Essentially, the reason that we do this is because we already know this value is correct on our local clients. However, other clients might not have that same information. So we're going to basically add all these things into an authoring component. So I'll go ahead and create a new Unity script here, and I'll just call this hit points authoring. So basically anything that has hit points is going to get this here. So we'll just do a public int, and then we can have our max hit points here. We'll go ahead and create our baker. So we'll do a public class hit points baker. This is going to be a baker, passing in the type of hit points authoring. Of course, we'll implement that bake method there. So here we'll get a reference to the entity, which is equal to get entity transform usage flags dot dynamic. So here you'll see that I'm just going ahead and adding the current and max hit points, setting the value equal to the max hit points from the authoring. Next up, we'll go ahead and add our damage buffer element. Of course, we can do an add buffer of the damage buffer element, of course, adding that to the entity. And then for adding our command data, we also will go ahead and use the add buffer. And this is the damage this tick. Of course, we're adding it to the entity as well. Okay, so we can come back over to Unity and we can go to our different prefabs. We'll start with the base prefab here. Go ahead and add in the hit points authoring, and we can put a max hit points value of say 500. Let's go ahead and do the same thing with the champion. We'll add a hit points value. Let's do 1,000 for the champions. Even though we haven't implemented any minions yet, they still will need this prefab, so we can go ahead and add in a max hit points of say 250. And then for the towers will also need a max hit points, and let's say 250 for these as well. So this basically gives us everything that we need to have these elements part of combat. And one other thing that we do need to do before we actually start getting too deep into the combat system is for these static objects like the towers and bases, we need to basically just give them a way to assign a team to them. So we can do that very easily here. So what I've done here is just created a new authoring component for MOBA team authoring. You can see that our team type is just exposed in the editor, and then we can just assign whatever that team type is to that entity. So now we'll only need to add this to the base and the tower. So we can go ahead and add the MOBA team authoring, just leave the value as none for now for these, and then we actually will go into the MOBA scene here under MOBA entities, and then we just have to go through to each of these. So for the blue base, we can set this to the blue team. Red base, of course, will be red team. And then we can just go through the different towers, and basically the ones on this side of the map will be blue, and then the ones on the other side of the map will be red. So just go ahead and assign the team type to all the different towers here. Okay, so now that pretty much everything in our game can take damage, now it's time to actually deal damage. So we'll give the players the ability to shoot some different types of abilities. So the first one that we're going to use is the AoE ability. Basically, this is just going to spawn a sphere wherever the player is, and then everything within that radius of the sphere will get damaged. So for starters, we'll need another input component for our champion. So we'll just go ahead and open the champion components file here. And we'll go ahead and create another public struct for the ability input. This is going to be another one of those input component datas. And then for here, we're going to use a public input event for our AoE ability. So this input event is a special netcode type. The reason that we are using this is because things can get a little bit weird if we don't have a perfect synchronization between the application's frame rate and the server tick rate. Most times that is not going to be the case, and that's probably not necessarily what we always want, because say our server's updating at 60 frames per second, it would be really nice if our client could update at a higher rate than that. And so the problem that this solves is essentially missed inputs. So basically anytime that say an input is pressed, we can set this input event to say that it has been pressed. And then so let's say the next frame comes around, but we're still on the same server tick as before, but now the player is no longer pressing that input key. Well, this leads to a little bit of an issue, because if we were to say just, overwrite the data for that current server tick, that basically says that the player is no longer pressing that key, and then that gets sent up to the server saying that, the client wasn't pressing the key or anything, so it seems like the input is almost ignored. So anyways, these input events are very handy for things like where you need to press a key and make something happen, so you can kind of have much more reliable input. Now this also will need to be a ghost field, and we'll also go ahead and make this a ghost component, and then we can also set the prefab type equal to the all predicted ghost prefab type. And then we are going to have a couple other input events for some other abilities later on. So we'll just go ahead and just leave this AoE ability input here for now. So on our client side, we can go ahead and create a new class here. This would be the ability input system. And so this is going to be a system base. So we'll make it a public partial class system base. Of course, implement the on update, and then we'll just go ahead and get a reference to our MOBA input actions. Of course, we'll just need to create a new one, and then in the on start running, we can enable this, and in the on stop running, we'll disable the input actions. So the way that I've chosen to do this is we can do a var new ability input, and we'll set this equal to a new ability input, just that input component data struct that we've just created. And what we can do here is we can just look at our input map and see if the AoE ability was pressed this frame. If it was, then what we can do is say new ability input dot AoE ability dot set. And that's how we basically say that it is going to be set for this server tick. And then now we actually just need to go ahead and apply that to our player. So we'll say for each, we'll do a system API.query ref RW ability input. Just call this ability input, and then we'll say ability input dot value RW is equal to that new ability input right there. Now we just need to go ahead and add this ability input to our player. So then just come back to our champ authoring and go ahead and add an ability input component to our champ entity. Okay, so next up, we're actually going to need an entity for our player to spawn for these AoE abilities. So back in the combat components, I'm just gonna go ahead and create a new regular iComponent data called ability prefabs, and it just has one public entity for the AoE ability right now. We'll come back to add the next ability later on. And so to actually set this in the inspector, I'll go ahead and create a new ability authoring, of course having a public game object for the AoE ability prefab. And then inside the baker, we can just go ahead and set that AoE ability entity equal to a get entity, passing in the authoring.aoE ability with a transform usage flags of dynamic. Now I'm going to go ahead and choose to add this to my champion. So we have the ability authoring, and we of course need an AoE ability prefab. So I'll just go ahead and create a empty game object because I should have everything that I need to build here. So we can just call this the AoE sphere, and then we will need to add a mesh renderer and mesh filter to it here. So for the mesh filter, we'll go ahead and use the AoE sphere, which is part of the sample assets. Same thing with the AoE material. So if we actually go ahead and center this at 0, 0, 0, we can go ahead and just see what this sphere looks like. It's just kind of like a red translucent sphere. This also will need a physics shape component. And I'm going to go ahead and set this as a sphere with a radius of 5. For collision response, we want this to say raise trigger events, because we don't need this necessarily like physically colliding with things in the world, but we do just want it to trigger when it overlaps something. So on belongs to, go ahead and set this to nothing, and then we can set this to the abilities group, and it collides with everything. And then we only want it to collide with a few things, so go ahead and set this to nothing. And we'll set this to champions, minions, and structures, because those are the only 3 types of things that we want it to hit. We will need to go ahead and add a ghost authoring component to it here. And we have a little warning because it's not a prefab yet, so that's just fine. We go ahead and set an importance of like 500 if we want to for this. By default, let's go ahead and make these predicted. And this also will need our MOBA team authoring, because it will need to be basically assigned to a team. If someone on the red team spawned this, we only want it to damage people on the blue team. And then the last thing that we do need is we do need a rigid body as well. The reason that we need this is so that we can actually raise these trigger events. So we can just leave pretty much the default, but we'll go ahead and uncheck use gravity and check is kinematic, because we don't want it to really be moving around. So once we have that, we'll go to our prefabs. We will save this as a prefab and go ahead and delete it out of our main scene. Come back to our champion, and then we can go ahead and come down to the ability authoring and drag in the AoE sphere prefab. Okay, so before we make the system, I'm actually going to go ahead and make an aspect. The point behind an aspect is it's a way that we can kind of group multiple components and treat it as one. The reason that I'm going to do this is because for when we're doing these ability systems, we need to interface with a bunch of different components. And it ends up getting pretty messy if we're just doing these inside, regular idiomatic for eaches or iJob entities. Now, usually if you're going to use an aspect, this is kind of like a refactoring that you would end up doing later. So it's not necessarily something that you have to do. And it's not something that you usually start with. But the reason that I'm starting with it now is because I know that we are going to be using them. So might as well just go ahead and start off with this instead of having to, change a bunch of things around later on. So under common, we'll go ahead and add a new struct here. We can call this the AoE aspect. And so this is going to be a public read-only partial struct because there is some code generation that does take place. And this is going to implement the IAspect interface. Now here is where we basically define kind of the components that we want to be part of this aspect that are required, say any entity that has all these components or is associated with this type of aspect. So here we'll do a private read-only, and we do need read-only access to our ability input. So we can do a ref ro ability input and just call this underscore ability input for now. Next up, we do also need read-only access to the ability prefabs. We also want read-only access to the MOBA team. So this is essentially the team that the entity is a part of. And finally, the local transform. Now, I should have pointed out that this aspect is going to be essentially associated with the champions in our game. So we basically, know when the user presses the button to spawn the AoE ability, we can spawn it, at the same place as the entity who's trying to fire it and set it to the same team and everything like that. Now, after that, we're going to go ahead and add some public properties so that we can actually access outside of this aspect. So have a public bool for should attack, and we can get this off of our ability input dot value ro dot AoE ability dot is set. So that's how we can basically test if that set has been set for that input event. Next up, we'll have a public entity for the ability prefab. Of course, we can get that off the ability prefabs dot value ro dot AoE ability. We'll have a public MOBA team just called team, which just returns the MOBA team dot value ro. we can just go ahead and get this whole component because we're just going to be setting this full component on the entity that's going to be spawned anyways. And then finally, we can do a public float 3 for our attack position, and we get that from our local transforms position. So now to actually go ahead and spawn one of these guys, we'll go ahead and come back into the common. We'll create a new struct. This will be the begin AoE ability system. And of course, this will be a public partial struct implementing the iSystem interface. And this is going to be part of the predicted simulation system group. So we'll go ahead and get our onUpdate method going here, and we can actually burst compile this method here. So we'll go ahead and add the burst compile attribute on here. Now, first things first, I'm going to go ahead and get a reference to one of the built-in entity command buffers. The one that I'm going to be using is the begin simulation entity command buffer system, and we can just do a .singleton to get a reference to the singleton. You'll see that Writer is throwing a little bit of a warning at me, and we can just do Alt-Enter, which will automatically apply this require for update for the begin simulation entity command buffer system singleton. Reason that I chose the begin simulation entity command buffer singleton is because typically when we're spawning things, we want to spawn them towards the beginning of the frame. Otherwise, we can end up with this weird glitch where they basically render at the center world position for one frame. I've talked about that in videos previously, but it's just kind of like an order of operations type thing here. So anyways, to get the actual entity command buffer itself, we can do an ECB singleton .create command buffer, passing in state.world unmanaged. Now this is where things start to get really weird with the netcode. So what we need to do first here is get a reference to the network time singleton, which we can just do a system API.get singleton network time. And of course, we can go ahead and add the require for update on there. So we can do here a exclamation mark network time dot is first time fully predicting tick. If that is the case, we'll go ahead and return. So real quick, I just want to explain this line of code here that we're implementing. So this is called is first time fully predicting tick. Now this kind of goes back to the notion of full versus partial ticks. Again, we can think of a full tick as an update loop on the client side, which is associated with one network tick. And again, if our client is updating at a faster rate than the server, then we're going to end up having, partial ticks in between each full tick, which is related to that, full one network tick. And again, we want to have this so our game, feels responsive and is constantly updating on the client side, even though it's not constantly getting update from the server at like 360 times per second. So this is first time fully predicting tick. This is going to be false on partial ticks, and it's true on the full tick. However, it's going to be false when we're re-simulating that full tick. So if we ever have to actually, go back a number of network ticks and re-simulate, through that tick, it's going to actually be false. Now, the reason that we want to use this is for things like events where we're, maybe spawning some new things into the game, or we're playing some effects, basically things that, just kind of happen one time that aren't like necessarily easy to kind of interpolate between. So this is basically what we're using this for. Now, if I'm being completely honest, when I was developing this, I didn't completely understand the purpose and reasons for this. However, I recently put up a forum post over on the Unity forums where some people gave a lot of really good information about the full versus partial ticks and kind of the context of when you would use this is first time fully predicting tick. So I'll have that link down in the description below, and I would highly recommend reading through that if you do want a little bit more information on that. Now, again, when simulation happens, these systems can kind of run multiple times. So we only want the rest of the system to run if it is the first time that we are actually fully predicting this tick. So after that, we'll actually get a reference to what the current tick is. So we can say var current tick is equal to network time dot server tick. So then now here we can do our idiomatic for each. So we'll go ahead and do a for each system API dot query, passing in our AoE aspect. And we also want to go ahead and do a with all of the simulate. Again, we want this to only be running on the proper things for this predicted system. And we can just call this variable AoE. So later on, we're going to have to do some crazy things with determining if this ability should be on cooldown or not. But for now, we'll just go ahead and implement a very basic version of this. So we can say if AoE.shouldAttack. So again, that basically means that if the player has pressed the attack button in this current network tick, you can go ahead and instantiate a new AoE ability. So we'll do an ECB.instantiate, passing in the AoE.ability prefab, and then the ability transform is equal to local transform dot from position, and we can go ahead and pass in the AoE dot attack position. And then of course we'll just need to go ahead and do an ECB dot set component, passing in the new AoE ability as well as the ability transform. And then also we can do an ECB.setComponent on the new AoE ability and apply it to the AoE.team. So basically the team of the champion should also be applied to the team of that new AoE ability. So this should be enough to just spawn the AoE ability, but it's not actually going to do anything. So to test it out, we can come back over to Unity and press the Q key, and we should see that an AoE ability spawns here. Now, a couple of issues with this is you see it just basically stays around forever. It's not destroying itself. And we can also just, spam this button a bunch of times and, spawn a million of these because there's no cooldown or anything like that. And then also at this point, we're still not applying damage to anything. So let's just first take care of the one where it's going to destroy the ability after a couple seconds, because that's going to be the easiest one to implement. So come back to our combat components, and we'll need 2 new components to actually implement this destroy on timer. So we'll go ahead and do a public struct for destroy on timer. And this is going to be an I component data. We'll have a public float for the value. So now this is basically going to be a fixed value representing the time in seconds that this object will live before it gets automatically destroyed. Now, the thing about timers and networking is, again, basically all of our networking is based around our network server tick time. So what we're actually going to do, rather than running actual timers and having that timing data be synchronized across the network and some weird things being synchronized with that, instead what we're actually going to do is when we first instantiate this object, we're going to calculate the server tick that this object should be destroyed at, and then we're going to save that value in a component. And then so basically every client knows when it should clean up that particular entity. So here we'll do a public struct destroy at tick, and this is going to be another I component data. And then here we'll have a public network tick called value, and we'll go ahead and make this a ghost field. So I'll go ahead and create an authoring component for this destroy on timer. You see that there's just a public float for destroy on timer, and then we're just setting the value for that destroy on timer component there. Now the next thing that we need to do is actually create a system to initialize the destroy on tick. So this is going to be under the common scripts here. So this will be the initialize destroy on timer system. This will be a public partial struct implementing iSystem. Inside of our on update here, we'll just go ahead and create a local entity command buffer. So now what we need to do here is get the simulation tick rate. So this is basically how many ticks the simulation simulates per second, and then we can multiply that value by our destroy on timer value. So we basically know how many ticks that entity should last for, and then we can add it to the value of the current tick. So then we basically get the value of the target tick of when that should be destroyed. So to get the simulation tick rate, so this is actually a new feature part of the Netcode for Entities 1.2 version. You'll remember back towards the beginning of the video, we created that Netcode configuration asset. So we can actually reference that by doing a netcode config.global, and then so that basically gets us the global asset that we have set in the editor. And then we want the client server tick rate dot simulation tick rate. So that should basically return us a value of 60, which is the default. And lastly, like I mentioned, we will need a reference to the current tick. So we can do a system API dot get singleton on the network time. And then here we can get the server tick. So again, this is the current server tick. And of course, we can also add in the require for update network time. So we'll go ahead and structure our for each here. So we'll do a system API dot query. So this is looking for everything with a destroy on timer, but it does not yet have the destroy at tick. And then we will need entity access to it so we can add in the proper component here. So we'll call this destroy on timer and entity and do a little cleanup there. So here we can calculate the lifetime in ticks. This does need to be an unsigned integer, so we can do a uint, and then we'll get our destroy on timer value, which again is the value, the float value in seconds, and multiply that by our simulation tick rate. So we can calculate our target tick by first setting it to the current tick. And then what we actually need to do here is we do a target tick dot add, and then here we can pass in lifetime in ticks. So that basically adds to that target component. And then we can do an ECB dot add component on this entity for a new destroy at tick. And the value here is going to be that target tick. And then finally, we can go ahead and do an ECB.playback, of course, passing in the state.entity manager. So at this point, this basically just initializes it to say, hey, you know, at this particular tick, this is going to be destroyed. So now we need to actually create a system that looks at everything with this destroy at tick, and then we see if we are, you know, at or past that, and then we can actually destroy the entity. Now to destroy the entity, I'm going to come back to the combat components and add another component, which is the public struct destroy entity component. And we're going to be using this for a couple things, and this is just an empty tag component here. So actually, if we want, we can just call this the destroy entity tag, so we're just very clear that there's no data associated with that. So now we'll go ahead and create a new system. So we'll go ahead and add a struct. So this is the destroy on timer system. Of course, this is a public partial struct implementing iSystem, and we'll go ahead and have this run in the predicted simulation system group. So we can just go ahead and create our update method here and add the burst compile attribute to it. And first thing that we can do is just get a reference to the end simulation entity command buffer system.singleton and get the actual entity command buffer from that. And then we'll also, in the next step, we'll get a reference to the current tick, again, just by using the network time.server tick. So now let's go ahead and iterate through everything that has one of those destroy at tick components. And again, because this is a predicted simulation group, we need to do a with all simulate. Let's go ahead and also filter out for anything that does not already have the destroy entity tag. And finally, we do need with entity access if we do want to add the destroy entity tag to it. And our variables are destroy at tick and entity. So basically what we can do is we can say if current tick dot equals, and we can pass in the destroy at tick value, or current tick dot is newer than, again passing in the destroy at tick value. Then all we need to do is just an ECB dot add component destroy entity tag on the entity. So basically all we just need to do is just compare the target tick at which that entity will be destroyed versus the current tick. If the current tick is essentially greater than or newer than our target tick, then we know that we need to destroy that entity, so we can just add the destroy entity tag to it. And finally, we do need to go ahead and add a system for the destroy entity system, of course, public partial struct implementing iSystem. And this is in the predicted simulation system group, and I've set order last equal to true. So I'll go ahead and set up a couple things in the on update here. So again, we'll get a reference to the network time. I'm going to go ahead and do that thing where it says the, is the first time fully predicting tick. If it's not, then we'll just go ahead and return. Also using the begin simulation entity command buffer singleton for where we actually are going to be destroying these entities. Now, predicted destruction systems are a little bit weird because we don't actually want to say destroy something on the client. We only want to destroy things on the server. Reason being is because if we actually destroy something on the client, but the server says, hey, this thing should still exist, then we get in kind of a weird state where, we no longer have that entity, and then we'd, have some weird issues where like the server has an entity and it's like trying to send things to the client that's not there. And unfortunately, there isn't like a super clean way to handle this in Netcode for entities kind of right out of the box. We have to do things a little bit more manually. So essentially what we end up doing is on the client side, we basically just move that entity very far off screen. And then on the server side, then we actually do the destruction. And then once that synchronizes with the client, then that entity actually gets destroyed and cleaned up on the client side. Now, I don't actually have like a way implemented right now where if there is some, desynchronization between the client and the server, if there is some disagreement about whether an entity should exist or not, I'm not really handling that case in a particularly good way. Again, I just couldn't really figure out a clean way to do this that I really liked. So this is probably something I'll end up doing like a supplemental video later on about. But for now, on the client side, we're just going to kind of move this entity far off screen, and the server is actually going to clean it up. So in our for each, we're going to do a system API.query, and then we're going to do a ref RW on the local transform, because again, on the client side, we're going to be moving this way far away. And then we also want a with all of the destroy entity tag and the simulate tag, and we will need with entity access to here. And then our variables are just going to be transform and entity. So first we can go ahead and check to see if it's running on the server. If it is running on the server, then we'll actually go ahead and destroy it. So we can do that just by doing an if state.world.isServer. Then here we can just do an ecb.destroy_entity, passing in our entity. We will come back to the system and do a couple extra things in certain cases. For example, if it's a champion, we want to respawn it. And if it's one of the bases, then we want to trigger the game over system. But for now, this is all we need to do. So otherwise, if we're on the client, we can say a else, and then we'll set the transform value RW position is equal to a new float 3, and we'll just pass in 1000 for each of the values there. So we'll come back to Unity and let's go to the AoE sphere prefab, and then we'll go ahead and add the destroy on timer authoring, and we'll destroy it after 3 seconds. Okay, so now you can just come back to Unity, hit the Q key, we'll see that we'll spawn the AoE sphere, and after a couple seconds, you'll see that it disappears. Again, we can spawn a new one in that place, and then it's go ahead and disappears. And then we can, continue to kind of, spawn these, and we'll see that each of them will disappear after a time of 3 seconds. And if this isn't working for you and you end up getting an error saying it can't find the global network configuration here, all you need to do is just go ahead and uncheck the box next to MOBA entities to unload the scene, and then it should all work out for you. And I can just actually go ahead and test to confirm that when we do reload the scene, that everything still works out for us as intended. So it's one of those things where it may just need to, unload it one time to kick it into gear. Okay, so let's get these AoE abilities to actually damage things in our game. So we're going to need to add a couple more combat components in the combat components script here. So we'll have a public struct for damage on trigger, and this is going to represent the amount of hit points that should be dealt to an entity that goes into the trigger of the AoE sphere. And then we also want to maintain a list of the entities that this particular ability entity had already damaged. The reason that we are going to do this is because we basically only want our AoE ability to apply damage only one time instead of once every single frame. And so we can just create an iBuffer element data called already damaged entity and just have a public entity value here. And neither of these need to be ghost components or anything like that. So then of course we'll create the damage on trigger authoring. Of course, we can have a public int where we set the damage amount, And then we just go ahead and add that damage on trigger component, setting the value, as well as adding the already damaged entity buffer. So we'll say come back to our AoE sphere prefab and go ahead and add in a damage on trigger with a value of 150. So now to actually create the system that deals damage when this AoE sphere overlaps with another entity, go ahead and create a damage on trigger system. So this of course is a public partial struct damage on trigger system, which is an I system. And because we are doing stuff with the physics system, we want this to update in the physics system group, but after the physics simulation group. So I'm actually going to go ahead and skip everything in this system for now, because we're actually going to be creating a job. So we can call this public struct damage on trigger job, and this is going to be an iTrigger events job. Now, if you aren't super familiar with the whole physics system, I've done some videos of this in the past. Some of them may be a little bit outdated, but basically these trigger events get fired when anything that's a trigger overlaps with some other collider / rigid body. And then inside these trigger events, we basically have two entities, entity A and entity B, and we need to figure out basically which entity is which based off of what components that each of these entities has. So to do that, we're going to get a couple component and buffer lookups here. These are all going to be read-only ones, so we can just go ahead and use the read-only attributes from the system.collections. So we'll do a public component lookup for the damage on trigger. So this is going to be how we can actually look up the damaging entities so we can see how much damage to deal. We'll have another component lookup for MOBA team called a team lookup, and this is how we can look up what team the damaging as well as damage receiving entities are part of, so we can basically ignore any friendly fire. Next up, we'll do a buffer lookup for the already damaged entity type. We just call this the already damaged lookup. Reason we want to have this is so we can basically ignore entities that we've already damaged. Again, we only want to deal damage to entities one time. And then finally, we'll do another buffer lookup for the damage buffer element. This is something that we had created a while ago, and this is the damage buffer that every entity that can take damage has. So we can basically add to that damage buffer, and then again at the end of the frame, all that damage is added up and applied to the actual entity. And then finally, the last thing that we do need is a public entity command buffer, which we just call ECB. So here we're going to figure out which is the damage dealing entity and which is the damage receiving entity. So we'll just go ahead and define a couple of variables for that. So we can basically do a couple if statements here saying, if entity A has a damage buffer and if entity B has a damage on trigger, then we know that the damage receiving entity is entity A and the damage dealing entity is entity B. Then we'll just do the opposite of that, where we check to see if entity A has the damage on trigger component, and if entity B has the damage buffer, then that basically means that entity A is now the damage dealing and entity B is now the damage receiving. Now, if there is another case where the entities don't fall into this category of one is the damage dealing and one is the damage receiving, we'll just go ahead and return out of the rest of this job here. So after that, we're just going to check to make sure that we don't apply damage multiple times to the same entity. So we can get a reference to the already damaged buffer just by using our already damaged lookup, and then we pass in the damage dealing entity, and then we just iterate through everything in that buffer, and then we just check to see if that current already damaged entity equals our current damage receiving entity. If that's the case, then we can just return out of the job. After that, we'll do a quick check to ignore friendly fire. So we'll do team lookups on both the damage dealing and damage receiving entity. And then we can see if the values of these are the same. If they are the same, then again, we can just go ahead and return out of the function. And then after this, we can actually apply the damage that we need to. So the way we do that is we just get the current value for the damage on trigger just by using the damage on trigger lookup. And then all we're doing is an ECB.append to buffer on the damage receiving entity. We're going to create a new damage buffer element. We're setting the value of that to the damage on trigger.value. And then the other thing that we do need to make sure that we do is do another ECB.append to buffer. This time on the damage dealing entity, we're going to add a new already damaged entity. and then add in the damaged receiving entity. So that damaged receiving entity is now part of that already damaged entity buffer, so it doesn't get dealt damage multiple times. So now we need to actually schedule the job, so we can come back here and go ahead and do an on update, and we can actually burst compile this method here. So inside the on update, we can do a var damage on trigger job is equal to a new damage on trigger job. And then here we can set all the parameters that we need to. So the damage on trigger lookup is equal to system API dot get component lookup for the damage on trigger. And then we do want to set is read only equal to true. And then just go ahead and fill these out for the rest of the components and buffer lookups. And then finally, we do just need an entity command buffer as well. And I'm going to use the end simulation entity command buffer so I can get a reference to my ECB singleton here, and then do an ECB singleton dot create command buffer, passing in state dot world unmanaged. So here, once we have the damage on trigger job, then we can go ahead and schedule this. So we do a dot schedule, and here we do need the simulation singleton. We can get the simulation singleton by doing a system API dot get singleton, passing in the simulation singleton. So we'll pass in the simulation singleton into where we're scheduling it. We also need to pass in the dependency, and so we'll just use the state.dependency here. And the proper thing to do is actually assign this to the state.dependency as well. Okay, and then before we test this out, we're going to fix one error. You'll remember that we've been seeing every time we enter play mode, it yells us about dynamic objects not being ghosts or what have you. So we'll just go ahead and fix that real quick just by going to the base and adding the ghost authoring component here. We can go ahead and set the values for this to just be an interpolated and static. Static basically just means that it receives fewer updates from the server. And we can set, say, an importance value on this of 50. And then for our tower, we can do a ghost authoring component. We can do another importance of 50. We'll set it to a default mode of interpolated, and we'll just leave the optimization mode as dynamic right there. So now when we enter play mode and start the game, now we should no longer see those errors. Great. And then we can move our player over to the first red tower right here in the middle lane. Okay, so we can go here, and then I think I found the correct entity in the hierarchy, so we can just go ahead and spawn one of these AoE abilities. You see that it does kind of encapsulate this tower right here, and then you'll see that over in our inspector, the current hit points is still set to its maximum value of 250. Now that's because we're not actually applying the damage to the current hit points yet. However, you see that the damage buffer has one element, and if we open that up, you see that it has a value of 150. And if we continue to spawn, say, more and more and more of these, then you see that this damage buffer just keeps increasing. So now we have a bunch of different elements, each with a value of 150. So now what we want to do is actually go through these damage buffers, add up all these damage, and then apply them to the current hit points per frame. And by the way, this is on the server world. And then if you actually go over to the client world, you'll notice something a little bit interesting. So we actually won't see that damage buffer on here. We'll just see the current hit points. Now, if you remember, when we set up the damage buffer component, we set it to occur on only predicted entities, and this is actually an interpolated entity, not a predicted entity. So interpolated entities, they basically only get that end hit position because we don't really care about predicting them because they're not predicted. Okay, so we'll go ahead and in the common directory create a new system for calculate frame damage system. This is going to be part of the predicted simulation system group, and we want order last equal to true, just so we can kind of account for any damage that has already been applied in the, say, predicted simulation system group. So in our on update, we do need a reference to the current tick. And of course, we can get that by doing a system API.getSingleton on the network time.server tick. And then of course, we can add in the require for update network time. And we'll go ahead and structure our for each query. So here we'll be looking for everything with a dynamic buffer of the damage buffer element, as well as the dynamic buffer of the damage this tick. And of course, we want to do a with all simulate, because we are running this in a predicted system group. And then the variable names are going to be the damage buffer and damage this tick buffer. So first thing that we can do is we can check if the damage buffer is empty, meaning it has not received any damage this frame. If that's the case, we do still need to update the damage this tick buffer because this is one of those special command data buffers. So basically we can do a .add command data, and we can add a new damage this tick element. And then here for the network tick value, we're going to set this equal to the current tick, and then we'll just set a value of 0. So basically we do have to continually keep updating this damage this tick buffer, because otherwise if we didn't do that and we actually went to check to see what is the current value at that tick, then it just returns the value for the most recent value that we added. So in that case, that might end up to some weird situations where we could again apply damage multiple times when we don't actually want that to happen. So we do just basically need to continually updating this to 0 every frame that the buffer is empty. By the way, we should be able to burst compile this system here. Anyways, so if the buffer is not empty, now we'll actually calculate the total damage for this frame. So we'll say total damage equals 0. Reason we want to do this is because we want to check the damage this tick buffer and do a .get data at tick, and then we pass in the current tick and output that to a damage this tick. Reason that we're doing this is because again, we can have multiple client frames equal to one server tick. So if there already has been damage applied in one server tick, but we haven't actually applied it to that entity, then we basically just want to say start with that value and add from that. So we can say total damage now is equal to the damage this tick dot value. So now here we can do a for each on our damage buffer, and we'll just do a total damage plus equals damage dot value. And then after that, we can go to our damage this tick buffer dot add command data, passing in a new damage this tick. Tick is equal to the current tick, and the value is equal to total damage. And then finally, we're just going to go ahead and do a damage buffer dot clear. So at this point, we're basically just kind of adding up all our data, moving it from one buffer to another. However, this other buffer that we're adding to is that special command type, which can be synchronized across the network. So now to actually apply the damage, we're going to create another system. So we'll go ahead and create a new iSystem for the applied damage system. This is also going to run in the predicted simulation system group. We'll set ORLast equal to true, and we'll just make sure that it updates after the calculate frame damage system. So here we can just create a burst compiled on update. And the first thing that we are going to need is a reference to that current tick, which we can get from the network time. And if we want, we can add the require for update as well. Here, I'll just go ahead and add in a local entity command buffer, and our for each, we'll do a system API.query. And here's where we actually are going to be writing to the current hit points. And we also will need read-only access to the dynamic buffer of the damage this tick. Again, because this is a predicted simulation group, we want to do a with all simulate. And we also will need entity access here. So we'll have the current hit points, damage this ticks, damage this tick buffer, and a reference to the entity. So we'll actually just do a couple quick tests to make sure that we're operating on valid data. So we'll say if exclamation mark damage this tick buffer dot get data at tick, passing in the current tick and getting an output of the damage this tick. So if we don't get anything, then we can just go ahead and continue. If we do get anything, we want to make sure that the damage this tick dot tick is actually equal to the current tick. If it's not, we'll go ahead and continue. Again, this is kind of another one of those safeguards to just make sure that we actually are operating on data for the current tick and not like a previous tick. And then basically at this point, we can just go ahead and modify the current hit points just by doing a value.rw.value minus equals damage this tick.value. So just subtracting out the value for the current tick. And then we can also just do a check to see if current hit points.value ro.value is less than or equal to 0. If it is, we'll use our entity command buffer to go ahead and add the destroy entity tag to the entity. And then at the end, we can just do an ECB.playback passing in state.entityManager. So at this time, we can go ahead and enter the game. I'm going to go ahead and hit the Q key. And we'll see that we basically spawn that AoE sphere. Again, it overlaps with the tower. And then we can now see that the current hit points for that tower is set to a value of 100. And we don't have anything in that damage buffer because we, again, basically added to it and cleared it out. And then we can also confirm that over on the client world, we can see that the current hit points is set to a value of 100, again, because that is a ghost field. So it's just receiving that data from the server. So now if we go one more time and hit the Q key, we should see that that entity actually does get destroyed. So it is no longer in the inspector here. And that is exactly what we want to happen. And we can also confirm that we could say maybe go up to another one of these towers here, go ahead and just hit the Q key 2 times to destroy it, and that works just fine. And I think we'll have to hit it a couple times to destroy the base here. And yep, the base does get destroyed. Of course, we're not doing any game over logic. And then we also can confirm that friendly fire is working appropriately. So we'll just go ahead and go to the closest tower on the blue team. And we can confirm that if I hit this a bunch of times, damage will not actually be applied to the tower because it is on the same team that we are on. Awesome. So that's kind of the start of the combat system here. And now we're going to continue building off this combat system to do more and more things. And as we go along, I think you're going to start to see one of the real advantages of data-oriented design because we have all this infrastructure for this combat system created already, that things are just going to kind of start working as we add in, more of the minions and other things kind of on top of this. But before we get to that, let's just implement that one other complicated thing that I was talking about a little bit earlier, which has to do with the ability cooldowns. So we'll start as we have been by creating a couple of data components. So back in the combat components script, first thing that we're going to do is create a public struct, and this will be called the ability cooldown ticks. And this is just a regular iComponent data, and we don't need to have it a ghost component or anything like that because the values are staying the same. Now we're going to go ahead and have a unsigned integer, so just a public uint for the AoE ability. When we add in the other ability, it's going to go, we're going to have another value in here as well. Basically, the idea here is this is going to store the tick count of how long the cooldown will take. So again, we do have to do one of those kind of calculations where we take the time in seconds and we multiply that by the server tick rate. So we get the number of ticks that this ability will be on cooldown for. And then the next thing that we're going to have to do is a public struct, which I call the ability cooldown target ticks. And so this is another iCommand data. And so because it is an iCommand data, we do need to implement this network tick property here. And this one will in fact be a ghost component. And we do want this to only apply to the predicted ghosts. Now on here, we will have a public network tick value for the AoE ability. And basically what we're going to do is we're going to be setting this command data to essentially the target tick that the ability will expire from its cooldown. So again, kind of at the beginning of the application, we're going to calculate this AoE ability uint, basically the tick count of how long it will be on cooldown for. And then anytime we actually use the ability, then we're going to set this network tick on the ability cooldown target ticks of which it's set to expire at. So we'll go to the ability authoring, which we have right here, and we'll create a public float for the AoE ability cooldown. So this is the AoE ability cooldown in seconds. Now we're actually just going to go ahead and calculate the tick count right inside this baker here. So now the way that we can actually reference what the current simulation tick rate is we can actually just have a public reference to our netcode config asset here. And then from that, I've just created a little private property for the simulation tick rate, which just goes to that netcode config.client-server-tick-rate.simulation tick rate. And inside the baker, we can do an add component on the entity. We'll add a new ability cooldown ticks. And then here for the AoE ability, we can set this equal to, which I have to cast this to an unsigned integer, but we'll do the authoring.AoE ability cooldown multiplied by authoring.simulation tick rate. So again, we're just calculating the number of ticks based off of the AoE ability cooldown in seconds. And then we also just need to go ahead and do an add buffer, adding the ability cooldown. I really called it the AoE ability cooldown target ticket. Why didn't anyone correct me there? AoE ability cooldown target ticks. So we'll come back to Unity, select the champion prefab, and we now have a field for the AoE ability cooldown. So we'll set this to a value of 5 seconds. Then we'll go ahead and set the netcode config asset to our netcode config asset. Now, obviously this cooldown isn't doing anything right now, so let's make it actually do something. So we'll come back to the AoE aspect, and you see we're going to add a couple more things to here. So this is, kind of one of the reasons why I wanted to make this an aspect, is just because there are so many components on here. So go ahead and add on the private read-only ref RO for the ability cooldown ticks, and a private read-only dynamic buffer of the ability cooldown target ticks. And then we can add some more public properties. So we can have a public unsigned integer for cooldown ticks, which is that. And then we can just have access to the dynamic buffer this way. So back in the begin AoE ability system now, before we check if we should attack, let's go ahead and check to see if we are on cooldown. So we'll just go ahead and create a couple of variables for is on cooldown and a cur target ticks, which is a new ability cooldown target ticks. Now this is a little bit of a strange and interesting thing that we have to do. It kind of honestly feels like a workaround that I have implemented to solve a particular problem when we're testing our game, particularly when we're testing it in the editor. Basically, what ends up happening is sometimes if the server is running too slow and then it skips over network ticks, then it leads to a situation where if we say had that target cooldown tick on the tick that it missed, well, then we actually never would go off cooldown, and then, at some point, the player would actually not be able to fire their weapon. So what we actually end up having to do is at each tick, we have to simulate back a number of ticks to see if the cooldown was up at any time in that couple tick window there. Now, luckily, using the network time, there is a way that we can actually see the number of ticks that the client or server is simulating. So most of the time this value is going to be 1, but if it skips 1 frame, then this value is going to be 2. So then we know to actually simulate back 2 frames. So we have to actually use a for loop here and basically kind of go back in the simulation to see if the ability should be on cooldown or not. So this is one of those things that just drove me crazy for a very long time, but this seems to work just fine. So the way we can do this is create a for loop, and we'll set I equal to an unsigned integer of 0. And then we're going to be doing this while I is less than network time simulation step batch size. Again, if we're just simulating 1 tick, this is going to be a value of 1. If we're simulating 2, 3, 4 ticks, that is going to be the value of this here. So what we can do is we can set, say, our test tick and set that equal to our current tick, and then we just subtract I. So then we basically are testing ticks in the past. So basically we'll just do a quick check here to see if we cannot get data at the current tick that we're testing. If we can't, then we'll just go ahead and set this current target ticks that we're testing, the AoE ability on it, we'll just set it to a network tick of invalid. And then if the current target ticks.AoE ability is equal to the network tick.invalid, or the current target ticks.aoe ability is not newer than the current tick, then we've basically determined that we are not on cooldown, and we can just go ahead and break out of this for loop here. However, if we go through this whole thing and we determine that we still are on cooldown, we'll just do a continue, and this continues to the next iteration of this for each loop up here. So basically all this is to just determine, if we are on cooldown right now. So that is just to determine if we're on cooldown. So now we actually need a way to say that we are on cooldown when we do fire the attack. So anyways, we're just gonna go ahead and do inside this if AoE should attack. Remember, this is when we are actually instantiating these AoE prefabs. So we're actually only going to be running this stuff on the client side. So we can say if state.worldUnmanaged.isServer. Just go ahead and continue. Otherwise, we'll figure out the new target tick. So we'll say var new cooldown target tick, and we'll just set this equal to the current tick for now. And we can do a new cooldown target tick dot add, and then here's where we can pass in AoE.cooldown ticks, again from our aspect. And we can set our cur target ticks.aoe ability equal to the new cooldown target tick. And then we have to do another weird little workaround that I found where we need to get the value of the next tick. So we'll say var next tick is equal to current tick. And we can do a next tick dot add, passing in 1u, and then the cur target ticks dot tick is equal to the next tick. And then here we can actually go ahead and do the cooldown target ticks dot add command data and go ahead and pass in that cur target ticks. Now, I know this is kind of a lot of weird stuff happening here, but let me just try and explain this as best as I can. So because we're setting command data, we're only setting this client side. So that's why we're just kind of ignoring the server for here. Now, this part is pretty self-explanatory. Basically, we're just calculating the current target tick of when the ability is off cooldown. And then the reason that we're getting this next tick is because when we're adding the command data, we actually need to add it at the tick after the current tick. Because if we actually add it at the current tick, then it just spawns locally, but then the server kind of has some like desync and thinks that it, shouldn't actually be spawned, and then it just gets cleaned up right away. And even if you are, overlapping an enemy tower or something like that, it doesn't apply any damage at all. The server just doesn't thinks that it actually gets spawned. So we do actually need to set the current cooldown target tick at the next tick so that, when we are simulating the next tick, we can see that data at that tick. Again, really weird workaround, but something that was making me pull up my hair for a very long time until I figured out that we just need to assign this at the next tick, basically. So I'm going to come over to Unity, and I'm basically just going to go ahead and spam the Q key, and we're going to see that only one of these AoE spheres is going to spawn. It should clean up after a couple seconds, and then it'll be a few more seconds until the cooldown has expired. So we'll just go ahead and have him start moving so it can be very obvious. And then you see that I have spawned the first one, and then it's still on cooldown, and then we spawn the second one, still on cooldown, and spawn the third one. So that's perfect. That's exactly what we want to see. And we have a couple seconds of cooldown in between the different casts of the AoE sphere here. Okay, great. So now we have the ability to cast one ability, but what's better than casting one ability? Casting two abilities. So now we're going to go ahead and implement the skill shot ability. The skill shot ability, basically we're going to press the W key, and then the client is going to essentially get an arrow UI element that basically points to where the mouse is facing. And then when the player left clicks, it's going to cast that ability in the direction of that arrow. So we're just going to start with the basic ECS side of things, and then we're going to go ahead and move over into doing some of the UI stuff. Once we have that UI stuff in place, then we will come back to do the other UI stuff that we've been skipping over, which is kind of like the ability cooldown UI, as well as the health bars for everyone who has health. So we'll start in the combat components script and add a couple things. So in the ability prefabs, we'll need another public entity, and this will be the skill shot ability. Next up, we can scroll down to the ability cooldown ticks, and this will be the public unsigned integer for the skill shot ability. And then finally, for the ability cooldown target ticks, we'll also need a target network tick for the skill shot ability. And then I'm going to go ahead and create one last component in the combat components, which is the aim skill shot tag. So this is basically a tag that gets added when we are aiming the skill shot so we can run certain parts of our system. So now in ability authoring, we can add another public game object for the skill shot ability, public float for the skill shot ability cooldown, and then down here in the ability prefabs, and then we can set the skill shot ability equal to get entity authoring.skillshot ability with the transform usage flags of dynamic. And then just go ahead and set the ability cooldown ticks for the skill shot ability equal to an unsigned integer of authoring.skillshot ability cooldown multiplied by the simulation tick rate. And then there is one other component that we need, and this is going to be part of the champion components. And this is a public struct, which we can call the aim input. And so this is also going to be an I input component data, a public float 3 value. A reason that we need the aim input is to basically keep track of where the mouse is pointing, so we know which direction to shoot the skill shot in. So this is going to be a ghost field with a quantization of 0, and it's also going to have the ghost component attribute with the prefab type of all predicted ghost prefab types. And then also, while we are in the champion components, we do need to add a couple more of these input fields or input events, which are ghost fields. So we'll have a public input event for the skill shot ability and a confirm skill shot ability. So the skill shot ability basically kind of like initializes the attack, and then the confirm is when we actually click to cast the attack. And then we'll just need to go ahead and make sure that we add the aim input to our champion entity in the champ authoring component. So next up, we're going to go ahead and do the aspect things. So go ahead and create a new struct, which will be the skill shot aspect. So this is a public read-only partial struct implementing iAspect. So on this skill shot aspect, this is going to look very similar to the AoE aspect. In fact, it has pretty much the same first 6 components here for the ability input, ability prefabs, cooldown ticks, MOBA team, local transform, and the dynamic buffer of ability cooldown target ticks. Additionally, we also have the aim input for when we actually need to go to aim the mouse and such. And then we also do have a public read-only entity, and this is a direct reference to the champion entity because we do need that for a few things in the system. And then down here, I just have kind of public accessors to everything. So we have a should attack. So again, we're just looking at our ability input and seeing if the skill shot ability is set. So that's kind of the initial, begin attack here. And actually, maybe I'll just go ahead and rename that as such. Next, we have the confirm attack. So pretty much the same thing, except it's against the confirm skill shot ability. So when the player actually clicks, the ability prefab is set to go into the ability prefabs, get in the skill shot ability here. Again, we can check what the team that it is on. We'll have reference to that dynamic buffer here, as well as the cooldown ticks for the skill shot. We do have a reference to the attack position, which is basically just the position of the player at any given time. And then the spawn position, we're actually going to go ahead and create a new local transform, doing a from position rotation. Then we can get the position off of the local transform. And then using the quaternion.look rotation safe, we can use the aim input value and then also use the up vector. So we can basically get a direction based off of, you know, wherever the player's mouse is facing. Okay, so I'll just create a new begin skill shot system, which is just an I system. We'll go ahead and do a little bit of setup in the on update here where we create a local entity command buffer. Again, just getting access to that network time. And if it's not the first time we're fully predicting this tick, just go ahead and return out of here. And we will need this current tick for calculating the cooldown in just a moment here. So we'll set up our for each to do a system API.query for the skill shot aspect. And of course, we're going to do a with all simulate. And we're also going to do a with none filter against the aim skill shot tag. So this is kind of only the beginning portion right here. Just have our skill shot there. So a lot of this is going to be very similar to before. So we're just going to go ahead and check to see if we are on cooldown. And so again, we just have to do that weird thing where we need to like simulate back a little bit. You know, same exact code as before pretty much here. So what we'll do here is we'll say if !skillshot.begin attack continue. So basically, you know, this is just kind of like a breakout case. So if the user did press the begin attack, then all the code past here is going to run. Otherwise, we'll just, you know, continue to the next element in this for each loop here. And so that is basically all we need to do for now. When we come back, we're going to add a little bit of UI stuff here. We can just go to the next part of the system, which is going to be another for each loop. So this will be a system API.query again against the skill shot aspect. And this time we want the with all with the aim skill shot tag as well as the simulate component. So we'll just go ahead and first make sure that we actually have pressed the confirm attack button. If we haven't, continue, but if we have, go ahead and instantiate the new skill shot ability. So once we've instantiated it, we'll go ahead and figure out what its spawn position is going to be. Again, this actually returns a local transform, so I probably could do a better naming convention on that. But anyways, we'll just go ahead and set the components on the skill shot ability for that new position. Same thing, we'll also set the skill shot.team, so it has the same team as the entity that's spawning it. And we just also want to go ahead and remove the aim skill shot tag from our champion entity. So this part of the system no longer applies. Now after this is basically when we're spawning that skill shot out into the world. So at this point we do want to reset its cooldown. And actually we're going to be using this server check a couple times. So up here I'm going to go ahead and add a var is server is equal to state.world_unmanaged.isServer. And again, we're only running this on the client. So if it is on the server, we'll continue. And then we have to do again that weird thing where we basically get the data at the current tick, calculate what the target tick is going to be for when that cooldown is expired, and then we actually are setting that at the next tick. So same thing as before pretty much. And then just don't forget at the end to do an ECB.playback, passing in state.entityManager. And don't do what I did and forget to put it in the predicted simulation system group, because if you do, you're gonna have a bad time. Okay, so we'll come back to Unity. I'll go ahead and create a sphere here, and we can call this the skill shot ability, and we'll go ahead and make a prefab out of it here. So what we can go ahead and do is I'm going to go ahead and remove the sphere collider in favor of the physics shape type. This is going to be a sphere with a radius of 0.5. That's perfect. We'll just change the material from the lit material to that AoE material, so it has that same kind of translucent red. Go ahead and collapse these things a little bit here. This of course will also need a rigid body, and we'll just disable use gravity and set is kinematic. This also is going to need a destroy on timer. We'll go ahead and destroy it after 2 seconds. We'll also give it a damage on trigger. So you can see that this is really nice because we already have these things set up and all this stuff is just gonna work. Then of course we'll also go ahead and add a MOBA team and just set that for none, because again we're going to be setting that when we actually go to spawn it. Then after that, we don't want to forget to add the ghost authoring component. We can set this to say an importance of 500, and let's make it default predicted. Make sure we set our physics shape to raise trigger events, and then we do want this in the abilities category, and then it should collide with champions, minions, as well as structures. So we'll go ahead and delete this out of the main scene here. go onto our champion prefab, and then we can go ahead and set our skill shot ability right here. And the skill shot ability, let's just say that has a cooldown of, I don't know, 3.5 seconds. However, at this time, we actually won't be able to spawn it because I did forget one thing. We do need to listen for input. So in our ability input system, so I'll just go ahead and add in 2 more if statements to see if we have pressed the skill shot ability or confirm skill shot ability buttons this frame. If that's the case, then we'll just go ahead and set the appropriate either skill shot ability or confirm skill shot ability. So now we can enter play mode, and you can see that we can still press the Q key to go ahead and spawn that one ability. Now we can also press the W key, and you see that, well, nothing happens. And why is that? Because we still need to confirm the attack by left clicking. You can see that the attack basically just spawns in place of, wherever we were at that time. And we can also kind of confirm that the cooldown stuff works as well, which it does seem to be doing. So now at this point, the next thing that we want to actually do is go ahead and move this skill shot in a particular direction. So in combat components, let's go ahead and have a public struct for ability move speed, which is an I component data with a public float value. And we'll of course need to go ahead and create an authoring and Baker script for this here. And then here you can see that I've created a very simple movability system, which updates in the predicted simulation system group. Inside our bursted on update, we'll just go ahead and get a reference to the current delta time. We'll do a system API.query. Of course, we're going to be writing to the local transform, and we do want to read from that move speed. Now, because we're running it in a predicted simulation system group, we want to have the simulate tag, and then we'll just call our variables transform and move speed. And you see that all we're going to be doing is just moving the transform's position in the direction of the forward direction multiplied by the move speed.value times delta time. So then we'll just come back to Unity and go ahead and do an add component, and we'll add the ability move speed authoring, and let's set this to a value of 7.5. So now when we enter play mode, I'm going to press the W key and have my mouse kind of up here and click. You see that the skill shot ability kind of moves towards the mouse. We can test at a different angle here, and you can see that it is, well, still moving upwards. And that's because we're not actually setting the rotation correctly. Now, we actually are setting the rotation correctly, but we're not actually accounting for where our mouse is aiming yet. So we'll go ahead and need to just create a little system to actually aim towards the mouse. So this will be a client-only system, which I've just called the aim skill shot system. And of course, this is going to be in the ghost input system group, which is only running on the client side. So first, I'm just going to go ahead and create a private variable, which is of type collision filter, and I'll call it selection filter. Now this selection filter is going to belong to our raycasts category, and it's only going to collide with the ground plane. So the idea here is that whenever we have the ability in kind of that state where we want to determine which way it should be facing, we're just going to go ahead and shoot a raycast from the camera out towards the mouse, and we can do a little bit of math to determine what direction that should be from the player. So inside on update, we'll go ahead and structure a system API query. And of course, we're going to be writing to that aim input, and we do want to know the current local transform's position. And we are only going to be doing this on entities that have that aim skill shot tag. So the only time we really care about this aim input is when we're actually trying to aim that skill shot. Otherwise, we just don't need to worry about it. And we'll also make sure that we're only running this on our owner champ as opposed to other champions. So then I'm just going to go ahead and pretty much paste in some similar code to what we had before of when we were right clicking to select the position to move. Basically, all that we're doing is we need to do a little bit of physics and components setups here. Go ahead and create this raycast input here based off of our mouse position. And then we can actually just go ahead and run a raycast out into the world and just figure out the direction to that target. Just do a little bit of math on here and then set the aim input there. So now when we enter play mode, we can now hit the W key, and then if I point it in this direction, then you can see that our ability now basically moves in whichever direction that the mouse is pointing. So we have kind of a little bit of control over, how to aim these different shots here. Okay, so now we can just confirm that the skill shots can actually damage these towers. So we'll just go ahead and shoot a couple. I think it will take just a few shots here. And boom, just like that, the tower is destroyed. So we can confirm that these skill shots are properly applying damage to structures and other entities that can take damage. So at this point, our combat system is fully functional. However, we don't really get a whole lot of information about what is happening. So for example, we don't really have a clear indication about where the skill shot is going to actually go. And we also don't have any real indication about the cooldown times for our different abilities. And most importantly, we have zero information about how much health a particular entity has. So we have no idea if, our player is close to dying or we're close to destroying a tower. So those are the next parts that we're going to be implementing, is some of the different UI to give the player just a little bit more information about what is going on in the game. Okay, so at this point, we'd like to add in some UI elements to give the players a little bit more information about what's happening in our game. Now, all this stuff is going to be happening client side, so it's really not all that much different about how you'd implement UI in just like a regular Unity Dots project, but I'm still just going to go ahead and walk through everything for completeness sake, because there are a couple things that we do need to take into consideration with the way that we have some of the things set up on the Netcode side. So in our client directory, we'll go ahead and add a new class here, and this would be our UI components. And we can just clear out the default class here. Now there are three different types of UI elements that we're going to be adding. The first are health bars, which go above all the different players and towers and pretty much anything that can get damaged. This is basically just a very simple UI health bar slider with a little bit of an offset from their origin. The next thing that we're going to do is the cooldown timers. So you see there's kind of the Q and W little cooldown timers in the lower left-hand corner of the screen. And then those are basically just going to do a little spiral animation as the timer counts down, and then it will let the player know when they can use the ability again. And then the final thing that we're going to implement is kind of a little arrow that is projected onto the ground to tell the player which direction they're aiming the skill shot ability in. So we'll go ahead and start with the simplest one, which is going to be the health bar. So in our UI components here, we're going to create a public class called health bar UI reference. And this is going to be of type iCleanup component data. Now, iCleanup components are super helpful to use, especially when we're dealing with a game object that is referenced by a specific entity. The idea with cleanup components is we can do some essentially initialization as well as cleanup logic on them. So during kind of our initialization phase, this is when we're actually going to spawn a health bar into the world. In the regular update phase, we're going to update that health bar with the position and current values of that health bar, so it always stays above the player if they're moving around. And then in the cleanup phase, when the associated entity is destroyed, we're actually going to go ahead and clean up that game object as well. And again, we're doing a public class because the one field that we're going to have on here is a public game object. And because we just have a single value in here, we can call it value. And the other component we're going to need is a health bar offset, which is a public float3 value. And this will just represent the offset from the transform's origin to where we want this health bar to display. Now we can come back to our hit points authoring script, which we already have here. And then we're going to add a public vector3 for health bar offset. And then we're going to go ahead and add that health bar offset setting, the health bar offset from the authoring component. The idea here is that this means that basically anything that has hit points is also going to end up having a health bar reference. Now, we don't actually add in the health bar reference at this point. That's kind of where the initialization logic comes into play in our health bar system. Now, before we actually spawn these health bars, we're going to need to get a reference to it. So go ahead and open the MOBA prefabs script that we already have created here. And we're going to create a public class called UI prefabs, which is an iComponent data. And then we're going to have a couple fields on here, but for now we just have this one single game object field for the health bar. So that means we can come back to our MOBA prefabs authoring. We can go ahead and add in a new field for a public game object of the health bar prefab. And for a little bit more organization, we can add headers for entities and game objects so we can separate these out because we're going to be adding a few more entities and a few more game objects later on. So then coming into your Baker here, you can just go ahead and do an add component object. So the prefab container entity is a new UI prefabs, and go ahead and set the health bar equal to authoring.healthBar prefab. So then before we forget, we can just come back to Unity, go to our prefab container in the subscene here, and we go ahead and set the health bar prefab equal to this health bar canvas object that I have. Okay, so now we'll go ahead and create our health bar system. And again, this is going to be a client side only system. So we can just go ahead and add a new struct here, call this the health bar system. And of course, this will be a public partial struct implementing iSystem. And then above here, we want this to only run on the client side. So we can do the world system filter on the world system flags client simulation. And also I'm going to go ahead and do an update after type of transform system group. The reason that I'm doing this is because if we're going to be updating the position of the health bar, we want this to happen after our entity has moved for that frame. So we always are basically rendering it in the correct spot. So inside our on update here, we're first going to need to go ahead and create an entity command buffer. I'm using the nSimulation entity command buffer. And then we'll go ahead and do our first for each loop. And this is going to be the for each loop that is going to spawn the health bar objects for any entities that have not gotten them spawned yet. So the way that we can do that is we can do a system API.query, and we're going to need read-only access to a number of things here. So the first one is local transform, so we basically know where to spawn it. The next is the health bar offset, so we know how much to offset it off of the base transform, and we'll also need to know the maximum hit points, so we know how big to make this slider. Now the key thing here with this query is we need to add a with none, filtering out for anything that does not already have a health bar UI reference. Again, because we're not adding this component in the authoring. By default, anything that has, say, this health bar offset component is not already going to have that health bar UI reference. So we know that if we don't have that already, that means that we need to spawn a new health bar for that object and set it for a new health bar UI reference value. And because we are going to be adding a component here, we also will need the with entity access. Then we can come over to our variable here and create a tuple. So we'll have the transform health bar offset and the max hit points, as well as the entity. Make sure you don't forget that. So first things first, we're going to go ahead and spawn this health bar prefab. And so first we need to get a reference to that. The way we can do that is do a var health bar prefab. And we can use the system API, which has a managed API, which allows us to do a get singleton on any managed types, which we have this UI prefabs. Again, that is a public class of iComponent data, which is a managed type. And then we can get our health bar prefab off of there. So now we have a reference to that. Now by default, Writer doesn't pick up the required for update get singleton for the managed types here. So we do just have to come up to our on create and add that manually if we do want to add that restriction, which is a best practice to add that. So next up, we'll figure out the spawn position. So we can say var spawn position is equal to transform.position plus our health bar offset.value. So now we can create a new health bar by doing a object, make sure that's the Unity engine.object. So do an object.instantiate, passing in the health bar prefab at the spawn position. And we're going to put this just at a quaternion.identity here. Now I'm going to come outside of the on update and create this set health bar function here. Basically, this just takes in a game object for our health bar canvas object with the current hit points and max hit points. And that basically finds the slider and the children. And then it goes ahead and sets up the minimum, maximum, and current values here. This is a nice helper function to have because we are going to be using this in kind of the main system where we're updating the health bar. So we can do a set health bar, passing in the new health bar, and then for the current and maximum hit points, we can just pass in the max hit points because we know that this is it's going to always spawn at the maximum value. And even if for some reason it didn't spawn at the maximum value, it's going to go ahead and get updated the next frame anyways. So the last thing that we need to do is do an ECB.addComponent against our entity. We're going to go ahead and add a new health bar UI reference. We'll go ahead and set the value on there equal to our new health bar. So now let's come back over to Unity and we can start configuring our prefabs a little bit. So the three prefabs that are going to need these health bars are going to be the base. So we can go ahead and open the hit points authoring. We'll set the health bar offset on here to say a value of 3. On our champion, we can set this offset to a value of 2. I'm just setting the Y position here. And then finally, the towers are going to have a Y offset of 4.5. So now when we enter play mode, you'll see that the base, the champion, and the tower all have health bars above their head. However, unfortunately, when we move the player around, the health bar isn't going to move with the player, it's just going to stay in place. So let's go ahead and fix that issue right now. And so because we're going to have a couple different for eaches in here, it's helpful to add just a little quick comment above each of these so we know what each of these is doing here. And so the next part that we're going to be adding is updating the positions and values of the health bar. So here we're going to go ahead and do a for each system API.query. So we're going to need pretty much the same things as the previous query. So we'll first need the local transform, then we'll need the health bar offset. This time we do need the current hit points because we want to keep this updated with the current hit points. We still will need the maximum hit points. And then this time we also will need to query for that health bar UI reference. So again, this is only going to run on entities that actually already have that UI reference set up. So we'll go ahead and assign names to all these variables. We have our transform, offset, our current hit points, our maximum hit points, and the health bar UI. So first we'll just go ahead and calculate the health bar position, again just by using the transform.position and adding that to the health bar offset value. And then we can go to our health bar UI.value.transform.position and set that equal to the health bar position. And then we just need to go ahead and update the actual values. So we can do a set health bar on the health bar UI.value. Our current hit points is current hit points.value. And the max hit points is max hit points.value. Now you can see that this system is maybe not the most efficient because again, we are actually going to be updating not only the position of this every single frame, but also updating the actual UI values every single frame. So there may be some additional optimizations that we can do, but for the most part, this works just fine. So coming back to Unity, we can see that the health bars still spawn just fine. And now when we move the player around, we see that the health bar actually follows it around. And then now when we attack one of the opposing towers, you'll see that the health bar value is actually updated in real time, showing the current value of what that health bar is. And then if we damage it again, you see that the health bar decrements to 0. However, it doesn't clean itself up. You'll see that there is still a floating health bar in the middle of the air. So that's just the last part that we need to do, is actually clean up this health bar when the entity gets destroyed. So under this for each loop, we'll create another one to clean up the health bar once the associated entity is destroyed. So we can do a for each query here, system API.query. And here we're looking for anything with a health bar UI reference. And then we can do a .with none local transform. And then we also do in fact need with entity access here. And then so we can get the health bar UI as well as a reference to the entity here. Now, this may look a little bit weird if you're not familiar with how cleanup components work, but basically the way that cleanup components work is when an entity is destroyed, that entity still kind of exists, but it only exists with those cleanup components on them. All other components have been removed from that entity. So this is basically a way that we can now create a query for any of these cleanup components that need to go through their cleanup operation. So we're basically looking for anything that has this health bar UI reference cleanup component, but it no longer has a component that we know was on there and should always be on there, which is, say, the local transform component. So we're basically just looking for anything that needs to be cleaned up. So at this point, we know the entity has been destroyed. We just need to do our final cleanup operation to actually destroy this health bar UI reference. So all that we need to do in this case is do our Unity engine.object.destroy, and then we can pass in the health bar UI.value. And then we will just go ahead and do an ECB.remove component using the type of the health bar UI reference off of that entity. And then once all the cleanup components have been removed off that kind of, I guess you could call it like an orphan entity, then that entity is actually destroyed at that point. So now when we come back to Unity and we press the Q key to cast a spell and destroy that tower, you'll see that the health bar does in fact clean up and we no longer have a health bar flying in midair. Okay, so the next thing that we're going to implement is the actual cooldown timer. So you can see there's the Q and W here. If we actually go into our in-game HUD, I can say go to one of these, and under each of these, you'll see that there is a cooldown mask with a source image, which is set to a filled image type, radio 360 fill method. And basically using this fill amount, we can control this little mask looks on the timer here. So essentially what's going to happen is we're going to calculate a value from 1 to 0, kind of mapping the time for the particular ability, and then converting this to essentially a percentage value, which we can actually set the fill on here. Now this ends up being a little bit cumbersome because, again, if you'll remember, the way that we're actually implementing the cooldown for these different abilities is by using network ticks instead of like a raw float time value. So essentially what we have to do is we have to like get the network ticks and then use those to calculate our percentage. And once we have our percentage, then it's super easy to just, set that in our little UI controller here. So speaking of, we are going to need an ability UI cooldown controller. This really should be part of the starter assets. So if I remember to add this into the starter assets, I can go ahead and do that. But you'll see it's a very simple script here. You'll see that we are going to basically be using a singleton instance of this. This is so we can easily get a reference to it from the ECS side of things. So we're just going to go ahead and set up the singleton in the awake function here. On start, just go ahead and set the AoE ability masks fill amount to 0 and 0, just because, again, we want them to start essentially available to use. And then we'll just have these public functions for updating the AoE mask as well as the skill shot mask. And you'll see that we basically just pass in the float for fill amount, and we're just setting that fill amount on there. Again, this is just that value from 0 to 1. And then we can just come over to the in-game HUD and we'll go ahead and add on that ability cooldown UI controller. And then we just need references for the AoE ability mask, which is the cooldown mask under the AoE ability. And same thing, we need the cooldown mask under the skill shot. And so just to kind of test that this is working off the initial stuff, you can just see that when we enter the game, the Q and the W should have basically no fill over it, whereas it previously did have a little bit of fill on it. So next up, we'll create a new system. This is a client-side system, and we'll use a struct ability cooldown UI system, and this is a public partial struct, which is an iSystem. And again, we're running this only client side, so we have to set the world system filter flags. And inside our on update, we need to get a reference to the current server tick so we can calculate how long it is from the current tick until the essentially completion of that cooldown period. And then we will just need to go ahead and get a reference to our ability cooldown UI controller just by doing an ability cooldown UI controller.instance. Now we'll go ahead and create a little for each here, system API.query. We're looking for a dynamic buffer of the ability cooldown target ticks, as well as the ability cooldown ticks. Now, if you remember, this ability cooldown target ticks is that iCommand data type, so we need to access it using a dynamic buffer, and that's basically going to give us the ability to essentially look up of when the target time of when that cooldown expires. And then the ability cooldown ticks gives us a reference of how long the total time of that cooldown is supposed to take in the number of ticks. So just go ahead and set some variable names and do a little cleanup if you want. So first we want to try and get the data from the current tick off of the cooldown target tick. So we can do cooldown target ticks dot get data at tick, and then pass in our current tick here. And we can do an out var cur target ticks. And I do have an exclamation mark at the beginning. So that basically means that if we don't have any data at that current tick, let's just go ahead and initialize it to something. So we can just say cur target ticks dot AoE ability is equal to just an invalid network tick. And then we'll do the same thing for the skill shot ability. Now, after this, we can go ahead and do a little bit more logic. And then so first, we're just going to go ahead and do this for the AoE ability. So what we can do is we can say if cur target ticks dot AoE ability is equal to that network tick dot invalid, or if the current tick is newer than the cur target ticks dot AoE ability. If that is the case, then we know it's expired. And again, maybe a little bit of an inefficiency here, but we'll just go ahead and set it every frame because it's easy. So we can just go to our ability cooldown UI controller dot update AoE mask, and we'll just pass in a value of 0 here. Now we'll go ahead and do an else, meaning that the cooldown is still valid. So first we need to calculate the remaining ticks. So we can do that by saying var AoE remaining tick count is equal to our cur target ticks dot AoE ability dot tick index for valid tick minus the current tick dot tick index for valid tick. So a little bit of weird terminology, but this is essentially how we can figure out the integer index of each of these and do a little bit of calculation to see what is the remaining tick count. So from there, we can calculate the fill amount. And so we need to just cast this to a float, and we'll get the AoE remain tick count and divide this by the ability cooldown ticks dot AoE ability. So this is, how many are left divided by the total count. And then same thing, we can just do the ability cooldown UI controller dot update AoE mask, passing in the fill amount. Now there's probably a better way to do this, but we'll just go ahead and do an easy Control-C, Control-V, programmer's favorite thing. And then we can just come through here, and instead of the AoE ability, make that the skill shot ability, current tick, make this the skill shot ability. We'll go ahead and update the skill shot mask here instead. We call this the skill shot remain tick count. Again, change this to the skill shot ability. Go ahead and bring this over here. Go ahead and bring this over here. And again, change this to the skill shot ability. And then finally, update skill shot mask. So now if we come over to Unity, we can go ahead and press the Q key, and we'll see that we get this nice cooldown here. Again, we can't press the Q key if the cooldown is still there, but now that the cooldown has expired, we can go ahead and press the Q key again. So again, we basically will be able to spawn something as soon as that little icon on the Q thing gets expired. Same thing, let's just go ahead and check the W, make sure that's working. Again, when we press the W key, nothing happens until we click, and then we actually want that cooldown to start when we click. And again, because we have already implemented the cooldown logic, everything works just as we would want it to. So again, when we're clicking, when the cooldown is active, we can't cast a spell until that cooldown is actually expired. And then of course the cooldowns don't affect each other, so if say the W's on cooldown, I can still cast the Q, and vice versa. So the next feature we're going to implement is the skill shot UI. Again, this is the little arrow to tell the player which direction that they're pointing the skill shot in. This is going to be similar to the health bar, and then it is also going to be set up as a cleanup component. Now, luckily, we're not going to have to create any new systems. We can pretty much already use our existing systems and then just add a little bit of logic to spawn and clean up these particular prefab references. The one thing that I will point out is if we do take a look, you see that I have included this skill shot aim prefab in here. You can see that under it is just an image component with a sprite render. I also have this skill shot visual delay. Basically, I noticed that when I was spawning this, it was just kind of like spawning with the default orientation for one frame, and then it would snap to essentially wherever it was. So all the skill shot visual delay is it just waits one frame until the sprite renderer is actually enabled. And so that's just kind of like a, hack little workaround away so we don't get that one frame flash of it being in the incorrect position. So first we'll start in our UI components script. We'll go ahead and create another public class. This one is going to be the skill shot UI reference. And this is another iCleanup component data with just a single game object field called value. Next up, we can come back to our MOBA prefab script, and on the UI prefabs, we'll go ahead and create a public game object for the skill shot here. And then in the authoring, we can create a public game object here for the skill shot aim prefab. And then when in our add component object, we're adding this UI prefabs, we can set the skill shot aim prefab here, and then just come back to Unity inside the subscene, select the prefab container, and go ahead and drag on the skill shot aim prefab. Okay, so then we'll open up the begin skill shot system, and this is where we're actually going to go ahead and instantiate the skill shot prefab. So we'll go down to the bottom of the first for each loop here. So after we're doing the ECB.addComponent aim skill shot tag, and here we're going to only run this on local clients. We don't want to run this on the server, and we don't want to run this logic for any remote clients, because basically we want only the player to see that visual representation of where they're aiming. So we can say if is server, or if exclamation mark system API dot has component owner champ tag, and then we can pass in skillshot dot champion entity. Go ahead and continue. So again, our local champion is going to have this owner champion tag. So if it is one of the other clients, then it's not going to have this champion tag. So that's how we kind of know that we're running only on our local client. So now we'll need the skill shot UI prefab, and we can get that again by doing our system API dot managed API get singleton UI prefabs dot skill shot, and then we'll go ahead and instantiate the new skill shot UI by doing our Unity engine.object.instantiate, passing in the skill shot UI prefab. And if you'll remember, on the skill shot aspect, we do have a attack position, which we can use as the position, and we can set this to quaternion.identity here. And then finally, we can do an ECB.addComponent, and this will be on the skillshot.champion entity, and this will be a new skillshot UI reference, and of course the value is our new skillshot UI, just like that. Now, while we're already in this system, let's just go ahead and implement the cleanup operations. So after the last for each, but before the ECB playback, we actually need to do two different cleanup for eaches for two different cases. So one is we'll do a system API.query looking for anything with the ability input and a skillshot UI reference. Of course, we're going to do a with all simulate because this is in a predicted system. And we need entity access here. So this is with the ability input and the skillshot UI reference, and reference that entity. So basically the first cleanup operation that we're going to do is after the player clicks to spawn the entity in a particular direction, that's when we'll go ahead and clean up that component. So we can say if exclamation mark ability input dot confirm skillshot ability dot is set. Go ahead and say continue. So that means that the user hasn't pressed it. So just go ahead and continue out of here. Otherwise, if they have pressed it, just go ahead and do an object.destroy skillshot UI reference.value. And then also just go ahead and do an ECB.remove component, the skillshot UI reference on the entity. Then the other cleanup operation is going to be a more traditional cleanup component, cleanup operation. So this is system API.query, looking for anything with a skillshot UI reference. And we can do a with all simulate, but we also want to do a with none local transform, and we will need with entity access on here as well. So skillshot UI reference and entity. So again, this is basically going to happen if, say, the player had pressed the W key and they were like, trying to aim a skill shot, but then they got killed before they could fire off a shot. We also just want to go ahead and clean up this little UI component here. So we can do a object.destroy, of course, passing in skillshot UI reference.value, and then an ECB remove component skillshot UI reference off that entity. So this part of the system no longer functions. And then just add a couple of comments for clarity on there. So if we come over to Unity and we press the W key to cast the spell, you'll see that we have this nice big arrow here. However, it's not following along with the player, and it's also not following along with where our mouse is pointing, but it should clean up if we do actually click to cast. So the next thing that we need to implement is basically the ability for this arrow to follow around the player as well as point towards our mouse. Now, luckily we already have a system built out which we can do that. We can just go to our aim skill shot system, and then we can add a couple of things to our query here. So after the local transform, we can also add in the skill shot UI reference. And again, this is only running on our local champion, and we know that, when our local champion is aiming, it's always going to have this skillshot UI reference. And just at the top of here, I'm going to go ahead and go to skillshot UI reference.value.transform.position. And just go ahead and set this equal to the transform.position of the current entity. And then when we actually want to set the rotation, we're going to have to do this down inside where we're doing this ray cast here, because again, we're basically already ray casting out to find the direction that we're aiming in. And so basically just by using a little bit of math, we can calculate the particular angle that we need to rotate this object at, and then we can just go ahead and set that using a quaternion.euler here. So now we can enter play mode, and we can go ahead and press the W key, and you'll see that now basically the arrow is moving around with whichever direction that the mouse is pointing in, and similarly it is updating the position, so we can actually now move around here, and you see that the arrow is updating its position in real time. So now, and then when we click, it's going to fire off in that direction that we had pointed. So it's a lot more helpful information to the player. So, the player can actually kind of like aim one of these shots at, say, this tower here, and know exactly where it's going to be going. Okay, so we're actually at a pretty good point where we can do things in our game, and we're giving our players some good information about what's going on in our game. The only thing missing is really making, everything that makes this a fun game. So let's go ahead and actually make this world feel a little bit more alive. The way that we're going to do that is we're going to start making these towers be able to attack units on the opposing team. Now, as we go along, it's going to be really cool because, as you see, we can use this exact same code that we use here for our minions to give the ability to our minions to attack people on the opposing team as well. So let's come back to our combat component script and scroll all the way down to the bottom, and we're going to add in a bunch of new components here. So the first is a public struct NPC target radius, which is of type iComponentData. This doesn't need to be a ghost type or anything, because this is basically just a fixed value where we define how wide of a radius that entity can target other entities in. Next up, we'll have a public struct NPC target entity. This one will be a ghost field because we will be essentially populating this entity with the entity that it's targeting. Next up, we'll have some NPC attack properties, and these are going to be separated out from the target radius because this is just going to be used in a separate system here. But essentially, these are things more related to directly actually instantiating attacks. So we're just going to have, again, a little bit of an offset from, whatever the center point of the transform of the entity is versus where we want to actually fire the shots from. We're going to have a public unsigned integer for the cooldown tick count, again, because we're going to be having like a timer-based cooldown. We want to keep track of the number of ticks that cooldown will be. And then finally, we will have a public entity reference for the attack prefab, so we can spawn a particular entity for a given NPC type. And then the last component we'll need is a public struct NPC attack cooldown, and this is an I command data. Again, the I command data does force us to implement that network tick property, and then we can just store a public network tick called value. Again, this is going to be the tick at which the cooldown expires. So let's go ahead and just create an authoring component that goes ahead and adds all these things. So we've set up this NPC attack authoring. You see that we have public values for the NPC target radius, the vector3 for the fire point offset, a float for the attack cooldown time, a game object for the attack prefab, and then we also do that thing where we get a reference to the netcode config scriptable object, and then I just have this little property for us to get the actual simulation tick right here. Then in the Baker, it's fairly standard stuff. We're just adding the NPC target radius, setting that value, NPC attack properties, setting the value for the fire point offset, the cooldown tick count. Again, we do have to just cast this to an unsigned integer, and then we take the actual attack cooldown time, which is the floating point value, and we multiply that by the simulation tick rate, which we got up here. The attack prefab, we're just getting an entity from our attack prefab here. And then just going ahead and adding an NPC target entity, don't need to set anything on that, and then adding the buffer for the NPC attack cooldown. So we'll come back over to Unity and we can go ahead and set up, and we can just go to the tower prefab here. Let's go ahead and add a NPC attack authoring. Let's give this a target radius of 10. Let's set the fire point offset to 2.5 in the Y, an attack cooldown time of 3. We'll come back for the attack prefab and then go ahead and set the netcode configuration asset there. So now we need to go ahead and create this attack prefab. So just go ahead and create a 3D sphere. We can call this tower shot. So on here, I'm just going to go ahead and change this to the AoE material. We can just use that same material that we were using. I don't like using the regular sphere collider, so we'll go ahead and instead use the physics shape. We can set this to a sphere. For collision response, we'll go ahead and change this to raise trigger events. For belongs to, this should be on the abilities layer, and we would like this to collide with champions, minions, and structures. Next up, this will in fact need a rigid body component. On the rigid body, we'll uncheck use gravity and then check is kinematic. We can use our existing destroy on timer authoring and just go ahead and destroy this after 1 second. We can also use our existing ability move speed authoring, give this say a move speed of 10. This will also need a MOBA team authoring and just set the default value as none, which is fine because we'll be setting that when we actually spawn it. And lastly, we just need to go ahead and add a ghost authoring component here, and then we'll just go ahead and drag this into our prefabs, destroy this, and then on the tower shot, let's go ahead and set this an importance of, I don't know, 500. And we'll do a default ghost mode of predicted. And we do need to add a damage on trigger authoring here as well. Go ahead and set this to a value of 150. And then we just need to go back to the tower and drag in the tower shot prefab. So let's go ahead and create a new script in our common directory. This will be a struct, and this will be the NPC targeting system. And so of course, public partial struct, and this is an I system. And we're going to want to update this in a specific place in the player loop. So it's going to update in the group type of physics system group. And the physics system group, I should point out, does run under the predicted simulation system group. So same kind of rules apply to predicted simulation groups as well as the physics system group. And they want it to run after the physics simulation group, but before the export physics world. So because we are just kind of going to be doing some things with a particular query cast, this is the kind of recommended part in the frame that we actually are going to be running these queries. So go ahead and create a private field here for collision filter. I've just called it NPC Attack Filter. This is going to belong to the target cast layer, and you see that it's going to collide with champions, minions, and structures. So basically, we're just going to use this collision filter to do essentially an overlap sphere, and then it's going to collide with anything on the champion, minion, or structures layer. And we'll actually skip creating an on update here because we're going to create a new iJob entity. And you can see that we can just call this the NPC targeting job. You'll notice that we also do have the with all type of simulate, because again, this is running a predicted system group, so we do want to have that. And this also can be burst compiled here. Before we go ahead and create our actual execute method, let's just go ahead and define a couple of fields here. So we have one for the collision world, one for our collision filter, and then we also have a component lookup for the MOBA team, so we know if the entity that we're targeting is on the same team or a different team. So go ahead and define the signature for our private void execute here. Again, this can be burst compiled. So first we'll have a reference to the actual NPC entity. Next up, as you remember, we're going to be writing to the NPC target entity type. So we can just call this target entity. We want to read in from the local transform, which we can call transform, so we know, where we're going to be originating this overlap sphere from. And then finally, we just need read-only access to the NPC target radius, which just can be called target radius. So what we're going to do here, again, we're going to do an overlap sphere, and that's going to return us all the entities matching that collision filter within that specified radius. So what we can do is we can say if collision world dot overlap sphere, and here we can pass in the position, which of course is going to be transform dot position. Our radius is going to be the target radius dot value, and then we need to actually populate a native list of hits. So we can just go ahead and define, we say var hits equals new native list, and this is of type distance hit. And we can do an allocator.temp job. So with that, we can go ahead and do a ref hits. And then the last thing that we need is the collision filter. So if we did actually collide with something, we can actually test them. And the way that I've defined this logic is it's going to basically loop through everything. And it's going to find the closest entity on the opposing team. So we can say var closest distance is equal to float.max value, and the closest entity is equal to entity.null. So then we'll just go ahead and loop through the hits here. So we'll say for each hit in hits. So here we can say if exclamation mark MOBA team lookup dot try get component against the hit.entity out var MOBA team. So if it doesn't have it, then we can just go ahead and continue to the next. And then so we can compare if the MOBA team dot value is equal to MOBA team lookup at the NPC entity dot value. Go ahead and continue as well, because again, we don't want to target any entities on the same team. And then finally, we can do a distance check where we say if hit dot distance is less than the closest distance, then we'll set closest distance equal to hit.distance, and we'll set the closest entity equal to hit.entity. So then after the for each loop completes, we can say target entity.value is equal to the closest entity. And then I also just put an else on here. I don't know if this is entirely necessary, but if the overlap sphere doesn't collide with anything, just go ahead and set target entity.value equal to entity.null. And then finally, I'm just going to go ahead and manually dispose the hits list. And then of course, we just need to go ahead and actually schedule this job. So back up in the system here, go ahead and do an on update. And this in fact can be burst compiled. Just go ahead and say the NPC targeting job. We can say state.dependency is equal to a new NPC targeting job. For the collision world, we can do a system API get singleton physics world singleton dot collision world. For the collision filter, this can just be the NPC attack filter. And finally, for the MOBA team lookup, system API get lookup, get component lookup against the MOBA team, and read only is set to true on there. And here we'll do a dot schedule parallel, passing in state dot dependency, just like that. And we can of course add the require for update on the physics world singleton. Okay, then we can verify that this is actually working. Okay, so here you'll see that I've located the actual tower over in the hierarchy, and it's open in the inspector. You'll see that NPC target entity is currently set to none. However, when we move our champion entity closer to it, and once it gets in that radius, you'll see that the champion entity is now targeted. So that's how we can kind of verify that that's working now. So under the common folder, we'll go ahead and create a new struct for the NPC Attack system. So this is going to be an I system running in the predicted simulation system group. However, we're not actually going to do anything inside this system just quite yet because we're going to create an iJob entity. So this is going to be the NPC Attack job. Again, because it's running in a predicted system group, we want to use the with all simulate attribute on here. We're going to need a couple fields here, one for the current tick and then one for a transform lookup, so we can actually find the transform of the target entity so we know where in which direction that the NPC should shoot its shot. And we'll need an entity command buffer to do some ECB operations. In this case, because I'm going to be running this NPC attack job in parallel, we'll use an entity command buffer type of parallel writer. So for the signature of the execute method here, we're going to be writing to a dynamic buffer of type NPC attack cooldown, which we can call attack cooldown. The reason that we need write access to this is because we're going to be setting this after we actually send our attack. We'll need read-only access to our NPC attack properties, called attack properties. We'll also need read-only access to the NPC target entity. We'll have a reference to the actual NPC entity itself. Also, we'll want to know the team of the NPC entity because we're going to be adding that MOBA team to the shot that we're shooting. And then finally, we'll need a chunk index in query, call this int sort key. The reason that we need to do that is for entity command buffer operations. So the first thing that we can do is we'll actually make sure that a target entity exists. The way that we can actually do that is by piggybacking off of the transform lookup, which we're going to be using for something later. So we'll say if transform lookup dot has component, and we can pass in the target entity dot value. So basically, if there's a null entity or this references like an entity that got destroyed, when we do the transform lookup on here, we can actually determine if this entity exists by using this .has component method here. So anyways, if the entity does not exist, just go ahead and return. Next thing that we want to check for is if the cooldown is expired or not. So again, we're going to do one of these interesting things where we could say if attack cooldown dot get data at tick, of course passing in the current tick. We could say out var cooldown expiration tick. So if there's no data in there, then we can just go ahead and set the cooldown expiration tick dot value is equal to a network tick dot invalid. So here we can just create a little bool for can attack, set this equal to cooldown expiration tick dot value dot is valid, or if the current tick is newer than the cooldown expiration tick dot value. So if we can't attack, go ahead and return again. So basically everything beyond here means that the NPC actually can attack, so we will go ahead and attack. So now we need to figure out where we want to actually spawn this from. So we can say our spawn position is equal to, we have to use our transform lookup at the NPC entity dot position, and then add in the attack properties dot firepoint offset. And then we'll also need the target position. We can also get that from the transform lookup. This time we'll pass in the target entity dot value, and we'll just get the dot position from that. So now we can actually go ahead and spawn a new attack using our entity command buffer dot instantiate. Of course, we do need to pass in the sort key. And then we can pass in the attack properties dot attack prefab. Here we'll go ahead and set the new attack transform equal to local transform dot from position rotation. The position, of course, is going to be the spawn position, and we can calculate the rotation by doing a quaternion dot loc rotation safe. For our forward vector, we'll do the target position minus the spawn position, And for the up vector, we'll just do math.up. Then of course, we'll just go ahead and do an ECB.setComponent, passing in the sort key. So we're going to be setting this on the new attack, and we'll set the new attack transform. We'll do another ECB set component, sort key, new attack, and then here we can pass in the MOBA team. Again, we're just getting the component, so we can just pass that directly in like that. And then finally, we just need to go ahead and reset the cooldown timer. So we'll go ahead and say var new cooldown tick is equal to current tick. We can do a new cooldown tick dot add, passing in the attack properties dot cooldown tick count. And we can go to the attack cooldown dot add command data, passing in a new NPC attack cooldown. The tick is equal to the current tick, and the value is equal to the new cooldown tick. Fun times. Anyways, before we test this, we just need to go ahead and of course schedule the job. So we'll do a good old on update here. We'll get a reference to our ECB singleton as well as network time, and we can go ahead and add in our require for updates if we do want to. So now we'll just go ahead and say state.dependency is equal to a new NPC attack job. Go ahead and of course set the current tick is equal to network time.server tick. Our transform lookup is going to be a system API.get component lookup of local transform, passing in for true for is read only. Finally, our entity command buffer is going to be an ECB singleton.create command buffer. We've got to do a state.world unmanaged. And then just that doesn't work because we do need to do a dot as parallel writer. And then finally, we can just go ahead and do a dot schedule parallel and then pass in state.dependency there. So all the dependencies work. So we will come back over to Unity. You'll see that as we move past our own towers, of course, they're not going to attack us because again, we're only attacking things on the opposing team. However, when we do get closer to this other tower, you'll see that it's going to spawn and fire a shot at us. Now, you'll remember it's basically using the same logic that we used for the skill shots. So it's just going to move in a forward direction. Again, we're setting that orientation to look towards the player. And you'll see that when it does hit the player, it does in fact damage us just a little bit each time. So now we can just kind of let this ride out a little bit. And you'll see that our player should eventually run out of health here and get destroyed. And boom, we get destroyed. So now the player, it no longer exists. So we will be implementing a respawn system, but a little bit later. But for now, that's just kind of like the basic NPC attack system. Next thing that we're going to do is actually spawn some minions, and we're going to be using that same NPC attacking code for the minions. Okay, so now we're going to make the game feel a little bit more alive, and the way that we're going to do that is by spawning some minions that are going to be walking around in this world. Now, we're just going to do a pretty simple setup for this tutorial just so we can have something kind of implemented, but of course you can take this much further and make these minions much smarter than they already are. But basically what we're going to do is we're going to have an entity that sits in our subscene that controls when these minions are going to spawn. Basically, these minions are just going to spawn in waves of 3 minions each, and then we're going to send 3 to the top lane, middle lane, and bottom lane, and of course we're doing that on each side. Now the minions don't have a whole lot of crazy logic. Basically, they just have some very basic movement logic where they're just following a simple path that goes along these different lanes. And then they also do have that same NPC targeting and attacking behavior that the towers do, so that basically anytime a minion or champion of the opposing team gets close to one of those minions, then that minion is just going to fire an attack towards it. And it's a very simple implementation, but it's good enough to make the game feel just a little bit more alive. So first things first, let's just go ahead and define all the properties for our minion spawning and pathing behavior. So let's come over to our IDE. We're going to go ahead and go in the server. We'll go ahead and add a new class. These will be our minion spawn components. components. Okay, and then we'll just go ahead and start off with two components here. The first one is minion spawn properties, and this is basically where we define the float values for the time of how long it takes for the time delays between our different spawning. So the first one is the time between waves. Again, we're going to be spawning these minions in groups of 3. So we want to basically delay it for maybe like, 5 or 10 seconds between each wave of minions. And they also need to keep track of how the time between each minion spawn, because we're not going to be spawning all 3 at once. We're going to spawn one and then wait like a second or two and then spawn the next one and then wait a second or two and then spawn the third one. And then finally, we just want to keep track of how many in each wave that we're going to spawn. Again, in this case, we're going to be spawning 3, but we can define this at any number that we want. And then we also need a timers component where we can basically keep track of these time values in real time, because we're just going to be like, decrementing these timers. And then once a minion can spawn, we'll of course reset these timers as needed. The reason that we're using kind of regular timers here as opposed to keeping track of the network tick and everything like that is because all this spawning logic is going to be running on the server side only. So this way we don't need to worry about, like syncing across timers across the network or anything like that. Again, all this is just happening on the server side. So basically we just, again, are keeping track of the live time to the next wave, the time to the next minion in that current wave, and then also keeping track of, the count of how many we've spawned in that current wave that we're on right now. So then once we have these defined, let's go ahead and create an authoring component for these. So here's what this authoring component looks like. You see that, of course, we'll need public floats for the time between waves, time between minions, as well as the count to spawn in each wave. And then inside our baker, we're just going to go ahead and get the entity. I'm using transform usage flags.none because this is a data only entity where we just define the data properties and it doesn't need to physically live anywhere in our world. For the minion spawn properties, I'm just setting those values directly from the authoring. And then on the minion spawn timers, I'm going to go ahead and set time to next wave at that time between waves value. And that's just so we can have kind of like an initial delay of a couple seconds before the minions start spawning in the game. However, time to spawn next minion should be set to 0 because we want the first minion to spawn basically right immediately after this kind of initial delay from the time between waves. And of course we haven't spawned any, so we can set the count spawned in wave to 0. So back over into Unity, we'll just go into the subscene on the minion properties and go ahead and add in the minion spawn properties authoring. Let's set time between waves to say 10 seconds. Time between minions is 1. And we'll spawn 3 in each wave. So next thing I'm going to do is actually create an aspect, and this is just going to be an easy way for us to deal with these different timers. So I can go ahead and create a new struct here, and I can call this the minion spawn aspect. Now this is going to be a public read-only partial struct, and it will implement IAspect. And we will need read and write access to our minion spawn timers, so we can do a private read-only ref rw. So again, even though we use the read-only keyword, we can use ref rw to basically designate that we have read and write access to this. And then we need read-only aspect to our minion spawn properties. And then from there, I'm just going to go ahead and generate accessor properties for the things in the timers as well as the spawn properties. Writer has a way to easily do this very quickly. However, if you're using Visual Studio or something else, you just have to manually type these things out here. This basically just gives us an easy way for us to get and set the underlying values of these components rather than going through the trouble of kind of like diving down a couple layers to that actual value. And actually these accessor fields can all be private because all the public stuff are going to be through some public properties, which we're going to be doing here. So we'll go ahead and create a couple public properties. The first one is going to be a public bool for should spawn. So this is basically just going to check against the timers to see if we should actually spawn a minion on this given frame. And so we can do that just by checking if time to next wave is less than or equal to 0 and time to next minion is less than or equal to 0. If that is, then we basically know that the timers have expired and we're ready to spawn a new minion. And then the other property is another public bool, and this will be is wave spawned, and this will be true when the count spawned in wave is greater than or equal to the count to spawn in wave. Next up, we'll need a way to actually decrement all these timers. So I'll just have a public void decrement timers, which takes in a float for delta time. So first we'll go ahead and check if the time to next wave is greater than or equal to 0. If it is, we'll say time to next wave minus equals delta time. And then we'll go ahead and return from here because we don't want to decrement any further timers. And then after that, we can check if the time to next minion is greater than or equal to 0. If it is, just go ahead and say time to next minion minus equals our delta time. So basically it's just going to decrement that time to next wave timer. Once that time to next wave timer is expired, then it's going to start decrementing the time to the next minion. And it's going to probably loop through this a couple times until the wave has been fully spawned, at which point we'll go ahead and reset our next wave timer, and then this will go back again. Now we will just need a way to reset these timers. So we'll have a public void reset wave timer, where we can set time to next wave is equal to time between waves. We'll do the public void reset minion timer. So we can set the time to next minion is equal to time between minions. And then finally a public void reset spawn counter. We'll just go ahead and set count spawned in wave equal to 0. So these are all the functions that we're going to hide away in our aspect. So we'll go ahead and create a system now that's going to actually call these different functions here. So again, this is going to be a server only system. So go ahead and create a new struct here. This will be the spawn minion system. Of course, we'll do a public partial struct implementing iSystem, and of course this is going to use the world system filter or the world system filter flags server simulation. So we'll go ahead and create our onUpdate method here, and this can in fact be burst compiled. We'll go ahead and do an idiomatic for each in system API dot query, and we'll go ahead and query against the minion spawn aspect, which we can just call minion spawn aspect. And we'll actually need a reference to delta time, so we can get a var delta time by doing a system API.time.delta time. Now from our minion spawn aspect, we can first just go ahead and decrement the timers by delta time. And now we can check if we should actually spawn a minion. So if minion spawn aspect dot should spawn, then we'll go ahead and call a function which we'll create called spawn on each lane. So this is actually going to go ahead and spawn one minion on the top lane, one minion in the mid lane, and then one minion on the bottom lane. And it's going to do that for both the blue and red teams. And actually I did misspeak. We will need the count spawned in wave as public, so that we can do minion spawn aspect dot count spawn in wave plus plus. So we'll just go ahead and increment that so we kind of keep track of the count of these. So now we can say if minion spawn aspect dot is wave spawned. So that means, is the wave fully spawned? So we'll go ahead and do minion spawn aspect and reset the minion timer, minion spawn aspect dot reset wave timer, and minion spawn aspect dot reset spawn counter. So we're basically just going to go ahead and reset everything. However, if the wave is not fully spawned yet, that means that we've only just spawned one or two of the entities, not all of them. Then we can just do a minion spawn aspect dot reset minion timer. So now we need to go ahead and implement this spawn on each lane method here. So we'll create a new method for this. So we're going to go ahead and spawn these minions with one of the built-in entity command buffers. So we will use the begin simulation entity command buffer system. So we'll get a reference to our ECB singleton equal to system API dot get singleton begin simulation entity command buffer system dot singleton. And then it's going to want us to go ahead and add the require missing for update. Now this is actually not going to work if we do this right here. And unfortunately it's not throwing us any errors in the IDE, and we don't even get any errors in Unity until we actually go to run the application. Then we would get some errors, but we can't use system API without a reference to the system state. but luckily we can just do that easily by doing a ref system state and just call this state. And then so that means when we call this, we just need to go ahead and do a ref state. And again, we're just getting this state from this on update up here. So now we can actually get our entity command buffer. So var ECB equals ECB singleton, create command buffer, passing in state.worldUnmanaged. So that's another reason that we will need access to this state here. And unfortunately, we're not actually going to be able to proceed any further until we have our minion prefabs, as well as actually defining the paths that these minions are going to follow. So at this point, we can just make sure everything is working just by doing a debug.log, and we'll say spawning minions on each lane. So now we'll go ahead and enter play mode, fire up our game, and you'll see that once we're in, you'll see that it waits about 10 seconds, and then we should start seeing spawning minions on each lane, spawning minions on each lane, spawning minions on each lane. You see that these are each 1 second apart, and then it's going to wait for another second or another 10 seconds, and then we should see the minions spawn again. So we have spawning minions in each lane, spawning minions on each lane, spawning minions on each lane, again 1 second apart. So that's all we want for now. So next thing that we're going to do before actually creating our minion prefabs is we're going to define the paths that the minions are going to walk on. So if you look at basically our whole MOBA map here, the way that we define a path is just with 3 different points for each lane. So for the bottom lane, one point is going to be kind of right here, where at the edge of the blue base, in the beginning of the path. So this is basically where the blue minions will spawn. They're going to go ahead and walk over to basically this corner piece here, and then they're going to move all the way over to the red base here. And then conversely, this is going to be where the red minions will spawn, and they're just going to traverse the path backwards. And then the mid lane is going to have a similar setup where they'll go between the blue and the red base, and the top lane, of course, is just going to follow this top lane here. So we'll come over to the common folder, and we'll go ahead and add in a new class here. These will be our minion components. And so we're going to define things that are specific to the minions here, but we'll also define kind of our dynamic buffer for these different paths. And so we'll just go ahead and define all the minion components because there's only 4 of them. So the first 2 are simple tag components, one for the minion tag so we can query against minions, and then one for new minion tags for our minion initialization logic. Next up, we're going to go ahead and create an iBuffer element data for minion path position. And this is just going to have a public float3 value of 0. So this is a dynamic buffer because it's going to store all the different waypoint positions that the minions are going to follow. Of course, we do want to put the ghost field attribute on this value here because we do want this to be a ghost component, so this can be synchronized across the network. And then we'll just go ahead and also set the quantization equal to 0 just so we have full precision on this float 3, even though we probably could get away with something a little bit less for these particular values. And then the final one that we'll add is a regular iComponent data for minion path index. And this is just going to have a public byte for value, and this is just going to keep track of the index of where the particular unit is along the path. And we do need this to be a ghost field because this value is going to be updating as it's moving from point to point to point. Now, before we actually create our path authoring, we do need to come back to our minion spawn component and create one more public struct here, and we can call this minion path containers, and this is a regular iComponent data. The idea here is that we're going to have 3 different entities, one for the top lane, one for the mid lane, and one for the bottom lane. And then basically each of these entities is going to have a reference to the particular path for that lane. And then when we spawn entities on a given lane, it's going to reference the particular entity, and then it can set that path value appropriate for the newly spawned minion. So anyways, back over in the server, we'll go ahead and add a new Unity script. This will be a mono behavior for minion path authoring. And first we'll start off with 3 vector3 arrays for the top lane path, mid lane path, and bottom lane path. So this will be where in the editor we actually define the points on the path. Now I'll go ahead and actually set up the baker part of this. And first we're actually going to define 3 entities instead of just the regular 1. So we will have a single entity for using the get entity, just like we would regularly do. Again, we can do transform usage flags.none because this is a data only entity. Now we do need to do this create additional entity, and that's because we're going to be creating new entities for each, again, the top lane, mid lane, and bottom lane that are going to have these dynamic buffers. So you can see that these all have transform usage flags set to none. This value for false here, we have is baking only entity set to false because we do want this entity to persist after baking. And then we can go ahead and just set a name for each of these different lane entities. So now for each of the lane entities, we're just going to go ahead and loop through the particular path that we've defined in the authoring. And then we're just going to go ahead and add points to a dynamic buffer. So first we need to add the buffer to that top lane entity. So this again is that minion path position dynamic buffer. So we've just called this buffer the top lane path. So now we can do a for each loop iterating through the authoring.toplanePath, which again we've defined in the editor. And so for each path position, we'll just go ahead and add that as a new minion path position in that top lane path dynamic buffer. Then just go ahead and do the same things for the mid lane and bottom lane. And then finally on the main entity, we can just go ahead and add that minion path containers component with the top lane, mid lane, and bottom lane set to the top lane, mid lane, and bottom lane entities, again, that we've created in this baker here. So if we come back over to Unity, again, come back to our minion properties, and this time we'll add the minion path authoring. And then on each of these, we need to go ahead and define the points for each path. So I'm just going to go ahead and go through that now. So these are the particular values that I've used to define my paths here. So then we can go ahead and enter play mode. You'll see that I've just done a search against the minion path position, and we do have 3 entities. And then if we open these minion path positions buffers, we can actually see that these have the appropriate values that we've set in the editor. So now the next thing that we need to do is actually create some minion prefabs to go ahead and spawn. So we do already have all the components we need. However, we do just need to create a new authoring component. So we'll go ahead in here into the common and create a new mono behavior for minion authoring. And the only field that we're going to need to actually define is a public float for move speed. And then it's going to be a pretty standard Baker component. You'll see that we're going to be adding that minion tag, the new minion tag, the character move speed, and this is the only thing that we're setting an actual value on. Our minion path index, our minion path position. We'll of course need a MOBA team this is going to be associated with, as well as the URP material property base color, so we can set a color for the minion based off of the team that it's on. So now we can come over to our minion prefab, and you see that it should already have the hit points authoring from earlier. So we'll go ahead and also add on the minion authoring, and we can just go ahead and set a move speed value of 2 here. And then also let's just go ahead and add in our NPC Attack authoring, and we can go ahead and set a target radius of say 10. Just a fire point offset of 0, 0 is fine. Attack cooldown can be 3 seconds. The Netcode config script, we can just go ahead and reference that asset here, that global asset from our scene. For our attack prefab, let's just go ahead and actually just duplicate this tower shot. We can hit F2 to rename this to minion shot. And we can go ahead and just come back to this minion prefab and drag in the minion shot here. We can come over to the minion shot, and let's just make this a little bit weaker than the tower shot. So we'll say it just damages for 100, but otherwise everything else is exactly the same as the tower shot. And then one last thing we do need to add to our minions, of course, is a ghost authoring component. And let's go ahead and set, say, an importance value of 100, and we can leave this as an interpolated ghost for now. And I'll also go ahead and set a health bar offset on here to a value of 2 in the Y direction. Okay, great. So we have our minion set up here. Now we need a way to reference this from code, of course. So we'll come back to our MOBA prefabs. We'll make a public entity for minion, and then in our MOBA prefabs authoring, under the entities section, we'll do a public game object for minion. And then in the baker, of course, go ahead and set minion equal to get entity authoring dot minion. And we will want the dynamic transform usage flags. Okay. Everything is in place. Now let's just come back to our spawn minion system. And then back here in our spawn on each lane, Let's first just go ahead and get a reference to the minion prefab, and we can do that by doing a system API.getSingleton MOBA prefabs.minion. Of course, we can add the require for update if we want. Also, we will need a reference to our path containers just by doing a system API get singleton against our path containers, minion path containers that is. And again, we can do a require for update there. So next up, we're going to spawn 2 entities on each lane. The reason is we're going to have one for the blue team and one for the red team. So first, what we're going to want to do is get a reference to each lane. So that way we can know which positions to spawn the different entities on. So let's go ahead and get a reference to the top lane. So we can do that by doing a system API.getBuffer. Again, this is the minion path position. And the entity that we're getting this off of is on our path containers.topLane because we're getting the top lane buffer. So now we'll go ahead and implement a new method called spawn on lane. And then here, this is going to take in the entity command buffer because we're actually going to do the instantiation in here. We'll also need a reference to our minion prefab, and then finally the particular lane, which is going to be the top lane. So we'll go ahead and create the spawn on lane method, and I'm actually just going to go ahead and rename the dynamic buffer to curlane, but otherwise the naming looks pretty good to me. So first thing, we'll just go ahead and spawn a new minion on the blue team. So we'll say var new blue minion is equal to ECB.instantiate, passing in our minion prefab. And then now what we need to do is actually add the elements of this dynamic buffer to this entity. You'll remember that this entity already has this dynamic buffer through the authoring component that we just created. So we can just do a simple for loop here, iterating through the elements of cur lane, and then we can just go ahead and add those directly to that new blue minion. After that, we'll just go ahead and set the initial position of this new blue minion. So we can say var blue spawn transform is equal to local transform dot from position. The start position is going to be cur lane at position 0, because basically the way that I've defined all these paths is they start on the blue side and end on the red side. So we can just do cur lane at position 0.value, and now we can do an ECB.set component, again passing in the new blue minion as well as the blue spawn transform. And then finally, we just need to go ahead and set component again on the new blue minion, and we can do a new MOBA team. And here's where we actually set the value of the MOBA team equal to team type.blue. Now we can pretty much copy and paste this for the red minion, but there are a couple things that we do need to worry about. So we'll go ahead and change this to the new red minion. So this time, instead of iterating through the for each loop regularly, we're going to go ahead and implement it backwards. So we'll say var I is equal to curlane.length minus 1, while I is greater than or equal to 0, I minus minus. So this way, we're just going to go ahead and do go through the for each loop backwards to add the points backwards. So it's basically starting point is going to be on the red side, and then it's going to move towards the blue side, but it will be basically in order in its dynamic buffer. So it doesn't need to like go through it backwards in the actual movement script here. So then we just want to make sure that we're applying this to the red minion, and then we'll change this to the red spawn transform. And here, instead of doing it at position 0, we can do this thing where we do caret 1. That basically just returns us the last element of the array. And then of course we can just go ahead and update these to new red minion and new red transform. And go ahead and assign this to the red team. So now we're spawning a blue minion and a red minion on the top lane. Now we'll come back to these spawn on each lane. And we can just go ahead and copy paste this a couple times here, and then do one for the mid lane. So then we want to get the mid lane here, and then just go ahead and of course pass in mid lane. And then finally, we'll do the same thing with the bottom lane. Perfect, so that should be all our minions spawning. Okay, so now we just need to come back to Unity and then go ahead to our prefab container. And then we do need to drag in our minion prefab here. Okay, so now we'll go ahead and enter play mode, and we should wait about 10 seconds until some minions start spawning. But we should see one spawn for each lane on the blue side, and indeed we do. Now likely a couple of them are actually spawning, but they're all just spawning in the same position, so we can't actually see them, unfortunately. And we can just come over to the red side and confirm that we do have 3 minions spawning here. And I see that they just have black materials on them right now, but let's just go ahead and do our initialization logic so they actually go ahead and get the appropriate color, and then go ahead and start moving along the path. So if you'll remember way back earlier in this video, we'll come back to this initialized character system, and this is where we're going to query, you remember we added this with any new champ tag. So we also just need to go ahead and add another element for the new minion tag. And then, so this is where we're already, setting the physics components as we want them to, and the team colors and all that. And then you'll see that we're just going to go ahead and remove the new champ tag, but let's also do an ECB.remove component against the new minion tag, passing in new character entity. And these aren't going to have any effect if the entity does not already have, say, a new champ or a new minion tag, depending on what type it is. So now when we enter play mode, you'll see that the blue minions spawn with the blue color and the red minions spawn with the red color. Now we can take a look in the entities hierarchy, and we see that we have a bunch of entities now, so we can be pretty certain that all these entities are basically just spawning on top of each other. So now the next thing that we're going to do is actually implement our movement logic, so these entities start actually moving around, and we can actually see the differences between these, and they're not all on the exact same spot. Luckily, implementing minion movement is incredibly simple because we already have all the components we need. We just need to go ahead and create a new system for it. So we'll just go ahead and create a new struct here. This will be the move minion system. Course public partial struct, and this will be an I system, and this is going to update in group type of predicted simulation system group. So this will be running on the client and server, so we can do our on update here, and this indeed will be a burst compiled function. So of course, because we're moving things, we'll just need a reference to delta time, system API time.delta time. And then we'll go ahead and do the for each, and we're going to be querying using system API. Of course, we're going to be writing to the local transform. We also will need to read from that dynamic buffer of minion path position. Again, this is going to be running on basically each entity, and each entity has the full path of where it's supposed to move. We do also need read and write access to the minion path index, because we basically need to know what index it's going to be moving towards, and once it's at that index, we'll actually increment it. And then finally, we also need to read from our character move speed. And then we also want to go ahead and do a dot with all simulate. Again, this is because it's running in a predicted simulation system here. So we'll go ahead and define our variable names. We'll have transform, path positions, path index, and move speed. And we'll go ahead and clean this up a little bit here. So first thing, let's just go ahead and get a reference to the cur target position. So this is where it's currently trying to move to. So we can get this from path positions at path index dot value read only dot value. And then we actually need to get the dot value of that path position. So this is the actual underlying float3 value. So here we can do a distance check here by using if math.distance between the cur target position and the transform value read only dot position. If this is less than or equal to, say, a value of 1.5, we just want to give it like a good amount of leeway for it to go ahead and go. This means that we know that we're at the target position. First thing that we'll just want to go ahead and do real quick is if the path index current value is greater than or equal to the path positions dot length minus 1. We can just go ahead and continue. Reason that we want to do this is because if we're at the end of the path, we don't need to move any further or anything like that. But here we can just go ahead and do path index dot value RW dot value plus plus. So just go ahead and increment that path index and set the cur target position is now equal to path positions at path index value read only dot value, and then the actual dot value on that guy there. Now I'm just doing a quick little hacky thing here as usual. So I'll set cur target position dot y equal to transform dot value read only dot position dot y. Again, just because this game is played on a flat plane, and we just want our minions to just move on this one single plane and don't need to worry about the up and down Y movement. So what we can go ahead and do is just go ahead and set var cur heading is equal to math.normalize safe. Go ahead and pass in the cur target position minus our actual current position by doing transform read only dot position. This is the vector from the minion to its current target position. And then here is where we can actually go ahead and set the transform's position. So here we can do transform dot value RW dot position. We'll do a plus equals with the current heading multiplied by the move speed dot value multiplied by delta time. And we'll also just go ahead and set the transform dot value RW dot rotation equal to quaternion dot look rotation safe, passing in again our current heading as well as math dot up. So this is pretty just normal dot stuff. There's no crazy networking involved or anything like that, but it's just kind of moving an entity from one position to the next. Okay, so now we'll go ahead and enter play mode, and after a couple seconds we should see our minions begin to spawn, and indeed we do. And you'll see that we now have 3 minions spawning in a wave, and they're going to go out and start making their way down each of these paths here. Again, we can wait another few seconds and we can see that another wave should spawn. So another wave of 3 of these guys are spawning. And we'll go ahead and follow these guys on the bottom lane here, and we'll just confirm that they are actually following the path as they should. Although we should also see the red minions are coming, and what's going to happen when we get a little bit closer here? Let's go ahead and find out. So you see that these minions are basically coming. They're going to both hit this same corner, and you see that they're going to start attacking each other and me. A couple of them are going to make it through, a couple of them won't. We'll see. And then we can also attack these minions. And yeah, so I mean, things are working. Our towers start attacking these minions. So pretty much everything is all, automated happening here. Again, we're just using these same existing systems that we had already. And you can see that, when we add this in, this behavior that we want, the behavior just kind of comes along with it. So it is, again, some of the cool advantages of data-oriented design here, just by adding in some simple components to add some existing features to this game here. So at this point, the game is starting to feel like a real game. We now have minions spawning, and they're attacking towers, and towers are attacking them, and we can attack minions and towers and everything like that. So it's a lot of fun stuff going on. So this is pretty much all the gameplay mechanics in place. The last thing that we need to do, just kind of like game flow logic. So we basically need the ability to kind of queue up into the game. We can wait for a target number of players to actually enter this game. Once the required number of players are in the game, then the game will actually begin, at which point, we can start adding in our own input, as well as, the minions will start spawning and everything like that. Of course, we want to add in some respawn behavior. So when a champion dies, then it's going to just, pop up with some new UI on the screen that's going to tell you, how many seconds you have until you respawn. It's actually going to go ahead and respawn the entity. And then the last thing that we need to do is add in some game over logic. So when one team's base gets destroyed, then the game is going to end for everybody, and it's going to pop up with a message on the screen saying, blue team won or red team won, and it's going to give the player the ability to return to the main menu so they can queue up for another game. So let's go ahead and define some of our game start properties. So this would be things like the minimum number of players required to begin the game. The reason we would want this is so that, say, when a player connects to the game, if there's not a sufficient number of players already in the game, then it's going to wait until that number has been reached and then the game actually begins. So we're going to go ahead and start and add some server-side components. So go ahead and add a new class in the server here. And these will be the game start components. And just go ahead and delete the default class created here. So first we'll create the game start properties. So this will be the max players per team. So we can basically limit it. So we can say only have a maximum of 5 players on each team. Also, we want to define an integer for the minimum players to start the game. Again, if we set this to, say, a value of 2, then that would be once 2 people enter the game, then the game can begin playing. And then finally, we'll have a public integer for countdown time, and this will basically be when the game actually starts. It'll give a 3, 2, 1, and then start the game. Next up, we'll go ahead and add in this team player counter component. So we're going to have 2 public integers, one for the number of players on the blue team and one for the number of players on the red team, just so we can keep track of these things. And then we also just have a public property here for the total players, which just returns the value of blue team players plus red team players. Then the last thing that we'll need is a dynamic buffer, which we call spawn offset. And this is just going to store float3 values here. We have these spawn offsets because basically we don't want to spawn all the new players at this exact same location. So this way we can kind of offset them so they spawn in a little bit of a pattern so they don't all start on top of each other to begin with. Okay, so here's the game start properties authoring, pretty basic authoring component here. You'll see that we just define our public integers for the maximum players per team, minimum players to start the game, as well as the countdown time, and then a vector3 array for the spawn offsets. Inside the baker, we're just going to go ahead and create an entity using transformUsageFlags.none because it's a data only entity. We'll just go ahead and add the game start properties component values here. We can just go ahead and set team player counter to the default values of 0. And then for spawn offsets, you see that we're just going to go ahead and add a buffer, and then we'll go ahead and loop through our spawn offsets array in the authoring component, and then just go ahead and add those to the dynamic buffer. Okay, so we'll come over to this game start properties and add the game start properties authoring. For max players per team, we'll set this to a value of 5. For the minimum players to start the game, we'll go ahead and set this to a value of 2 for now, but we'll go ahead and increase this later when we start messing around with thin clients. But we just want to make sure that we can just test this with 2 clients on our machine here. Countdown time, we can set it to 3, so we can have a 3, 2, 1, go. And for spawn offsets, we'll do 5. So this would basically be 1 offset per unit on each team. So we can go ahead and set these spawn offsets. The first one we'll just do at 0, 0, 0. Next one we can do -2 and +2. Then we'll do +2, +2, +2, -2, and finally -2, -2. So we're basically just kind of offsetting from the default spawn position. So now we'll come back to this server process game entry request system. And again, this is basically where we receive that initial request from the client and then process it and actually spawn the champion entities. So here we're going to do a little bit of logic to determine if the game should start or what kind of state that's in. Okay, so in the on update here, first thing that we're going to do is just go ahead and get a reference to that game start properties entity so we can actually get the components and dynamic buffers from it. So we can just do a system API.get singleton entity against the game start properties and go ahead and add in the missing required for update if we want it. So we'll go ahead and actually get the game start properties as well as the team player counter as well as the spawn offset dynamic buffer. Again, all just using system API here. So now we can actually scroll down into our on update here. And then when we do this switch here for requested team type, let's go ahead and first check to see if we have availability to actually add that player to that team. So for if team type blue, we can say if team player counter dot blue team players is greater than or equal to the game start properties dot max players per team. Then we'll just go ahead and print out a log message saying blue team is full, client ID, and we put in the client ID is spectating the game. And then just go ahead and say continue. And at this point, the client will still be connected to the game. They'll just be essentially in spectator mode at this point. And we'll go ahead and add the same thing for the red team right now. So then we'll just go ahead and change this to red team players. And we're still testing against the max players per team. And just go ahead and change the message to say red team full. Now the next thing we'll go ahead and do is actually adjust this spawn position depending on how many players are on the actual team. So we can say spawn position plus equals, and then we'll go ahead and look into our spawn offsets. And then the index that we're going to use is our team player counter dot blue team players. And then we can do a dot value on that. And then the last thing that we want to go ahead and do is do our team player counter dot blue team players and increment that. And then again, we're going to do the same things here for the red team as well. But this time, instead of looking at the blue team players, of course, we want to look at the red team players and go ahead and increment the count for the red team players. Now, a very important thing that we need to do is when we increment this value on the team player counter, it doesn't actually change the component. We need to actually set it on the singleton. So we can come down here to where we're doing our ECB.playback. And then after this, we can just do a system API.set singleton. You can go ahead and just pass in the team player counter, and then it will update that singleton automatically. So let's come back to Unity and do a little bit of testing and make sure everything's working. I'm actually going to go ahead and set max players per team to a value of 1. And that's just so we can test to make sure that we can't spawn more than the max number of players per team. So of course, to test it out, we'll go ahead and create a build of this. Okay, so over in Unity, we'll just go ahead and get a player connected to the blue team here. And I will go ahead and open up a build of this here. We'll set connection mode, of course, to our client. And then let's go ahead and try to join the blue team. So you see that it actually does not allow us to join the blue team. And if we come over to Unity, over here we get a message saying server assigning client to the blue team, server assigning client 2 to the blue team. We should probably change this debug message here a little bit, because then immediately after that one we do get one saying blue team is full, client ID 2, spectating the game. So maybe we could say client 2 is requesting to be on the blue team or something like that. Anyways, we'll just come back to our game start properties. Let's change this max players per team back to 5 and save it and enter the game. Luckily, we don't need to change anything in the build because all that stuff is basically kept track of server side. So we can just use the same existing build. This time we'll go to client mode and try to join the blue team. We'll say start client, and then we see that we do spawn, and we do spawn at an offset. And then if we were to say to continue to connect more clients, let's go ahead and join another one here. We could change this to client mode and blue team and connect. Now we will join up in this offset over here, and yeah, that should continue happening, and we can probably confirm that this happens on the red team as well. Let's just go ahead and spin up a whole bunch of these guys here. So we'll go ahead and set this to client mode, and we'll even do this auto assign team. So this should automatically assign us. Oh, so the auto assign team, I actually forgot that this is only assigning us to the blue team. So we do need to remember to take into account the different team countings to assign them to the correct team. So I'm glad that I did that, or else I probably wouldn't have remembered. So anyways, clients, and we'll go ahead and go to the red team. So we do spawn there. And again, we'll do client mode on the red team, and we start the client at an offset here. Okay, perfect. So we've got a bunch of clients connected, and let's just go ahead and close out all these guys here. And you do see that they automatically clean up, which is great. So let's go ahead and check out that auto assign here. So yeah, so if it's requested team type is equal to auto assign, then I'm setting requested team type equal to blue. So, but we can just do a quick little if else statement here and figure out which team has less players, and then we'll assign us to that team. And let's just go ahead and Control X this. and go ahead and move this after our little switch case here. So now this should appropriately send our debug messages depending on which team they're properly being assigned to. Now, in order to test this, we will need to create a new build of that. So I'm going to go ahead and run this now. Okay, so we'll go ahead and start up Unity, and we'll do an auto assign team, and we get the blue team, and then we'll open up a build. We'll go ahead and connect a client with an auto assign team, and boom, we are in fact on the red team. And then we can confirm that if we go ahead and add another auto assign client, it will add this one to the blue team. So it should just go back and forth between the blue team and the red team if the numbers are pretty much even. Otherwise, it's going to go ahead and assign it to whichever team has fewer. Okay, so that's all looking good. However, at this point, we're not actually doing any waiting for that minimum number of players to start the game. And basically, as soon as the player enters the game, they're still able to send inputs, and then the minions are going to start spawning and everything like that. So we're going to go ahead and just add a notion of a game playing tag, and then we can add that as a required component for any of our systems that we don't want to execute before the game is actually started. So we can come over to the common directory, and we'll go ahead and add just a new class here. We can call this the gameplay components, and of course just take out the default class thing here. So all we'll go ahead and add for now is a public struct for the game playing tag. And this of course is a regular iComponent data, doesn't need to be a ghost component or anything like that. So for example, we can say go over to the champ move input system, and inside the onCreate here, we can do a require for update and pass in the game playing tag. Now this is system based, so we can do it that way. And then we can do this for a bunch of other systems too. So for example, say on the champ move system, this one is an I system. So here we'll actually have to head and create an onCreate because we don't have one of those yet. And we can just do a state.require for update, passing in the game playing tag. So I can go ahead and just copy this here. And so I'm just going to add this to a bunch of systems. I'm just going to read off the names of these as I go through. I'll add this to the ability input system, the apply damage system, the move minion system, the NPC attack system, and finally the spawn minion system. So we can come over to Unity. We'll go ahead and enter the game here. You see that we are assigned to the blue team. However, we can't actually move around, and we'll wait a couple seconds when the minions should spawn, and we're seeing them not spawn. So we can basically confirm that if we don't have this game playing tag, then, well, the game isn't actually playing. So the next thing that we're going to go ahead and do is start controlling a little bit of the UI stuff. So we're actually going to have a message pop up on the screen saying, how many players are left to join the game. And then once that minimum player count has actually been reached, then it's just going to go ahead and do a 3, 2, 1 countdown, and then it will actually begin the game, and then we'll be able to enter our player inputs and everything like that. Now, not going to lie, things are going to get a little bit complicated at this point. Basically, what we're going to end up doing is in the server side, we're going to be sending some RPCs from the server to the client, basically whenever a new player joins the game. So that way we can update the UI counter for all the players who are already in the game to display the current number of players still remaining to enter the game before the game starts. And then once that number has been reached, we're going to go ahead and send another RPC, and we're going to pass along basically the target tick of the server time of when the game should start. So we'll come back to the script here that we've created for RPC components, and we're going to go ahead and add in 2 more RPC components. So we'll do a public struct. This one will be the players remaining to start, and this again is an IRPC command. And we'll have a public int value here. Then here we'll go ahead and do another one, which is the public struct. We'll call this the game start tick. This is well going to be an IRPC command, and this will have a public network tick value. So now back in the server process game entry request system, after we go ahead and actually spawn our champion and set all the values of it, this is basically going to be the last step of this for each here. First, we're going to go ahead and calculate the players remaining to start. And we can get this from our game start properties dot min players to start game minus the team player counter dot total players. And then from that, we'll go ahead and create a game start RPC entity. So we'll do an ECB dot create entity. So we'll do a quick if statement in here saying if players remaining to start is less than or equal to 0 and exclamation mark system API dot has singleton, and we can say game playing tag. So basically if the game is not already playing and the players remaining to start is now less than or equal to 0, that means we know that we can actually send the RPC to the clients saying, hey, let's actually start the game. So again, this RPC that we're going to need to send is essentially the target network tick of when the game starts. So first we need to go ahead and calculate that. So first we'll go ahead and get the simulation tick rate. And again, we can get that from our netcode config.global.client server tick rate.simulation tick rate. And then we can say the ticks until start is equal to, we'll cast this to a UINT, and then we'll do our simulation tick rate multiplied by the game start properties dot countdown time. And then the way that we actually figure out what tick that is going to be is we take the current tick and then add the ticks until start. But again, the way that we do that is we can say game start tick is equal to system API dot get singleton network time dot server tick, and then we can do a game start tick dot add, passing in ticks until start. And of course we can add the require for update on the network time. So then here we can do an ECB dot add component, and we'll do this on the game start RPC, and this will be a new game start tick. And the value, of course, is going to be the game start tick network tick value that we've just calculated here. So this sends an RPC to the player when the game should begin. However, let's also go ahead and do the else case. And this would be for when, say, a new player joins. We just want to go ahead and update that counter of how many players are remaining to actually join the game. And all we need to do here is do an ECB.add component, again on the game start RPC. And this will be a new players remaining to start. And then the value is this players remaining to start value, which we calculated a little bit earlier. So this one is pretty easy to do. And the last thing that we just need to remember to do, because these are RPCs, we need to do an add component and add the send RPC command request, and of course add that to the game start RPC. So next up on the client side, let's go ahead and actually receive these RPCs and process them accordingly. So I'll go ahead and create a new system base system. The reason is because we're going to be actually sending some events from this system. So let's just go ahead and define what those events are now. So we'll just have a couple public system actions, one which takes in an int parameter, and this is on update players remaining to start. So when we receive that RPC saying, hey, we still need 4 more players, then we can send this event to update our UI appropriately, as well as the on game start countdown, which basically means that we want the countdown to begin. And this one doesn't take in any parameters or anything like that. I should also mention that this system is only running on the client side. So first things first, let's just go ahead and create a new local entity command buffer. We can use allocator.temp here. And then you'll see that we'll create a for each here, and we're querying for anything with this players remaining to start. You'll remember this is the IRPC command that we're sending from the server. And we also do need this withal receive RPC command request. And then we do need entity access to that, because the first thing that we're going to go ahead and do is just destroy that entity. And then we can basically just invoke our event where we say on update players remaining to start dot invoke. And then we just pass in the players remaining to start dot value, just whatever we're getting from that RPC. So pretty basic thing right there. And then we'll do the same thing with our game start tick RPC, basically just destroy the entity and invoke the on game start countdown. Now what we're actually going to end up doing is keep track of what this game start tick is in a component, and then we're going to have a separate system which is actually going to update that countdown timer. And just don't forget to do an ecb.playback entity manager. So back in the gameplay components, we'll create a public struct, and this will be countdown to game start. And this will be an iComponent data, and this will be a public network tick, and just call this value. And you know, I want to call this game start tick, but I'm not going to be able to do that because that's what I named the RPC component. So let's go ahead and rename this game start tick to game start tick RPC. So then back here, we can just call this the game start tick. So now in the client game start system, we'll go ahead and create a new game start entity and just go ahead and add a new game start tick to that entity. And we'll set the value to the game start tick, which we're getting from the RPC. Now, an important thing to note is this game start tick entity is only going to exist on the client side. However, we do want this to actually exist on both the client and server. So the server has some idea of when the game should actually start, and it can add that game playing tag on the server side. And we can actually just go ahead and do this in this server process game entry request system. And so this will basically be the first start part in this if else statement, where basically right after we're creating this game start tick RPC, we can just go ahead and do basically the same thing where we're just creating a game start entity and adding a component of the game start tick here. So next thing that we're going to go ahead and do is actually create a system that does the countdown. And this is going to do a couple of things. Not only is this going to basically determine how many seconds are left until the game starts to update the UI, but also when that countdown is expired, it's going to go ahead and spawn a game playing entity. And we want this to spawn on both the client and the server. So we're going to do this in a predicted system. So we'll just go ahead and go to common and add a new class. This will be the countdown to game start system. Of course, is a public partial class, and this will implement system base. And we'll go ahead and update this in the predicted simulation system group. So again, it's going to run on both the client and the server. Now there will be a couple custom events to run. So this will be the on update countdown text, as well as the on countdown end event. And even though the events basically only apply client side, if we're invoking them on the server side, it's not really going to do anything. So it doesn't really matter that this is running in a predicted system. Okay, so we'll just go ahead and start up a couple things here. So get a reference to our network time singleton, and we'll go ahead and just do this check for the network time.IsFirstTimeFullyPredictingTick. If it's not, just go ahead and return out of here because we only want this to run the first time it's fully predicted. And we do want to know the current tick that we're operating on so we can basically tell if that countdown is expired or not. Of course, we'll just have a local entity command buffer, which we can play back at the end here. Now in between here, we'll go ahead and create our for each system API.query, and we'll look for that game start tick. And of course, we'll want to do a dot with all simulate, and we'd like to have entity access on here. So we can call this game start tick and entity. So first we'll just do a check here to see if the current tick dot equals game start tick dot value, or if current tick dot is newer than game start tick dot value. If that's the case, then basically we know that the game should be started at this point. So we'll go ahead and create that game playing entity. We can do an ecb.create entity, and then we can just go ahead and set a name on that for the game playing entity and add that game playing tag to the game playing entity. Next up, we'll just go ahead and do an ecb.destroy entity on this current entity because we are no longer counting down, so we don't need to worry about this entity anymore. And then we can do the on countdown end dot invoke because we're doing the dot. Basically, if no events are subscribed to it, it's not going to throw an error. So again, there's no issue running this on the server. So we'll just go ahead and also do an else here. So this would be if the countdown is still active. We can calculate the ticks to start by getting the game start tick value tick index for valid tick, and we can do minus current tick index for valid tick. So again, that's how we can kind of calculate the difference in integers between these different ticks. Of course, need our simulation tick rate, and we can get that from the netcode config.global.client server tick rate.simulation tick rate. And then here we can actually calculate the seconds to start, and we can cast this to an int, and we'll do a math.ceil for math.ceiling, passing in we'll cast ticks to start to a float and divide that by the simulation tick rate. And then finally, we'll do the on update countdown text and invoke, passing in the seconds to start. So this should basically call the event to update the UI. We also want to make sure that we just add in the onCreate, the require for update network time. So you see, if we come back over to Unity and enter play mode, we still can't move around when the game starts. However, if I do go ahead and connect a client, you'll see that we can't move for the first, say, 3 seconds until that countdown has exited. And then we'll actually go ahead and be able to move around. And same thing, we should be able to move around in this one now too. And we do see that the minions are beginning to spawn as well. Now at this point, even though the countdown is happening in the background, the player doesn't actually have any way to see that. So that's the next thing that we're going to go ahead and implement now. So here I have this game start UI controller, and this is pretty much just basic UI stuff. So I'm not going to go too into detail on this. But of course, this will be included with the full project files and all. So we have this game start UI controller. We have references to some of our panels, buttons, text elements that we're setting up. The only like ECS related things are this network connection query and of course the entity manager. So we just go ahead and get our entity manager using the default game object injection world, and we can create this network connection query, which looks for this network stream connection here. And that's going to be helpful for when we actually need to go ahead and disconnect our entity. Again, now we're just going to go ahead and find the client start game system. We'll listen into those events, and same thing, we'll also look for the countdown to game start system. And again, we'll listen to the events that we have set up on there already. On disable, we're just kind of doing some cleanup, removing listeners from the buttons, as well as unsubscribing from the events. Make sure we're unsubscribing to the events from both systems here. Just had to add that in real quick. And then, just basic stuff like updating some different text elements. We have some kind of quit logic here. The kind of one unique thing here is we have a little bit of a disconnect delay. So after we actually confirm the quit, it's going to go ahead and just wait a second before it actually goes ahead and disconnect. There must have been some issue with that I was noticing, and I had to put in a little bit of a delay. So yeah, but this basically just goes ahead and disposes all the worlds and just loads our regular scene so the player can queue up for another game if they want to. And then again, just some regular kind of UI stuff here at the end. So coming back to Unity on this HUD canvas, let's go ahead and add in the game start UI controller. We can go ahead and drag in references for the begin game panel, the confirm quit panel, the countdown panel. The quit waiting button is going to be on the begin game panel, and it's just the main menu button here. The confirm quit waiting is on the confirm quit panel, and then we have the confirm quit button, as well as the cancel quit button. The waiting text is on the begin game panel, waiting text, and then the countdown text is under the countdown panel, which is just this countdown text here. So you see now when we actually go ahead and enter the game, it'll say waiting for one more player to join. And of course, if we want, we can go back to the main menu. And so that all works just fine. So we'll come back here, and then we'll go ahead and get a client connected, and we'll see that it says game starting in 3, 2, 1. And then immediately once that time has expired, we can now move our players around. You can see that that UI did display on both the clients here. We do have the minions spawning, so it looks like that game start logic is working. Now there are only 2 final things remaining that we're going to implement in this project. One is going to be player respawning. So when a main champion dies, they'll just be respawned after a couple seconds back at their start position. And the other thing is the game over logic. I'm going to go ahead and implement actually the game over logic first, because that one's going to be a little bit easier to implement. And it uses some similar concepts to some things in the respawn system that we'll be doing after that. So basically the way that this game over logic is going to work is on each of the bases, we're going to have a tag that just says game over on destroy. So basically when that base is destroyed, then the game will be over, and then we'll have a little bit of logic inside our entity destruction system where we say, hey, if this entity that we're trying to destroy has this game over on destroy tag, then we'll go ahead and actually create a new entity with a game over tag, and then we'll also assign a value with the winning team inside that, so then we can have some extra logic to play to pop up and say, hey, you know, red team won, blue team won. So we'll come back to our gameplay components and we'll go ahead and create a public struct here. This will be the game over tag, and this is just an I component data. And then we'll also want a public struct winning team. And this is as well going to be an I component data. We'll have a public team type value. And this in fact will be a ghost field because we do want to synchronize this winning team across the network. Now, because this is a ghost component, we basically have to add this to a ghost entity. So what we're actually going to do is create a prefab of this game over entity. And then that way we can, you know, have the game over tag and the winning team, and it will go ahead and synchronize that data as needed. So just have this game over entity authoring, and inside the baker, we're just getting a entity with no transform usage flags, and then adding a game over tag and winning team component to it. Back in Unity here, go ahead and create an empty game object. We can call this our game over entity. And for the components, we're going to want to go ahead and add a ghost authoring component. Let's go ahead and set a importance of this to 100 and make it predicted. And it's yelling at us because it's not a prefab. So we'll drag this over into the prefabs folder. We can delete the one out of the scene because we no longer need that. And then finally, just go ahead and add on the game over entity authoring, and we don't need to set any values on there. Next up, come back to our combat components, and we'll go ahead and create a public struct game over on destroy tag, which is just an empty I component data. And of course, we'll just go ahead and create an authoring component so we can add this to our bases. So come over to the base prefab and then go ahead and add a game over on destroy authoring. Of course, don't need to set any values in there. So inside the destroy entity system, we're only going to be running these steps on the server side, but we'll say here if system API.has component passing in the game over on destroy tag for the current entity. If that is the case, then we're going to want to go ahead and spawn one of these game over prefabs. Now, of course, we need a way to reference this game over prefab. So come back to MOBA prefabs. We'll go ahead and add a new public entity for the game over entity. And we do need to add this back in the MOBA prefabs authoring as well. So we'll have a public game object for the game over entity, and then make sure we set that inside here as well. And we can set the transform usage flags to none because it's again a data only entity. So here we'll get a reference to the game over prefab by doing a system API.get singleton on our MOBA prefabs. And of course, we want the game over entity from here. We'll add the require for update. Now the actual game over entity is going to be equal to ECB.instantiate, passing in the game over prefab. After that, we need to figure out what team actually won the game. So we can do that by actually getting the losing team by doing a system API.get component of MOBA team from the current entity that we're trying to destroy. So we know that that team basically lost, and then just do a dot value at the end. So then we can basically infer that the winning team is equal to the losing team. If this is equal to the blue team, then we'll return team type dot red Otherwise, we'll return team type.blue. And if we want, we can just do a little debug.log in here saying winning.toString team1. And then finally, we'll just need to do an ECB.setComponent on the game over entity of a new winning team, and then set the value here equal to the winning team. So let's come back to Unity and test this out. First things first, I'm going to go ahead and just go to the game start properties and change max player or min players to start game down to 1, and then also go to the prefab container and drag in the game over entity here. And you know what? I'm just going to go ahead and go to the champion prefab and let's go to the champ authoring and let's change its move speed up to say 10 for now, so we can get to the other side of the map a lot quicker. Okay, and then so we can come over here and let's go ahead and actually just destroy this base. It should take just a couple hits of each of these spells here. So we do see that the base gets destroyed, and if we check in the console, we get blue team 1. So that is exactly what we would like to see. Now the final thing that we need to actually do to complete this is to just pop up with some UI on the screen saying blue team 1. And we also want to destroy that game playing entity so that, all our systems stop running so the player can no longer, submit any movement input or anything like that. So to do that in the common, I'm just going to go ahead and add a new class. This will be the game over system, and this is going to be a public partial class deriving from system base. And the reason that we're doing a system base is because we want to have a event here for on game over, which passes along the team type. Now we're only going to want to run this on game over system if this game over tag and this game over playing tag both exist. Otherwise, we're not going to execute this system. So what we can do first here is just go ahead and get this game over entity, doing our get singleton entity with the game over tag. And then from that, we can figure out what the winning team is by doing a system API.get component against the winning team. And we just pass in this game over entity, get the actual value from that. So then here we can actually invoke the event passing along the winning team. And then we'll go ahead and get the game playing entity from the system API.get singleton entity against the game playing tag. And then just go ahead and destroy that entity right there. Now the system should no longer update, but just as a safe measure, we can just go ahead and set the enabled property equal to false, because we really only want this system to run one time here. So now on the client side, I'm just going to go ahead and create a game over UI controller. This is just a regular mono behavior. Again, I'm going to go through this pretty quickly because this is just regular Unity UI stuff. So we have a reference to our game over panel, which is going to pop up on screen when the game is over. And we also want a reference to the game over text so we can say which team actually won. And then we have buttons for the return to main menu, as well as we want to give the player the ability to immediately rage quit from the game over screen, because that's the point where they're going to be most frustrated and want to smash that rage quit button. So it's really important that we have that in there for, reasons. We have an entity query for the network connection query because we do use that for something later on here. See that in on enable, we're just go ahead and setting events for the different button clicks, as well as creating that entity query. And with the game over system, we can just do a get existing system managed for that game over system which we just created, and then we can listen to that on game over event. And in which case we'll invoke that show game over UI. So here's just setting up the different buttons for the return to menu as well as rage quit. So we just do an application.quit, very important that we add that feature for our players. The on disable, again, we're getting that game over system and then just unsubscribing from that event. And you can see that here, all the show game over UI does is just enable that game over panel and set the text on it. So on the HUD canvas, let's go ahead and add that game over UI controller. The game over panel is going to be that guy right there. The game over text is going to be that guy there. Return to main button is the main menu button, and the rage quit button is the rage quit button. Okay, so now let's go ahead and enter the game, and we can go over to the red base, and we'll go ahead and destroy this base here. Boom, and when we do that, we get blue team wins. You'll see that we can still move around, so we can no longer actually click to move the player around, but we can move the camera around. and we can see that basically all the minions are just kind of frozen in place there. And same thing for both teams. So basically the game is kind of in like a game over state, and it's not going to continue to like, simulate the actual stuff in the game. And of course we can return to the main menu, and then, we're back at the main menu, and if we want, we can start a new game, and this new game should just work no problem, where we can still move around, and it should start spawning minions any moment now. And here come the minions. All right, so now we're going to implement champion respawning. Now this one is a little bit weird because we have to do some kind of weird hacks with the network and everything like that. Basically, we just have to set up a couple extra component references to keep track of a few things. But the idea here is that we're at the beginning of the game going to be spawning a respawn entity. And this will have basically a dynamic buffer queue of all the different champions that need to be respawned. And then so from that queue, we can basically determine, when an entity should be respawned, and then go ahead, of course, spawn it in the game. And then if it is our local champion, then we're also going to want to display some UI on the screen for how long left until the player actually spawns. So first, under the common directory, we're going to go ahead and add in some new components, and these will be the respawn components. So the first is just going to be a tag for our respawn entity, so we can easily get a reference to this entity. And the next step, we'll create our respawn buffer element, which is an iBuffer element data. And it's gonna have a couple fields on here. So one is the network tick. So this is the respawn tick of when we should actually respawn that particular entity. We do need a entity reference for the network entity associated with that particular champion, because again, each champion is going to have a unique network entity associated with them. So when we actually respawn them, we need to set up the appropriate network entity references. Now, we were already doing this when we initially spawn our champion in the server processing system, because we have that from the RPC request. And then finally, we do just need to keep track of the network ID as well. And you see that these are all ghost fields because these will be synchronized across the network. Next up will be the respawn tick count. So this is an unsigned integer for, how many ticks it's going to take to respawn a given champion. And the way that I'm doing it for this particular project is this is just going to be a static value that's not going to change throughout the duration of the application, so it doesn't need to be a ghost field or anything like that. So here I'll just go ahead and create a respawn entity authoring. You'll see that inside the maker here, we're just going to get an entity with a transform usage flags of none. We'll add that respawn entity tag. For our respawn tick count, we'll calculate that by taking the respawn time, which we get from the authoring, and then multiplying that by the simulation tick rate. Again, we can get that by referencing our global netcode config, which we will just have to drag in a reference over in Unity. And then finally, we can just add an empty dynamic buffer of these respawn buffer elements. So come over to Unity and we'll create an empty game object. This will be the respawn entity. On here, we can go ahead and add a ghost authoring component. Again, this is going to be a ghost here. We'll set, say, an importance of 10 and this pre-predicted. And then we'll also go ahead and add the respawn entity authoring. The respawn time is going to be a value of 10 seconds. And we'll set the netcode config there. And then of course, we'll just go ahead and drag that as a prefab and delete it out of the main scene. Now, before we create the actual respawn system, we do need to add a few more components. So the first is a player spawn info. Now we're going to store this actually on the client network component, and that way we can basically use that to reference what team this client should be on and where we should spawn it. And we also will need a network entity reference, so we can have a way to reference our network entity from our client. Now we should go ahead and set these up in the server process game entry request system. So we'll go ahead and do this after we're spawning the new champion entity, but before we do all this, player remaining stuff here. So basically after this ECB.append to buffer, where we're adding to this linked entity group. So this should be a good place to do this, where we want to do an ECB.set component. And we're gonna go ahead and set this on the new champ, which would be a new network entity reference. And the value is going to be request source.source connection. And then similarly, we're going to do an ECB.add component to the request source.source connection. And this will be the new player spawn info. And so here we can set the MOBA team equal to the requested team type, and the spawn position is equal to the spawn position that we've calculated. And one last thing that we need to do is we need to actually add this network entity reference to our champion. So just back in the champ authoring, we can do a simple add component and add that network entity reference. So now inside common, we'll go ahead and add a new class for the respawn champ system, and this is going to be a system base that runs in the predicted simulation system group. The reason is because we're going to have some events in here to do some UI things. And so while I brought it up, might as well talk about these. So we have the on update respawn countdown. So this is basically, we're going to pop up with a message on the screen saying, respawning in 10, 9, 8, 7, 6, da da da. And so we're just going to go ahead and update this with the current integer. And then also going to have a public action for on respawn. So when the player actually respawns, we know when to hide that UI. So before we get to on update, we'll start in the on start running. And so first we'll just check to see if this respawn entity tag already exists as a singleton. If it does, no need to proceed any further. We'll just go ahead and return out of it. But if it does not, we'll go ahead and instantiate a new one of these respawn prefabs. And we do need to add this to the MOBA prefabs. So we can come over to the MOBA prefabs, add a public entity respawn entity, and then come back over to the MOBA prefabs authoring, make sure that we actually set this respawn entity here, and then add that as part of the MOBA prefabs components. So then come back over to Unity inside the prefab container. Make sure we just go ahead and drag that respawn entity into the respawn entity field. And again, coming back to the respawn champ system, we just know that this will actually just go ahead and add that respawn entity at the beginning of the game. So now that we actually have the respawn entity instantiated, let's go ahead and actually add respawn elements to it when a champion is destroyed. So we can go after this system API has component game over on destroy tag. And we're going to do something very similar where we say if system API.has component champ tag, and we're going to be, of course, passing in the current entity that we're on. We'll first get a reference to the network entity, and we can get that from the system API get component network entity reference, again from the entity dot value. Next up, we'll actually get the respawn entity by doing a system API.get singleton entity with the respawn entity tag. And we can add the require for update if we'd like. So here we can say the respawn tick count is equal to system API.get component respawn tick count off of the respawn entity dot value. So we'll calculate the respawn tick by getting the current tick and then doing a respawn tick dot add respawn tick count. Then we can do an ECB dot append to buffer, and we're going to be appending this to the respawn entity. And we'll do a new respawn buffer element. And here we can set the values for the network entity equal to network entity. The respawn tick is equal to the respawn tick. And the network ID is equal to system API.get component network ID off of the network entity dot value. So basically what this means is that anytime a champion is destroyed, we're just going to go ahead and add this to the respawn buffer, and we have this respawn buffer to keep track of all the current champions who are essentially on respawn. So the champion itself is destroyed, but we now have some data stored in this dynamic buffer so that we know at a certain point of time which entity should get respawned, and then so we know how to look up the appropriate data values of where to spawn it, what team to spawn it on, and all that. So then we'll come back to the respawn champ system. We'll just start doing some things in the on update here. So we'll get a reference to our network time because we will need a reference to the current tick. And we also just want to go ahead and make sure that we're only running this the first time that we're fully predicting this tick. And then we're going to do a couple things where we differentiate between code running on the server versus not. So just go ahead and store a convenient variable there for that. Next up, we're going to be using a local entity command buffer. So just go ahead and define that using allocator.temp. and then make sure you play it back at the end. Now in between here, we're going to go ahead and do our idiomatic for each. We're going to query for anything with the dynamic buffer of type respawn buffer element. And we can also do a dot with all, passing in the respawn tick count as well as simulate, because this is running in a predicted simulation system. And so we can just define that as respawn buffer and do a little cleanup here. So inside this for each loop, we're going to go ahead and create a regular for loop, and we're going to do this because we need a reference to this index a little bit later on. But we'll just iterate through everything in this respawn buffer. And then so we'll just say the current respawn is equal to respawn buffer at I. So here we'll go ahead and check if current tick is equal to the cur respawn.respawn tick, or if current tick is newer than the cur respawn tick. So that means that we know that this is time to actually respawn this entity. So the spawning of the entity should only happen on the server side. So we'll say if is server, and we're going to go ahead and actually add in our respawn logic here. However, I'm just going to real quickly do an else. So this is anything that's happening on the client side. We only need to do one thing here, which is just do an on respawn dot invoke. So this basically just invokes the on respawn, and we'll listen to an event later to basically just disable the respawn UI. So anyways, back on the server side, we'll get a reference to the network ID. And we can get that by using the system API get component network ID. The entity that we're going to get this off of is something that we've stored in the cur respawn, and we get that from our network entity, and then we'll just do a dot value at the end. So we have a reference to our network ID, and we'll also need that player spawn info, which again we can get with a system API get component player spawn info on the cur respawn dot network entity. So next up, we'll get a reference to a champion prefab using system API dot get singleton MOBA prefabs, and we'll do the champion. So we can say var new champ is equal to our ECB.instantiate, passing in the champion prefab. And here we need to set a couple of components on this new champ. So we'll do an ECB.setComponent on the new champ, which would be a new ghost owner. And we can set the network ID integer to that network ID that we got at the top there. Next, we need to set the MOBA team. So the value of that, we can get that from the player spawn info.moba team. Next up, we need to set the transform position. So we'll do an ECB set component new champ, and we can do local transform.from position, and the position again we can get that from the player spawn info.spawn position. Next up, we'll initialize the champ move target position, so it basically respawns and it doesn't move anywhere, it just kind of stays in place. So we'll say new champ. This would be a new champ move target position, and the value of this is equal to the player spawn info.spawn position as well. Next up, we do an ECB.append to buffer for the cur respawn.network entity. Again, we just need to add this new champion to the linked entity group here. And this is in place so that if a client disconnects, the champion will get destroyed with it. And then finally, we just need to go ahead and do an ECB.setComponent again on the new champ. And then we're going to reset that network entity reference. The value on here is equal to the cur respawn.network entity. And that's so that, our new entity can have, again, reference to that network entity so that, if that entity gets destroyed again, we can set up the proper stuff with that network reference. Okay, so now the next thing that we need to actually go ahead and do is remove this element from this buffer. Just so we, once we respawn an entity, we don't want to respawn it again and again and again. So we're going to have to, remove this element from the buffer. Now, of course, we can't do it inside just immediately right here because we can't, modify the collection as we're iterating through it. So actually before this for loop here, I'm going to go ahead and just create a native list here called respawns to clean up. We'll set this equal to a new native list of integer and just do a temporary allocation on there. So then at the bottom, we can just do a respawns to clean up dot add, and then we can just pass in I. And so again, that's why we had to be using a for loop here rather than a for each loop to iterate through these buffers. So now outside of this for loop, which is right here, we can go ahead and do a for each loop, and we'll say for each in respawns to clean up, say respawn index. We can just go ahead and do a respawn buffer dot remove at, passing in the respawn index. So that'll just go ahead and remove that now from the buffer. Now there's one last thing that we need to do here in this system. And so you see that, the first thing that we're checking for is if the current tick is greater than or equal to the respawn tick. We'll of course go ahead and respawn it. Now we'll just go ahead and make the else case on this here as well. And we're actually only going to want to run this on the client side. So we'll say else if exclamation mark is server. And in here, we're just going to go ahead and trigger the events to update the UI so the player can get a countdown to know when they're going to respawn. So now we're only going to be updating this on the local client. Of course, we're not going to be updating this UI for all clients. So we can go ahead and say if system API dot try get singleton network ID, and we'll say out var network ID. So we can say if network ID dot value is equal to the cur respawn dot network ID, then that's how we know that the current entity that is in the respawn buffer is equal to our actual local client's network ID. In here, we can do something similar to what we did for the begin game countdown, where we just figure out, how many ticks are remaining to spawn, get our simulation tick rate, and determine, how many seconds left are to start. And then we can call our on update respawn countdown. Just go ahead and invoke that, passing in the seconds to start there. And for this respawn champ system, we just need to make sure that we manually put in these require for updates for the network time and MOBA prefabs. So then I'll just go ahead and create another of these UI controllers where we can listen in to some of those UI events. So basically in the on enable, we'll just subscribe to these events. So looking at the respawn champ system, so we'll just go ahead and listen to these events for on update respawn champ countdown. Just go ahead and update that respawn text. And when we do respawn, we'll just go ahead and close that respawn panel. So come back over to Unity and just go ahead and go to your HUD canvas and add the respawn UI controller and drag a reference to the respawn panel as well as the respawn countdown text. So now we can enter the game and just move close to the closest tower on the opposing team, which should be this one right here. And then I'm going to go right here, so hopefully the tower and minions can shoot at us. So then the champion should get destroyed any moment here. And we do see a respawning in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And you see that our champion is in fact respawned. It is just glitching out because I have the move speed set so high, and it basically just can't get to that target position in time. So that's not to worry there. And so we can go ahead and test this out in a build. So I'll set the min players to start to 2. Go ahead and fire up the local client in host mode here and get another client connected here as well. So now we can say bring this red guy over here. And we'll have this red guy get destroyed here. While that's happening, I'm going to go ahead and move the camera over here. We can see the red player gets destroyed. If I move this back into view, you can see that we have the respawn countdown. Let me see if I can get over to the other base in time before the other guy actually spawns. So now this blue character is about to get destroyed, but we can see that back over on the red screen, we can come over here. We of course don't have this countdown UI, but then we do see the blue player go ahead and respawn here. All right, and I know I said entity respawning was going to be the last part of this tutorial, but I actually lied. There is one other kind of bonus thing that I want to add in here, and that is spawning thin clients. I think it's super important to be able to spawn thin clients so we can do a little bit of testing in our game. And the whole idea with thin clients is it basically spawns these dummy clients in our game, and we can have them just basically kind of send random inputs for them to just kind of do random things in our game. Of course, if you want, you can add some, crazy extra AI logic and stuff like that. So in order to actually implement these thin clients, so first we'll go ahead and go to our client directory and go ahead and create a new struct, which will be the thin client entry system. And so we'll just go ahead and create this thin client entry system, which is an I system, and this will only run in thin client worlds, so we can use that world system filter flag there. Now we'll just go ahead and create our on update here. And first thing what we can do is just set state.enabled equal to false, because the system is only going to run one time. It basically just sends a request up to the server saying, hey, can this thin client actually enter the game? So what we first need to do is create a thin client dummy just by doing a state.entityManager.createEntity. And here we can go ahead and add some of the required components to it. So I'll just go ahead and use the entity manager here to just go ahead and add a champ move target position. Next up, we'll need to do an add buffer, and this is an input buffer data type of champ move target position. Again, this champ move target position component is that special I input data component, and we do need to add this extra buffer for thin clients specifically, which we don't have to do for just regular entities. Next up, we'll need to get a reference to the connection entity. You can do system API.getSingletonEntity of the network ID. Of course, we can add this require for update. So next we'll do a system API.set component on the connection entity. We'll set the command target entity equal to the thin client dummy. Next up, we'll actually get our connection ID by doing a system API get singleton network ID value. And so here we can do a state.entityManager.add component data. Again, this will be on the thin client dummy, and this would be a new ghost owner, and the network ID is equal to the connection ID, which we just got. And then finally, we're going to go ahead and create a thin client request entity. We're doing a state.entityManager.createEntity. So then here we can do a state.entityManager.add component data on that thin client request entity. And this will be a new client team request, and we'll set the value equal to team type.autoassign. And then once we have this in place, then our existing client request game entry system is going to take over. If you remember back at the beginning, we set this to work on both client simulation as well as thin client simulation. And it's going to look for anything with that client team request and store that requested team. And this actually goes ahead and creates the proper RPC commands to send up to the server to say, hey, I want to enter the game. Now, in order to get these thin clients to work, there is one important thing we need to do in the server process game entry request system. So we can go ahead and add this, say, after we add our player spawn info right here. So we can do an ECB.set component, passing in the request source.source connection. This would be a new command target, and the target entity is going to equal our new champ. Now this is done by default when we're spawning just like regular champion entities, because there is an auto command target value checkmarked on the ghost authoring component. However, with thin clients, we just need to manually set this here, and there's no harm in just including this as well, because Unity does this stuff for us by default for regular clients. So what I'm going to do is come back to Unity and set minimum players to start game is equal to 10. And then in the play mode tools, we can set number of thin clients to a value of 9. Okay, and then we can go ahead and enter play mode. And I noticed this weird bug where you couldn't spawn thin clients when the game was in full screen. So if you just have it set to play focused and then do start host, then you'll see that every couple seconds it will go ahead and spawn a thin client. So we now have a total of 5 guys spawned over here. And you can see they're just running immediately towards the center, and same thing with the red thin clients as well. So they all just moved towards the center there. In fact, we could probably just kind of, deal some damage to these guys here. And then once we've destroyed all of them, we can come over to the red base and we should see them respawn after just a couple seconds here. So they should just basically act like normal champions as well. So we'll give that a moment. And they don't respawn. Oh, they do respawn. There we go. So yep, we see them go ahead and respawn, and then they're just moving, back down towards the center there. Okay, so of course that's not exactly what we want. We don't want our champions to just all run to the center. So let's go ahead and just create a little bit of random input so the thin clients can just kind of randomly move around the screen. So under client, I'm going to go ahead and create a new struct for thin client input properties. So I have this thin client input properties. This is just a regular iComponent data, not a ghost component or anything like that. We have a public random called random. This is the unity.mathematics random. So we can just kind of generate some random values. We basically just have a timer, which is going to count down for a few seconds. Once that timer is expired, it's just going to go ahead and pick a random position between our minimum and maximum positions here. And then we're also just going to reset the timer to a random value. So we can just go ahead and set minimum and maximum values for that. So these guys are just going to be going to all random positions on the screen. So to initialize these values, of course, we could set up like an authoring component or something like that. But I'm just going to go ahead and do this all in the thin client entry system because it's pretty easy. If we just do a state.entityManager.add component data to this thin client dummy, we'll create a new thin client input properties. Go ahead and set random equal to the unity.mathematics random.create from index, and we can pass in a uint for the connection ID, just so each thin client gets a unique random value. We'll set timer equal to 0, so it'll go ahead and start with a random position off the bat. The min timer is equal to 1 second, and the max timer will be 10 seconds. The min position is a new float 3. We can pass in -50, 0, and -50, and the max position is a new float 3 passing in 50, 0, and 50. So that just kind of initializes the values. Then we need to actually go ahead and create an input system. So this would be the thin client input system, which is a public partial struct implementing iSystem. And we use the world system filter flags to only run this on thin clients. And then we have update in group for the ghost input system group. So this is basically, the same group that we would read input in a regular client. So inside on update, we can go ahead and get a reference to delta time, and we'll go ahead and do our idiomatic for each system API.query, and we're going to go ahead and actually write to that champ move target position. And we also want to write to the thin client input properties. So we can call this move target position as well as the input properties. So we'll say input properties dot value RW dot timer minus equals delta time. And if the input properties dot VRO dot timer is still greater than 0, just go ahead and continue to the next. If it is less than 0, we'll go ahead and generate a random position by doing a input properties dot value RW dot random dot next float 3. Really important that we do this value RW because we do need to actually write back to the input component so we can continually generate random new numbers. And then we'll pass in the input properties dot min position and the input properties dot max position. So then from there we can set move target position dot value RW dot value is equal to the random position. So that actually updates the thin client's input that gets synchronized up with the server. And then here we'll just go ahead and reset the timer. So we'll say input properties value RW dot timer is equal to input properties dot value rw dot random dot next float, passing in the properties read only, min timer, and input properties value ro dot max timer. Okay, so then we'll come back to Unity. I'll go ahead and enter play mode here. We'll go ahead and start the host, and we should see some thin clients join here. And then once the game starts, they should actually start basically going to random places on the map. You'll see that they're moving around. Sometimes they'll reach their destination. Same thing, the red guys are going to be moving around as well. Of course, they're moving around a little bit faster than normally we would like to have them. But again, I just had to increase that input to having a faster move speed to get around the map quicker is nice to have. Anyways, of course, these guys aren't like attacking or anything yet. Of course, we could add some extra logic to make them attack, but honestly, for the most part, just simulating, updating the position just to kind of validate that thing works is basically all we're trying to prove out with these different thin clients. Now it is cool because these are just regular clients, and as we can of course attack them, towers and other minions will start attacking them, so you see that their health actually goes down over time. So yeah, fun times. So that is now actually everything that we're going to be implementing in this massive Netcode for Entities tutorial. Very much hope that you enjoyed it, and I'm going to go ahead and just leave you with a little outro section here. Okay, and so that is it for this Netcode for Entities complete course. I really just want to thank you all for your patience in me getting this ready, because I know it's been a long time coming, a long time in the making, but I do really hope that the wait was worth it. I do hope that you found this video valuable and it taught you a thing or two about Netcode for Entities. If it did, again, I would really appreciate any amount of support that you're willing to give. Even just likes, comments, and subscribes really do go a long way. If you do want to take it the extra mile and share it with some friends or some coworkers or in any online communities that you're in, I would greatly appreciate that. Of course, all financial support is very much welcome. Again, the easiest way to do that would probably be using the super thanks button down below this video. But again, if you do want to support me on a more recurring basis and get some of those extra data-oriented bonuses that I do offer along with my live show, The Hot Path Show, definitely check out the Turbo Makes Games Patreon just at patreon.com/turbomakesgames. So anyways, I want to immensely thank you from the bottom of my heart for watching this whole video and just congratulate you on going through this. Again, I really do hope that this kind of kicks off your Netcode for Entities learning journey, and I'm really excited to see what you all make with this. So if you do have any cool things that you want to share with me, feel free to come by our Discord. You can get to that at tmg.dev/discord, and feel free to share what you're working on over there. So again, just wanted to wish you all the very best, and once again, thank you so much for watching this video. Take care, and I'll see you in the next one.